Good morning, my dear students. Today topic is magnetism and matter. So in this, we have to discuss about bar magnets, cutting of bar magnets and bending of bar magnets, resultant magnetic momentum, and then after what? Magnetic force, magnetic field about bar magnet. Let us discuss. Now, the topic is magnetism and matter. So, I won't go direct details of magnetism, what is the meaning of magnetism, how the magnetism is produced. Direct, let us go for the magnetism about a bar magnet. So, if you take a bar magnet, every bar magnet having two poles, and first pole is I am taking that is a south pole. So, which is having a negative pole strength minus m, and here another pole is the north pole, which is having equal amount of the pole strength, that is the plus m. M is not mass, that is the pole strength of the bar magnet, and the south pole strength can be taken as the minus m, and north pole can be taken as the pole strength plus m, and that is a positive pole strength. And every bar magnet, so we know that in the charges and fields concept, so we know about the electric dipole. So what is the electric dipole? A pair of equal and opposite charges separated by a small distance is called as a electric dipole. Here also every bar magnet having two types of the poles, one is south pole, north pole with the equal and opposite pole strength. Therefore, now we can say every bar magnet acting as a magnetic dipole. But there in the electric dipole, the two charges are different. There is no relation of first charge with second charge. So, both are individual charges or separate charges. But here in case of the bar magnet, so two poles existed at a time. So, if you cut the bar magnet into pieces, each piece becomes individual magnetom. That is why we can't separate south pole, north pole from the given bar magnet, right? No, because every magnet having two types of the poles, wherever if you cut along the perpendicular bisector, or if you cut along the length, each part again becomes a magnet, and each part having the south pole and the north pole. Therefore, this is the introduction. Now, so here if you see the total length of the magnet, for example, I am taking that capital L, this is the end to end. But if you take the length of the magnet is what, or magnetic length is what? So, magnetic length is different and the total length of the magnet is different. So, the total length of the magnet is called geometrical length or geometric length. But so the distance between south pole to north pole is called as the magnetic length. That magnetic length I am taking as small l. Small l is the magnetic length. So, here the poles are not exactly present at the edges, they are present just inside the edges. Means what? This south pole is not present at the edge. So, this is present just inside. That's why. So, the magnetic length of every bar magnet is always smaller than the what that is a geometrical length. Now, so the magnetic length L is always equal to 5/6 times of geometrical length of the magnet. That is the first formula. So, magnetic length is always equal to 5/6 times of the geometrical length. From this expression we can say that. So, what? So, the magnetic length is always smaller than capital L. Therefore, now because the poles are present just inside. And so, next, what is the pole strength here? As I told you, every magnet having the two types of the poles, and every pole having its own strength. So, what is the meaning of the pole strength? It is the power of any pole of a given magnet with which it attracts or repel the other magnet. So, because of this because of this pole strength, it will attract or repel another magnet. For example, near to the south pole of the given magnet, if you bring another north pole of another magnet, then what? The north pole, south pole will be attracted with a force. That force is, let us discuss later. Next, so near to the south pole, if you bring another south pole of the another magnet, now they will be repel each other with some force beta. Therefore, so the power with which the magnet with attract or repel other magnet is called as the pole strength, and the pole strength can be represented by small m nana, and this pole strength SI unit is ampere meter, and it is a scalar quantity. So, not a vector quantity. Pole strength is a scalar quantity. Next, one more is there. What is the magnetic moment? So, what is the magnetic moment here? So, magnetic moment is given by capital M, and capital M is always equal to magnetic length into, so magnetic pole strength. Therefore, this is called as the magnetic moment, and its unit is, you can take ampere meter square, and it is a vector quantity, not a scalar quantity. So, magnetic moment is a vector, and the direction is always from where to where? So, negative pole to positive pole, nothing but south to north pole, right? Now, south to north pole, the direction of magnetic moment. Their formula what? M is equal to L into M. But in some cases, for example, if you take, so this is the center of the magnet. If you take this is center of the magnet, and so center to north pole distance, if you take A, and center to, so south pole distance also, for example, then what that is the A. Therefore, now sometimes L is equal to, also you can take 2 into A, and 2A is a length of the vector. Magnetic length is also vector, and that magnetic length always directs from south pole to north pole of the given bar magnet. South pole, north pole. Therefore, now formula, so M is equal to L into M. This also, if you take A plus A as a 2A, therefore now you can say that is what? 2A into M, and the SI unit is what? South to, that is what? Ampere meter square, and it is a vector, direction always from south to north pole. Therefore, this is the small basic information related to what? So, related to, so bar magnet concept. Now, cutting off a bar magnet, let us discuss. Now, in this topic, let us discuss cutting off a bar magnet. Cutting off a bar magnet. Cutting off a bar magnet. For example, there are the two cases are there. If you cut the magnet along the length, what happens? Let us discuss. So, before that, now I am taking that, for example, here one bar magnet I have taken, right, and the initial magnetic moment I am taking that M, and initial length is L, and initial pole strength is M nana. So, capital M is the initial magnetic moment, L is the initial magnetic length, and small m is the initial pole strength. Now, we are cutting into two pieces. For example, along the length, first case what? If you cut along the length, now first case I am taking that along the length. Along the length, if you take, then what happen? So, along the length does not change, because, so after cutting this upper piece becomes one magnet, so bottom piece becomes one more magnet. So, what is not changing? Because we are cutting the magnet along the length. Along the length means length does not change. Therefore, now the new length is L dash is equal to L only. But what about the magnetic moment, magnetic pole strength M dash is equal to, when you are cutting into two pieces, so magnetic pole strength purely depends upon the area. So, this is depends upon the area beta. Now, what? When you are cutting, so along the length, this area of cross section becomes what? A by 2. Therefore, so this becomes A by 2. This area of cross section also becomes what? A by 2. So, when you are cutting the magnet along the length, the area of cross section of the magnet becomes into two equal pieces. Therefore, now here magnetic moment is always directly proportional to area of cross section. Therefore, when area of cross section becomes off, the magnetic moment also becomes what? That is equal to M by 2. Now, what is the new magnetic moment? The new magnetic moment is equal to, so new length into new magnetic pole strength, that is equal to L is L only, M is what? Of M by 2. Therefore, but you know that, so here what is the initial magnetic magnetic moment? Initial magnetic moment M is equal to L into M. Before cutting, the initial magnetic moment is equal to L into M. Therefore, now L into M you can take what? Capital M by 2. Therefore, when a bar magnet cuts along its length, so into two pieces, now length does not change, magnetic pole strength becomes off and magnetic moment also becomes off. So, this is only two pieces we have cut. But if you cut into n pieces, if you cut into n equal pieces, if you are cut into n equal pieces, now L dash is equal to L only and M dash is equal to M by N, because when you cut into two pieces it becomes M by 2, when you cut into three pieces it becomes M by 3, when you cut into four pieces it becomes M by 4, therefore M dash is equal to M by N. And so similarly what we can get now, M dash means the new magnetic moment is equal to new length into new magnetic pole strength is equal to, after simplification, Lm by N, that is equal to M by N. Therefore, finally, when a bar magnet cuts along its length into n equal pieces, length does not change. I mean magnetic length does not change. Magnetic pole strength becomes M by N, small m by N, and magnetic moment becomes what? Capital M by N. But there is no change in the magnetic length does not change. When so if you are cutting along the length. Next, if you cut along the normal to the length, now, this is a bar magnet, let us take, and so this is the south pole and this is the north pole, and we know that the initial length, the initial magnetic moment is equal to, that is equal to L into M, where L is the initial length, M is the pole strength of the each. So what? That is the south pole or north pole I have taken. Now what I am taking, that if you take this is the center, now I am cutting the magnet into two equal pieces perpendicular to its length. Now, right now, so this is the length. If you take a perpendicular to length, I am taking into two equal pieces. Now you know that the length becomes what? Now the length, this is becomes L by 2. This also becomes what? L by 2. Therefore, so when you cut into two pieces perpendicular to its length changes. But we are not disturbing the area of cross section. So here the area of cross section is the same before cutting and after cutting off. Also area of cross section of each part is the same. So area of cross section is not divided. Therefore, now we can say so magnetic pole strength in this case is the same. Now, so when you cut the magnet normal to the length or perpendicular to length, normal to the length or perpendicular to length, then what? So the length M dash is equal to becomes what? That is the no change, and L dash is equal to L by 2, and the new magnetic moment is equal to, so new length into new pole strength, that is equal to, so L by 2, so into what? That is the M, and finally Lm by 2, that is equal to M by 2. Same in the, as we discussed along the length, in the same way if you are cutting into n pieces, n equal pieces like this, therefore now what? First pieces like this and all are equal pieces. If you are cut into n equal pieces now, so there is no change in the magnetic pole strength. M dash is equal to M, and the length becomes what? L dash is equal to L by N, and the magnetic moment becomes M dash is equal to M by N. This is a story, remember like that. Therefore, when you cut perpendicular to the length, so pole strength does not change. The reason is area of cross section is not divided, and the length becomes L by N, and the magnetic moment becomes M dash is equal to M by N. That is a point, right? Now, this is the cutting of a bar magnet. So now, let us discuss one question. And one more point, sometimes they will give like that. Sometimes they will give like this. For example, now, a magnet cuts along the length into two pieces and so perpendicular to length into two pieces. Now, each piece of machama, now each piece becomes now. So, this one. Now, they will ask that, so what is the magnetic moment of each piece? Right now we are cutting into 4 equal pieces, correct? One is so perpendicular and one is parallel. In that case, so what here now the length becomes what now? L dash is equal to L by 2 because we are cutting perpendicular to the length, and so M dash is equal to how much now? M dash is equal to M by 2. In this case means what? At a time when you cut the bar magnet into pieces along the length and perpendicular to the length, now what? Both will be changed. When both will be changed, now what is the new magnetic moment? New magnetic moment is equal to new length into new pole strength, that is equal to L by 2 into M by 2, that is equal to Lm by 4, that is given by so M by 4. Therefore magnetic pole strength of the each part becomes what? M by 4 only, right now. But let us solve one problem, and if it is n to n equal pieces, in the same manner n equal pieces means what? Now so along the length, along the length means what? So M dash changes, M dash is equal to M by X, I am taking that, means what? So along the length, if you cut X equal pieces, or you can take N1 better, so I am taking that N1 equal pieces, and so perpendicular to length, so N2 equal pieces, then length changes, L dash is equal to, so what? That is L by N2 nana. Do you understand? So whenever you cut a bar magnet along the length, so what will be changed? Moment changes, so pole strength changes. Right now, how much it is? M by N1. So when a bar magnet cuts along the length into N1 equal pieces, and at the same time when the same bar magnet cuts N2 equal pieces perpendicular to its length, length changes, L dash is equal to L by N2. Therefore in that case the new magnetic moment is given by M is equal to L dash M dash. After simplification you will get so capital N by so N1 N2, that's it. So now separate we have taken, and combined means what? Along the length and perpendicular to length, at a time we have taken final formula what? So M is equal to N1 by N2 we have to take it. Therefore now let us solve one sample problem on this. Now there is one bar magnet. The bar magnetic pole strength, the initial pole strength, for example I am taking that 24 ampere meter square. So initial magnetic pole strength of a bar magnet is so 24 ampere meter square. It is cut into, so along the length into 4 pieces. Along the length we are cutting into 4 pieces, and normal to length. So normal to length, so into 2 pieces. Then they will ask what is the new magnetic moment? M dash is equal to how much? Right now, so what? So along the length is equal to 4 pieces, and normal to length is equal to 2 pieces. Now we want what? M dash is equal to how much? Now, so here what I am taking that. So let us take that. What is the formula I have given? So new magnetic moment M dash is equal to, just we have discussed that M by N1 into N2. M dash is equal to M by N1 into N1 by N2. So if you substitute, we can get the answer. M is equal to, I am taking that is a 24, N1 N2 that is equal to, so 4 into 2. So now the new magnetic moment is given by, so 24 by 8 that is equal to 3 ampere meter square. That's it. 3 ampere meter square is the new unit. And sometimes they will ask what is the ratio between the final magnetic moment and the initial magnetic moment of the each piece. Therefore now what? That I am taking that M dash by, so M is equal to 3 by 24, that is equal to 1 by 8. That is the ratio which is equal to 1 by N1 N2 only. Therefore this is the ratio between them. And so simple topic, cutting of a bar magnet is very simple. Just along the length, normal to the length, and combinedly just you discuss, you can get the answer. Now bending of a bar magnet. Cutting of a bar magnet completed. Let us go for bending of a bar magnet. Bending of a bar magnet, let us discuss. So what is the meaning of bending? For example, if you take this is the one bar magnet, now you can bend the magnet like that. So when you are bending the magnet like, there are the two cases are there. So one, the bending into the circular arc shape you have to find out. So here one thing I will say, Mama, that is so in case of the any bar magnet, if it is any circular shape or any shape, Mama. So now for example, this one I am taking that as a one bar magnet. So here I told L is what? L is the magnetic length. Magnetic length is always shortest distance between south pole to north pole. Therefore, now what? If you take this is the radius of the circular arc estimate, that is what I am taking that, for example, R. And if you take radius of the circular arc of the given magnet is R, then what will you think of it? As it is a semicircle. For example, if it is a semicircle, you may think that L is equal to, so 2 pi R by 2, because for the full circle, it is that circumference length is the 2 pi R, and it is a semicircle means for 2 to get cancelled. Therefore, you may take that L is equal to pi into R. That is a wrong. Because, so this is if you take a south pole and this is the north pole and this is the shortest distance means what? So this is the magnetic length. L is equal to, this is R, and that is what? That is 2R is the correct answer for that. So magnetic length is the effective length or the shortest distance between the south and the north pole. Be careful for that. Now, so here in case of the bending of a bar magnet, for example, the initial magnetic moment of the bar magnet, I am taking this is one bar magnet, right? This is the one bar magnet, and this bar magnet I am bending like this. So when you are bending like this, right now, so I am taking that here, so one I am bending, therefore this is a bar magnet bending like this, and its center, for example, here I am taking. So now what you can say, its center I am taking here. Now you know that, so this is the south pole and this is the north pole. Now this center makes some angle theta with the south pole and the north pole joining. So initial what? The initial magnetic moment is M. Now the final magnetic moment M dash is equal to how much? So when a bar magnet is bent in the form of circular, there are the two cases. Now what? First one I am taking that. So into arc, into a circular arc. Into a circular arc I am taking that. That is into a circular arc. Means what? So from this one to this one you are turning. Therefore now then what is the new magnetic moment? In this case the new magnetic moment is M dash is equal to, so 2M into sine, so theta by 2. So by what, Nana? By theta. So that is the formula. Remember it. What is that? That is equal to 2M into sine theta. So by 2. So into theta, there is a new magnetic momentum. Right now, and here one more case is there. That is equal to, so 2. Second one is at the center. If you bend at the center of magnet. Center of magnet. So means what? Now this is bending like this. This is the first bending. So we are bending in the, so what, like this. So into a, so circular arc we are bending like this. Now the second one is you are bending like this beta. Now watch. So this is the bending. Right? Now this is, now what? Here this is the angle theta I am giving that. This is the south pole and this is the north pole. Now what? South to north I have taken like that. So in this case, a very simple formula. Now what? The new magnetic moment M dash is equal to, so M into sine theta by 2, that's it. Right now, so that is the what is that magnetic moment when you are bending at the center of the, means what? At the center if you are bending, so that is a conversion of this one. Right now, so these are the, so bending formula. Now let's discuss one question from this. Now the initial magnetic moment of a bar magnet is given by M is equal to, for example, same I am taking that 24 ampere meter square. The initial bar magnetic moment is so 24 ampere meter square, and it is bent at the, in the form of a circular arc of angle made, that is equal to, for example, how much it is? For example, I am taking that 90 degrees now. So I am taking the 90 degrees. Then, so what is the new magnetic moment? M dash is equal to how much? right? No, so we want the new bar magnet theta is equal to, so 90 I have given, right? Now, so let us take this one. Now, what is that answer, ma? M dash is equal to what? M dash is equal to 2m into sine theta by 2 by what? That is the, so theta I have taken. When a bar magnet is bent in the form of a, so circular arc, the new magnetic moment M dash is equal to 2m sine theta by 2. So what? Theta. Here what thing is that is equal to what? So 2 into m value how much I have taken? 24 into sine, so theta by 2, nothing but what? Sine 90 by 2, that is equal to here. So theta what I have given, amma? Theta is equal to 90 degrees. So by forgetting, what will you substitute here? 90 degrees, but that is wrong. So whenever theta is the single function, means without sine, without cos, without tan, without any trigonometric function, if the theta is present, the theta must and should be substituted in a radian, not in degree. So here sine is there. Yes, you can use 90 by 2 or pi by 2 by 2. Because 90 is equal to pi by 2, no? So pi by 4 you will get that, no problem at all. But so whenever the theta is the single, so we should not substitute that degrees, we have to convert into what? So radian, therefore 90, nothing but what, that is equal to pi by 2, I am taking that. Therefore now you can get what? This 2 goes upside, 2 2 is a 4 and 4 24 means what? That is equal to 96. So into sine 90 by 2 sine 45 value, so 1 by root 2. Therefore now what you can get? 96 by, so root 2, and this you can get so 2 into 2 into 48 by root 2. After simplification, the new magnetic moment is equal to what? That is equal to 48 root 2 ampere meter square. So this is the answer for that. Okay, so any arc you can get the answer. Next, now, so this is the one bar magnet. I am not taking the just only straight line model I will take, and this is if you take a south pole, and this is if you take a north pole. Now at the center of the, from the center of the bar magnet, so it is converting into two pieces like this. So it is converting into two pieces. Now that pieces is that first part I made one, so what, circular arc beta, and second part as it is I am taking that. Now, so this is the south pole and this is the north pole. I hope you may understand. So at the center I made like this. At the center, the system means what? First half of the part I bent into semicircular, and the initial magnetic moment of the given bar magnet is equal to m. Now in this case, after converting this straight bar magnet into, so two pieces like that, then what is that? So new magnetic moment they are asking. What is the new magnetic moment after converting like that? So tell me first of all. So this becomes what, when you are making the two pieces now, so this its initial magnetic moment how much now? Its initial magnetic moment I am taking that m by 2, and its is also m by 2 beta. Means what? Here better to take here nana. So here, so this is becomes what? M by 2. Here also I am taking that m by 2 because we are dividing into two equal pieces. Therefore here m by 2 does not change. Therefore before converting this first part into semicircular arc, so what is the initial magnetic moment? M by 2. Now this one we have to find out. Right now, therefore now I will take this is the m1 and this is the m2, and m2 there is no change. M2 is equal to m by 2 as it is because we are not turning into any circular shape, but this first part we are turning into the circular part. Therefore now what? M1 we have to find out first of all. Here m2 is equal to m by 2, there is no change. Now what is the m1? So m1 is equal to formula what, so according to formula, what formula we have given? M dash is equal to 2m sine theta by 2 by what? Theta. From this expression I want m1. So before bending into the semicircular arc, so what is its magnetic moment? M by 2. Therefore now in place of the 2 I am writing the 2, in place of the m I am writing so m by 2. So sine, so theta by 2. So theta value how much? Idu semicircular arc. Semicircular arc means what? At the center, the angle theta is equal to how much? Now the theta is equal to compulsory 180 degrees, that is equal to pi radians. Therefore, if you substitute here sin 180 by 2 by what? As I told you, theta must be in a radian. Therefore, now that is a pi. Therefore, this 2 get cancelled. So m1 is equal to what answer you can get now? So that is equal to sin 90 180 by 2 sin 90 value 1. Therefore, now what? M by pi. So this is the, so m1 is equal to m by pi. Okay. Now, so here it becomes what now? So this is the south to north. Therefore, now total magnetic moment how much? Now the net magnetic moment of the system. So m net is equal to, so that is the m1 plus m2, that is equal to m by pi plus what? M by 2. That's it. That is the answer, because here m2 does not change. I am keeping as it is better. So like this, therefore now very important model, just once you check it like that. So whenever a bar magnet is making into different shapes, we can find out the answer for that. Okay. Now, next, here what I am taking, that same bar magnet. This is one bar magnet I am taking. Now this bar magnet, now at the center I am keeping like this, right now. So first part is I am taking that m by 2, and the second part bar magnet is m by 2. This is the south pole and this is the north pole we have taken. Now it is converting in 2 pieces like that, right? 2 pieces. Right now, now I am taking that. So idu south pole and this is what I am taking that. This is the, so north pole I am taking that. Now this angle, for example, I am giving the 60 degrees. 60 degrees I have given. So what? Here where I have bent? At the center of the bar magnet. Therefore, now it is a magnetic moment we have to find out, that is the m1, and as I told you in the last problem, this is m2 is equal to m by 2, does not change. So only we have to find out m1 value. So how to find out the m1 value? So now what? This is not into the form of a circle or arc. This is the bent at the center. So when it is the bent at the center, so you know that formula what? So m dash is equal to m into sine theta by 2 is the formula for that. Now in that case, now m1 is equal to given by, so because m1 only changes, so in initial value how much? For the first part, for the this bending part, initial value m by 2. Therefore, m by 2 into, so what? Sin theta by 2. So theta value 60 degrees I have given. Therefore, sin 30. Therefore, m1 is equal to m by 2 into sin 30 value 1 by 2. Finally, you will get what? M by 4. And here m2 is equal to m by 2 as it is. Therefore, the net magnetic moment is m net is equal to m1 plus m2, that is equal to, so what I am giving, that is the m by 4 plus m by 2. This you can write m by 4 plus 2m by 4. Finally, the net magnetic moment is equal to 3m by 4 is ampere per meter square. Right? Or we can take 3m by 4 as it is. Okay, na? Therefore, this is the, so bending and cutting of a bar magnet also completed now. Next, resultant magnetic moment. Resultant magnetic moment means combination of two bar magnets when you are combining. So let us see the what is the resultant magnetic moment. For example, let me take, this is the first bar magnet, and so this is the south pole I am taking, it is the north pole, and so its magnetic moment, as I told you, always from where to where, nana, that is equal to south to north, and its magnetic moment I am taking that m1. So I am keeping here one more bar magnet. So this is one more bar magnet now. so here I am taking that this is the south pole and this is the north pole. Now, so here its magnetic moment is also always from south to north and its direction is m2 and the angle between these two magnetic moments, for example theta, I am taking that. So, theta is the angle between the two bar magnets. So, when theta is angle between two bar magnets, we know that magnetic moment is a vector, it is a not scalar. Therefore, already resultant vector magnitude formula in beta r is equal to under root of so m1 square r is equal to under root of a square plus b square plus 2ab cos theta formula use madre. So, you will get the answer. Therefore, now from that formula the net magnetic moment m is equal to given by, so m net is equal to given by square root of m1 square plus m2 square plus 2m1, so m2 cos theta is the formula for that. Right, no, that is a very simple formula. Under root of m1 square plus m2 square plus 2m1 m2 cos theta is the formula for that resultant magnetic moment. Now, so if the theta is equal to 0, theta is equal to 0 means what? So, both are in the same direction. When both are in the same direction, you can say, so what, that net magnetic moment m is equal to m1 plus m2 only you can take, means what? So, like this one. For example, you can keep so one first bar magnet and on this you can take second bar magnet. This is the south, this is the north, this is south, this is the north. Therefore, its magnetic moment is m1, its magnetic moment m2. Therefore, m1, m2 both are in the same direction. Or you can keep like this also, no problem. For example, so side to side like this. Therefore, this is the south, this is the north, this is the south, this is the north of the second one. And for example, this one if you take so m1 and this one is what? That is the m2. And in this case also both are in the same direction. Theta is equal to 0. Therefore, now you can find out in this case, in that case m is equal to m1 plus m2 because both are in the same direction. And next, so if both are in opposite direction means what? So if theta is equal to 180, theta is equal to 180 means what? Magnetic moment is equal to m1 separation m2 we have to take. So what is the meaning of separation? So here I am not taking the minus I am taking the m1 separation m2. If m1 greater m2, then you can take m1 minus m2. If m2 is greater than so m1, then you can take m2 minus m1 in such case. And therefore now what in this the arrangement is the bar magnets are having opposite. Therefore now this is the m1 and below this one I am taking the what? This is the m2 and here this is the south, this is the north. For the first one, it is south, it is north. Therefore, like this you can take that. So when both are in opposite direction, and if the magnetic moments are perpendicular to each other, theta is equal to 90 degrees. Means what? So if you are taking that first bar magnetic moment is m1, second bar magnetic moment m2 I am taking. Therefore, now if the theta is the 90 degrees, now the resultant magnetic moment is like this. Therefore, now here in that case m is equal to under root of m1 square plus m2 square. That is the so second resultant magnetic moment of the combined element. Therefore, now here let us discuss some questions. Now let us discuss here one question. Let us discuss here. Now, two bar magnets, this is the south, this is the north, another bar magnet and it is also magnetic moment I am taking that m1, it is also m, and here this is the south and this is the north, and this angle for example I am giving that 60 degrees. So, from the figure find out the resultant magnetic moment. So, what we want? So, resultant magnetic moment we want. So, by seeing the diagram we may think that the angle between the two magnets are 60 degrees. Of course, magnets, the angle between two magnets is 60 degrees, but theta is not angle between the two magnets. That is the angle between the magnetic moments of the bar magnets. So don't so mistaken for that. So theta is the not angle between the two bar magnets. It is the angle between the magnetic moments of the two given bar magnets. Then how can I identify? So here south to north. Therefore this is the magnetic moment direction for the first magnet. Now I am taking that is the M1. M1 of course how much they have given? M1 is equal to M only they have given. Next, so what I am taking that? This is the south, therefore now what? This is the north, therefore magnetic moment direction is always from where to where? Now what? That is it. That is equal to M2 and M2 is equal to how much now? M. Therefore now this is what? 60 degrees. Now we want, so not angle, therefore this is our required angle. Therefore this angle is the 60 degrees. Therefore theta is equal to how much now? Theta is equal to 180 minus 60. That is equal to what? 120 degrees, because this 60 degrees we should not take into the calculation. So only theta is equal to 120 we have to take. Therefore now formula what I have given now? So magnetic effective magnetic moment M net is equal to under root of M1 square plus M2 square plus 2M1 M2 into cos theta. Use this formula. And here one thing you keep in mind, cos 120 value is always equal to minus 1 by 2. And sin 120 value, sin 120 is you can write is equal to what? That is equal to root 3 by 2. So cos 120 value minus 1 by 2, sin 120 value we can take 180 minus 60. So in that function if you convert sin 180 minus 60, nothing but sin 60 is equal to what? No? That is equal to root 3 by 2. I am taking that. Therefore, if you substitute the values, and what is that net magnetic moment? M net is given by under root of M1 square, that is M square plus M square. Next what? That is the plus 2M square into what? Cos 120, and cos 120 minus 1 by 2. Now after solving you can get that so 2M square plus 2M square into minus 1 by 2. This 2 to get cancelled, and 2M square minus M square will come. 2M square minus M square nothing but M square. So final answer what? That is the magnetic moment. And without solving that problem you can give the answer. When two vectors of equal magnitudes are acting at an angle 120, the resultant also equal to either of the answer. Means what? So if A is equal to B and the angle between them theta is equal to 120, resultant also equal to A is equal to R is equal to A is equal to B. Keep in mind. Therefore, once when you know, yes, the magnetic moment is M, here also M, therefore both are having the same value, angle between them is 120, direct we can take the answer, not need to solve this much time. Okay. Therefore, now this is the one more question. Coulomb's law. So now onwards, the magnetic field, Coulomb's law, all are very similar to our electric charges and fields only. So according to electric charges and fields only we can go to that. Okay. For example, here I am taking that. So this is one pole strength that I don't know, this is I am taking that M1, and here this is another pole strength I am taking that is the M2. Of course, the monopoles do not exist, but if you consider two bar magnets are very lengthy, therefore now what? It's a north pole here I am taking that, one more north pole here I am taking. For example, if you take like this, right, if this magnet is very high, very lengthy, therefore now here I am taking that its pole strength is M1. Another bar magnet I am taking that is also very long bar magnet, therefore now what? M2. Therefore now what? Here two bar magnets I have taken. Imagine that this is the first pole strength of the first bar magnet with one of the poles. I don't know, adu south pole or north pole or whatever it is. So this is the individual. Of course, once again I am saying that here monopoles do not exist, but when the bar magnet is very lengthy, therefore one pole do not affect the other pole. That's why I am taking that here. So single pole monopole system only. Therefore M1 is the pole strength of the first bar magnet. M2 is the one more isolated magnetic pole strength of any given bar magnet. Now these two are separating with a distance r in the free space. Then the magnetic force between them is given by F naught is equal to mu naught by 4 pi. So into what? That is the M1 M2 by R square. And one more time I am saying that here M1 M2 do not represent the mass, they are representing the pole strength only. So in the gravitation lesson, so we know that according to Newton's universal law of gravitation, F is equal to G into M1 M2 by R square, but here M1 M2 are not masses, those are what? Pole strength only. And as I told you already, mu naught by 4 pi value is to, for the free space, mu naught by 4 pi is equal to 1 into 10 power minus 7. So what that is the, so Henry per meter. Mu naught by 4 pi is equal to 1 into 10 power minus 7 Henry per meter. So keep in mind, therefore now, so that is the Coulomb's law, very simple only. Now, so here, if you take magnetic field, what is the electric field? In the same way we can define a magnetic field also. So we know that electric field is equal to force experienced, which force? Electric force experienced per unit pole strength, unit test charge particle in any electric field is called as electric field intensity. Same, the magnetic field intensity is given by, so B bar is equal to magnetic force experienced by unit, north pole strength, because here the test particles in general can be taken as the positive. That's why here if the test particle is the positive, here pole strength also positive means what? Per unit north pole we have to define. Therefore, magnetic force experienced per, so unit pole strength is called as magnetic pole strength, magnetic field. And so here what is the force unit? So Newton, and as I told you, so M naught is the pole strength. For the pole strength, the unit is what? Ampere meter. Ampere meter is the pole strength. Therefore, Newton per ampere meter is the SI unit of so what? Magnetic field, and it is also equal to what? That is the Tesla. So T, capital T is the symbol for the Tesla, and of course sometimes we can also use the, it is the Weber per meter square. So Weber is the magnetic flux unit. Therefore, from the definition of magnetic flux, we can take a Weber per meter square is also magnetic field unit. And so if you take magnetic field due to a single pole strength, so just electric field due to a single charge. So what is that? So here magnetic pole strength M, I am taking that at any distance R. Now what? So here the magnetic field magnitude is given by B is equal to mu naught by 4 pi. So that's what? M by, so R square, I am taking that out. So if it is the north pole strength, because this pole strength may be positive, may be negative. If it is the north pole, now for the positive charge, the electric field is always away from the charge. In the same way, for the positive pole strength, so the magnetic field is always away from the, so away from the given pole strength. Therefore, this is a B bar, I am taking that. So if it is a negative pole strength, so if it is a negative pole strength means what? If it is a south pole, then the direction of magnetic field is so towards the pole strength, towards the south pole strength, that is a B bar. Therefore, answer for the both means the magnitude of the magnetic field is the same for both of them. B is equal to mu naught by 4 pi M by R square only for both. Right? Therefore, this is the pole strength. A very simple question, just to go through the electric charges and fields, you can find out the answer for that. Okay? Right. Now, so magnetic field due to a magnetic dipole, just like electric dipole system. For example, I am taking that. This is one bar magnet. Let us take one bar magnet, and let us take this is the south pole, and this is the north pole. I am taking that. Let me take, this is the south and this is the north. and you know that minus m is the pole strength for the south and plus m is the pole strength for the north. Now here I am taking that this line is called as the axial line of the bar magnet, and from the center if you draw a line perpendicular to the length of bar magnet, this is called as the equatorial line. This is axial line, this is the equatorial line. 2 points I will select. So one is on the axial line and one is on the equatorial line. And so from the center if I will take, this is the 1 point. Now what I am taking that, therefore now this is the, so 1 I am taking the x beta. From the center of the bar magnet, now at this point I want what is the net magnetic field produced by the bar magnet. So here two are there. So north pole produces the magnetic field there, south pole also produces the magnetic field there. So now the effective or the total or the net or the resultant magnetic field at that point on the axial line is how much? That is called a magnetic field due to axial line. And here I am discussing only about the short bar magnet. Better to take short bar magnet only, I am taking that, not longer one, because that is not necessary here. Only short bar magnet you follow, then better. Therefore now what? For the short bar magnet, now I am taking that the magnetic field on the axial line BA is given by, so mu naught by 4 pi, so into 2 capital M by x cube. So this is the what? Magnetic field due to a point on the axial line of a short bar magnet. So mu naught by 4 pi, so 2m by x cube. And here if for the given bar magnet, if m is constant, now you can say the magnetic field on the axial line is directly, inversely proportional to x cube. Means what? If you go away from the bar magnet, the magnitude of the magnetic field is going to be decreased. Therefore now that is the inversely proportional to x cube. Right now, and if you take a point on the equatorial line, so at that point I want a magnetic field. Therefore now what I am taking that this distance from the center of the bar magnet, I will take what? That is the y nana. Now this point is on the, so what? That is on the y axis. Therefore for the, this is what? Axial line. And so this one I am going for the equatorial line. Therefore for the equatorial line, let us take the symbol is BE, and the formula is mu naught by 4 pi, so into what? M by y cube. Here 2m will come, here m will come, m by y cube. And here also on the equatorial line also the magnetic field so is inversely proportional to cube of the distance from the center of the bar magnet. Therefore now BE is the, so inversely proportional to y cube I have taken like that. Okay. So therefore now, so this is the formula for that. Next one. So here you know that the direction of magnetic moment is always from where to where? Direction of magnetic field is always from what? South to north. Therefore now I am taking that this is the direction of bar magnet. Now the magnetic field on the axial line and the field both are in the same direction. Therefore if you take the point here, the direction of magnetic field on the axial line I am taking, that is what? BA. Therefore this is the BA and this is the M bar I am taking. Therefore here, now if you take the point on the equatorial line, now this is the direction of magnetic field and that part I am taking that this is the BE. Therefore for equatorial line, the direction of magnetic field and the magnetic moment is both are in the opposite direction. Therefore between them theta is equal to 180. That implies what? So now what? BE is always anti-parallel to so magnetic moment. And in this case what? So in this case theta is equal to 0. Theta is equal to 0 means what? So what? South to north the magnetic moment are acting and the magnetic field, so due to the axial line also acting from south to north. Therefore in this case you can say that's what? Theta is equal to 0 means what? Now watch. So B axial is in the same direction of magnetic moment. This line is indicating what? Both are in the same direction. Therefore this is the small introduction of magnetic field due to a bar magnet. One is on the axial and one is on the equatorial line. Let us discuss so one or two problems. Two identical bar magnets are placed as shown in the figure. Two identical bar magnets are placed as shown in the figure like this. And the question, and here the distance between the centers of the magnets is given. This is that, and this one, the distance between the centers, I am taking for example 2D now. Right, 2D is the distance between the center of the magnets, and they are asking, so now what here, south to north, therefore here this is the south and north, and this is the south and north. Now they are asking at the center of the two magnets, at the center of line joining the centers, at the midpoint of, so line joining the centers, what is the magnetic field they are asking? Means what? For example, let me take, this is somewhat small. Right. Now what? So this is the 2D na? Now what I am asking that, therefore exactly here. Exactly here. So net magnetic field, how much they are asking? So the centers of the two given bar magnets are separated by a distance how much? 2D I have taken. Now the question is, what is the net magnetic field at the midpoint of a line joining the centers of the two bar magnet, and both are identical. Both are identical means what? Its magnetic moment is M and its magnetic moment is also M. Let us take. Both are identical and they have given each bar magnet moment how much? Capital M they have given. Now the thing is that, so what is the net magnetic field? First of all, let us identify the direction first. Now tell me, for the first horizontal bar magnet, this point acts as what? This point acts as a, so equatorial, axial line. Therefore, for the first one I am taking, let me take, this is the first bar magnet, and then let us take, this is the second bar magnet. Therefore, for first bar magnet, for one, that point, it acts as what? It acts as a axial line. It acts as axial line. Therefore, now what is the answer for that? So, B1 is equal to mu naught by 4 pi, formula what? 2m by, so what? Here to here, distance how much? That is the x. Therefore, x is equal to how much now? X is equal to d. In place of the x, you substitute the d. So, what we can get now? That is equal to d cube, equation number 1. I am taking that. So, what is the direction? Here, the direction is, so that is the magnetic moment, that is the B1 I have taken. That is over. Because for the axial line, magnetic field is in the same direction of magnetic moment. Therefore, for this magnet, the magnetic moment acting this side. That is the magnetic moment direction. Come to the second one. Second one, what is the magnetic moment? Second one, this is the south pole, this is the north pole. Therefore, now this is the magnetic momentum, that is equal to m. You can take that. But tell me, this point for this magnet means what? So, if you take this is center of the magnet, now what? This distance how much? Nana? Therefore, for this one, it is acting, it is a D, but this point acting as what? Equatorial line, because it is, this point is present on the equatorial line or on the perpendicular bisector. Therefore, now what? If you keep there, now what you can get at this point, the net magnetic field we want. Therefore, this is the magnetic moment for the equatorial point. The magnetic field always opposite to the magnetic moment. For the axial line, magnetic moment field both are in the same direction. See, this is the B1 direction, this is the M1 direction. M1 is equal to M, and this is M2 direction, magnetic moment of the second bar magnet, and what? This is the B2 direction, because both are in opposite direction. Now, what is the angle between them? Theta is equal to 90. Therefore, now the magnetic field due to second point, second bar magnet is given by mu naught by 4 pi. So, into m by, what is that? That is also d cube only. Therefore, now what? This is equation number 2. That is equation number 2, I am taking that. Now tell me, so what is the resultant magnetic field they are asking? So magnetic field is vector or scalar? It is purely a vector. If it is a vector, what is the angle between them? Theta is equal to 90 degrees. Therefore, now the resultant magnetic field is given by what? B is equal to, so better let us do one thing. So what I am taking that? So if you take this B2 is equal to B, if you consider, therefore this becomes what now? That becomes so 2B. right? Therefore, if you take mu naught by 4 pi, m by 2 cube is equal to b, therefore mu naught by 4 pi 2m by d cube is equal to 2b, let us take that. Now, the angle between them how much? Theta is equal to 90, therefore, b is equal to formula what, that is equal to, so when two vectors are perpendicular, you know that is what? So, b1 square, so b2 square only. And so, if you keep the values here, now in this case b1 square value how much? So, b1 square is equal to that 2b whole square means what? 4b square plus next what? That is equal to, this is 2b, no? Yes, 2b whole square. Now, so here b square and finally what? That is equal to, so root over 5 into b. Therefore, now the net magnetic field is given by, at that point at the center of line joining, so b net is given by root 5 into b. So, what we have taken? So, root 5 into b value how much? So, b value we have taken mu naught by 4 pi m by d cube. Therefore, this is the, so mu naught by 4 pi into m by d cube is the resultant magnetic field. And if they will ask what is the direction of resultant magnetic field at this point. So, here what we have taken, so this is the B2 we have considered, this is the B1 we have considered, B1 and this is the B2. Therefore, now what? The resultant magnetic field is the passing through the, so resultant of them in the middle of them, therefore B2 and B1. So, if you consider, so therefore, now what? If it is the B2, this is also can be taken as what? B2 and this is the angle theta. In this, so right angle triangle, so what we can say now? Tan theta is equal to, from that direction of resultant magnetic field. So, tan theta is equal to, so B2 by, so B1 and tan theta is equal to B2 value. We know that mu naught by 4 pi, so m by, so d cube and this is mu naught by 4 pi 2m by d cube. Now, after cancelling all terms, mu naught by 4 pi cancel, m by d cube cancel. Now, you are getting what answer? 1 by 2. Therefore, theta is equal to, you can say, that is tan inverse of 1 by 2 with what? With B1. With axial magnetic field, it is getting how much angle? Because we need to consider one reference line compulsory. So, with respect to the B1, so what? From the B1 or with respect to the B1, so we have calculated its direction. Therefore, that is what? Theta, tan theta is equal to tan inverse of 1 by 2. So, this is the and magnetism and matter, and tomorrow let us discuss electromagnetic induction concept. Thank you.
Right. Okay, Amma. Good morning, all of you. Right. Today, I am going to discuss about same chapter, yesterday's chapter. That is what alcohols, phenols, and ethers. Some other concepts I am going to discuss about that. Right. Now, here one of the topic is that is related to oxidation. Right. Oxidation with alcohol first. I am taking alcohol, different types of alcohols, observe clearly. Compulsory, they are asking question here only now. In this related concept, they are asking compulsory question. Already we know reduction, so many questions we have solved. Now related to reduction, after that's what I am going to discuss about oxidation. Oxidation of different types of alcohols. This is primary alcohol, this is secondary alcohol, this is tertiary alcohol. Right? Before going that, we should know the oxidizing agents. Already there, oxidizing agents. One is strong oxidizing agent. Second one is mild oxidizing agent. This you should know first. If you know the which one is strong oxidizing agent, which one is mild oxidizing agent, then you will get the answer automatically. Strong oxidizing agent is one of the strong oxidizing agent is this one, potassium permanganate, KMnO4 followed by H plus, otherwise alkaline. Alkaline, acidic medium or alkaline. KMnO4 followed by H plus, otherwise KMnO4 followed by alkaline means hot and concentrated. Sometimes they will give hot and concentrated. Hot and concentrated are also called alkaline. Alkaline KMnO4. That is called strong oxidizing agent. Next one is K2Cr2O7 followed by acidification, that is potassium dichromate. Third one is concentrated HNO3. These three are still there. These three are very, very strong oxidizing agents. Very, very strong oxidizing agent. That means this will oxidize double bond and triple bond also. Triple bond and double bond and triple bond also. Double bond also converted to acid, triple bond also converted to acid, and including alcohols. So alcohol is there, alcohol directly converted to carboxylic acid. That means this is strong oxidizing agent. But the final product is most of the cases is acid. These are the strong oxidizing agents. Still there, very strong oxidizing agent. Still strong oxidizing agent, that is what? Dilute HNO3. Observe clearly. This is called concentrated HNO, this is called dilute HNO3. Next one is Jones reagent. Jones reagent is what now? CrO3 followed by aqueous acetone or aqueous H2SO4. Anyone. It's a mixture of chromium trioxide or aqueous acetone. This is called Jones reagent. Otherwise, sometimes CrO3 followed by H2SO4 aqueous. That is called Jones reagent. Right? Still other one is there, that is leave it now. This most of these two only. Total these five are called oxidizing agents. Which oxidizing agent? Strong oxidizing agent. These are called very strong oxidizing agents. These are called strong oxidizing agents. That means here also final product is acid A, but double bond and triple bond will not oxidize. That is only different from that to this. In case of this, double bond and triple bond also will oxidize it to acid. Remaining other functional groups also directly acid only now. Here double bond, triple bond will not oxidize. That means double bond, triple bond will not touch. Remaining alcohols are directly converted to acid. That is the meaning of strong oxidizing agent. These are called very strong. These are called strong. Next one, still there. That is leave it now. We don't want remaining. Mild oxidizing agents. One is mild oxidizing agent, already we know, that is called PCC, pyridinium chlorochromate. Pyridinium chlorochromate. Pyridine, compulsory CrO3 and followed by HCl. CrO3, that is called chromium trioxide with pyridine plus HCl. This mixture is called pyridinium chlorochromate. Right? Second one is PDC, pyridinium dichromate. Pyridinium dichromate. There is not there in our syllabus. Okay, I am giving now mild. Some other one is this one, CrO3 with anhydrous. This is the important. Anhydrous. They are not mentioning anhydrous means that is the meaning of anhydrous only, CrO3. Otherwise CrO3, the simple they will mention. That is meaning anhydrous CrO3. From this to this observe now. This is aqueous. Water is present here without water. That is called anhydrous. This is called, these three are called what? Mild oxidizing agent. Mild oxidizing agent means this will not oxidize, that is what? Double bond and triple bond will not oxidize, will not touch like this. And again final product is carbonyl compound. Final product is what? Carbonyl compound. Carbonyl compound may be either aldehyde or ketone. So reaction will stop at aldehyde and ketone. That is the only difference. Those are called strong and mild. Right? On that now, first what I am going to use? Strong oxidizing agent. Here double one and triple one are there. Leave it now. That's any one you can use. That type of questions I will give it. First strong oxidizing agent. Here also same strong oxidizing agent. Here also same strong oxidizing agent. First. Strong oxidizing agent means first what is the product I can expect. In case of primary alcohol. Primary alcohol is first step is aldehyde. RCH2 is converted to aldehyde. That is primary alcohol to aldehyde. First step. From here this is what happened. So what happened means here observe now removal of hydrogen. Removal of hydrogen means addition of oxygen, removal of hydrogen is called oxidation. From this process is called oxidation. Here to here is called oxidation means this is called reducing agent. Alcohol is reducing agent. This is reducing agent means this whatever the reagent you are using, that is called oxidizing agent. That is called oxidizing agent. These are in this anyone you can use, but means I am saying strong oxidizing agent first. So these are called oxidizing agent. Oxidizing agents oxidize from alcohol to primary alcohol, oxidize primary alcohol to aldehyde, first step. This also again further oxidation will take place. Further oxidation will take place converted to carboxylic acid. Why sir it further oxidation will take place? Because it is a strong oxidizing agent. That means I told you already alcohol directly converted to what? Carboxylic acid. Now in case of secondary alcohol what I can get? Ketone. First step. These two are called carbonyl compounds, aldehyde and ketone. So first step. But which oxidizing agent I am using now? Strong. That's why it is also further oxidation will take place. Then what will happen? In case of strong oxidizing agent, it undergo further oxidation. Ketone, from special condition it undergo further oxidation. Compared to this aldehyde and ketone, which one is the more reactive? Aldehyde is more reactive than ketone. That means it is directly undergo carboxylic acid, but it is not undergo directly carboxylic acid. Why? Because here in this two which one is more reactive? Aldehyde is more reactive than ketone. That meaning ketone is less reactive. Why ketone is less reactive? Observe clearly. Why ketone is less reactive? Because adjacent groups are both are alkyl groups. Here also alkyl group is there. Here only one alkyl group. Here two alkyl groups are there. Where is the more steric hindrance? Here only compared to this. Because of the reason ketones have the more steric hindrance than the aldehyde. Ketones are more steric hindrance than the aldehyde. That is the reason it is less reactive than this one. So that's why it requires some special condition. So that's some special condition means elevated temperature we have to use. Elevated temperature. In case of strong oxidizing, not required. Elevated temperature. Elevated means extra temperature, means extra energy we have to supply. Why extra energy we have to supply? Because of this one less reactive. That's all. So I am supplying simply elevated temperature like the delta. Again ketone I am writing here. Ketone, further oxidation. In case of strong oxidizing, what happened? Any side, both side you have to break the bond. Both side, this side, right side to left side, both side you have to break down bond like this. This is one carbon acid, clearly observe. This side is one carbon, this side two carbon. Sir, why you are breaking this side, sir? I can break this side. Okay, you can. This side one carbon, that side two carbon. That means mixture of carboxylic acid you will get it. One carbon is converted to one carbon acid like this. So carbon is there, I will take carbon plus C. That means what? HCOOH, formic acid. Here how many carbon? Two carbon. Two carbon is R. This is converted to COOH. On this side. So R means ROH will not possible. That's what I written. R plus I taken C. One carbon, that means CH3 converted to HC. That means one carbon is one carbon acid. Two carbon is two carbon acid. That means this acid both are not same. That is different. That's you will get mixture of acids. Mixture of how many acids? Two acids. So this side also different is there, then that time you will get mixture of 4 acids you will get it. When mixture of 4 acids, in case of ketone with strong oxidizing agent with elevated temperature, that time mixture of carboxylic acids you will get it. Both sides will be different, Both sides will be different means you will get the mixture of 4 acids, 4 carboxylic acids. So that is only final answer. In case of tertiary alcohol, you go tertiary alcohol. Tertiary alcohol with strong oxidizing agent, no reaction. Reaction is not possible. What is the reason for that? Reason is, observe now. So this is the functional group. Functional group attached to first carbon is called alpha. This is called beta. This is called beta. This is called beta. Alpha carbon containing hydrogens are called alpha hydrogen. But here absence of alpha hydrogen, there is no alpha hydrogen. That is the reason. So absence of alpha hydrogen, tertiary alcohol do not undergo oxidation. In case of this one, observe no, your primary alcohol. Primary alcohol attached to first carbon, that means what you call functional group. Functional group attached to first carbon is called alpha. Alpha carbon containing hydrogens are 2 alpha hydrogens are there. Here 2 alpha hydrogens are there. Observe here. Your functional group. Functional group first carbon alpha. Alpha carbon containing hydrogens are called alpha hydrogen. Here 1 alpha hydrogen is there. Here no alpha hydrogen. That is the reason. Here 2 alpha hydrogen. Here 1 alpha hydrogen. Here no alpha hydrogen. That's why it is not undergo oxidation. In case of strong, same reaction. Instead of this I am using mild oxidizing agents. Mild oxidizing agents, observe here. RCH2OH, that is called primary alcohol. RCHOHCH, that is called secondary alcohol. RCHCH3 OH here CH, that is called tertiary alcohol. With mild oxidizing agents. Mild means anyone, PCC, PDC, anhydrous CrO3, anyone you can use. So that's what I written, mild oxidizing agent. Mild oxidizing agent, same again, what happened? Primary alcohol converted to aldehyde. Here further oxidation will not take place. That is the reason I told. Observe now. Why sir here further oxidation will not take place? Because it is a mild oxidizing agent. So energy is not sufficient to convert again acid. So the energy is not sufficient to convert aldehyde to acid. That's why it is mild oxidizing agent. Then what happened here? You observe clearly again. Reduction means what you call removal of hydrogen is called oxidation. This is oxidation means this is called reducing agent. This is reducing agent means what you call this one? Oxidizing agent. Which oxidizing agent? Mild oxidizing agent. In case of secondary alcohol, observe now. Secondary alcohol is converted to what? Ketone. Then further oxidation also will not possible. That means what I told. In case of mild oxidizing agent, carbonyl compounds is the final product. In case of strong oxidizing agent, final product is carboxylic acid. What about tertiary alcohol with mild oxidizing agent? No reaction. Same reason, because of absence of alpha hydrogens. Observe clearly, right? Next one. One example I am giving to you. CH3, CH, this is one of the time they ask the question. This is what I am giving. CH3, CH double bond, CH, CH2, CH2, OH with first strong oxidizing agent, anyone. First strong oxidizing agent means in this case, observe clearly. Strong oxidizing agent number I am giving now here. Here 1, 2, 3, this is 4, this is 5. So 1, 2, 3 on that first 1, 2, 3 anyone I can give. I can write 1, 2, 3. Otherwise 1 or 2 or not 1, 1 or 2 or 3 anyone you can use. 1 means KMnO4, 2 means K2Cr2O7, 3 means constant HNO3 with this one. Now here 4 and 5 here in this case 4 or 5. 4 or 5 means 4 means dilute HNO3, 5 means Jones reagent. Observe clearly what I told. These 3 are there, it will oxidize double bond and triple bond also and alcohol also. Observe now, first one. We know alcohol converted to what? This one or these are 1, 2, 3 are what? Strong oxidizing agent. That is alcohol, primary alcohol. Primary alcohol means directly converted to carboxylic acid, we know. Then again, here double bond also there, double bond also will be oxidized. That is the only reason. That's what I told. Double bond and triple bond also will be oxidized. So here will break down. First, here will break down means this is converted to first one aldehyde. That side oxygen, this side oxygen you have to add. Like a ozonolysis. First one, what is the product? CH3CHO. Here one product. This product observe now. This is converted to aldehyde. I am writing here. CHO, aldehyde. This is CH2 as it is. This CH2O is converted to what? CHO, aldehyde, because alcohol with strong oxidation, first one is aldehyde. First step, that means two products here breakdown, that means double bond also will oxidize to aldehyde first. This undergo further oxidation. Why further oxidation? Why further oxidation? Means this is a strong oxidizing agent. This is converted to carboxylic acid, CH3COOH. This one also converted to carboxylic acid. This aldehyde is converted to COOH, CH2 as it is. This aldehyde is converted to COOH. This is the product. Mixture of acids, two acids. When strong oxidizing agent, one is KMnO4, second one is K2Cr2O7, third one is constant HNO3. Here double bond also will be oxidized. Double bond also will oxidize, or triple bond also will be oxidized, directly converted to what? Carboxylic acid. Now in case of 4 and 5, 4 and 5 means what? This is what? Dilute HNO3 and zone 3 agent. That time what happened? These also directly converted to acid A, but double bond and triple bond will not be oxidized. Double bond. Answer observe first. CH3, CH, double bond CH, CH2. This is converted to what? First aldehyde. Aldehyde. Again this further oxidation will take place. Then converted to what? CH3, CH, double bond CH, CH2, COOH. That is the answer. Observe now. In case of 4 or 5, 4 or 5. 4 or 5 means what? Dilute HNO3 and zone 3 agent. Here double bond will not be oxidized. This part that is mild somewhat compared to that. So this converted to what now? Finally carboxylic acid, double bond is as it is. From that to this, that is only difference now. Right? In case of mild oxidizing agent, this one only now. We are starting with that one only now. With mild oxidizing agent, when I am giving PCC, PDC or CrO3 anhydrous, what happened? So these three also will not oxidize double bond. So double bond will not be touched. Double bond as it is. So double bond as it is. CH3, CH, double bond, CH, CH2. This is converted to what now? Aldehyde. Again further oxidation. Further oxidation is not possible. That means final product is what? Will be stop at aldehyde. Why will stop at aldehyde? Is primary alcohol. In case of secondary alcohol is there, second alcohol means ketone in the final product. The double bond is as it is. Double bond also will not be touched. Further oxidation, why it is not takes place? Because these are mild oxidizing agent. That is only difference between strong and mild oxidizing agents. Next one, some other one reagent is there related to oxidation process. But that oxidation will be takes place at the presence of catalyst, but it's called catalytic hydrogenation. Observe primary alcohol with copper or silver with 573 Kelvin. Secondary alcohol with copper or 573. Now third one is, okay, just I will write directly tertiary alcohol like this with copper or 573. Copper followed by 573 Kelvin. This is also catalyst here. Catalyst, what is the catalyst here? Copper. Sometimes silver also they will use. Copper or silver with 573 Kelvin means high temperature I am using now. So high temperature I am using means compulsory. What is the use of the temperature? To breaking of the sigma bonds, covalent bond. Sigma bond means a strong bond compared to the pi bond. We cannot break down sigma bond very easy. We want to break means it requires some external energy. That external energy is given by temperature. That is high temperature. In case of primary alcohol, converted to what? Aldehyde. Final product is aldehyde. So here what happened now? Same, removal of hydrogen. Removal of hydrogen means what you call? Reduction, also called dehydrogenation. D means removal, hydrogenation means hydrogen. Removal of hydrogen. Removal of hydrogen means oxidation. This oxidation means this is called reducing agent. This reducing agent means this is called oxidizing agent, like it is acting as a, in this case it is acting as a oxidizing agent. So further oxidation not possible. So that means primary alcohol with copper aldehyde, secondary alcohol with copper you will get the ketone. Here also further oxidation not possible. But tertiary alcohol with copper, before I have already seen strong and mild oxidizing agent. Tertiary alcohol with strong or mild oxidizing agent, no reaction I told, because absence of alpha hydrogens I told you. Now in case of this one, it is undergo elimination. Elimination means beta elimination. Observe here, functional group attached first carbon is called alpha, this is called beta, this is called beta, this is called beta. How many beta carbon? 3 beta carbon or 3 beta hydrogens are there now. So 3 beta carbons are same. 3 beta carbons are same means you will get the only single product. 3 beta carbons are different, you will get the 3 different products. That time major or minor will form. Major or minor will be decided by Sedgwick rule, also called Zaitsev rule. Sedgwick rule or Zaitsev rule for elimination reaction, right? Now we are not don't want Sedgwick rule because all alpha carbons are same only now. That time what happened? Hydrogen from beta carbon, any beta, your choice. Hydrogen from beta carbon, OH from alpha carbon. So hydrogen atom is eliminated from beta carbon. That is called beta elimination. So answer is CH3, C, CH3 as it is. Here hydrogen means you will get the double bond, CH2, here OH, then water is eliminated. This is the product. Alkene is the product. This is what happened here, dehydration. So dehydration means what? Removal of water. That is called elimination. So why dehydration? Because I am giving high temperature. That high temperature is supplied because of breaking of what? Which bond? Sigma bonds. So this is only difference now, right? Primary alcohol, secondary alcohol, tertiary alcohol. This is the information. Now this information using, that is one of the concept. Now we will solve some questions now like this yesterday's. First one. This is ketone. This is already textbook question amma. This is so many times they ask the question. So many times. Right. Here NaBH4, sodium borohydride. Here lithium aluminum hydride, followed by hydrolysis or H2. H2 simply you can write H2O. This is the these two reactions, right? Again, what I can write? First one, sodium borohydride. This reaction. Observe now. Sodium borohydride use that is called mild reducing agent. Last I told mild reducing agent, right? Mild reducing agent means it will reduces only selective functional groups I told, that is what? Aldehyde and ketone and acid halides. Only will be those three only will be reduced. Observe here. So this is called ester. Ester with mild reducing agent it will not change. So no product means no reaction here. So reaction will not take place because it will not reduce. Because this is ester, right? This is mild reducing agent. In this one is there, what they have, what is there here? Ketone. Ketone is there means ketone will reduce. Ketone will reduce it to alcohol. So this functional group as it is, CH2, C double bond O, OCH3. This is the product. This is the answer. Sorry, CH3, C double bond O, O is there now. OCH3. Ester will not touch. That is because mild reducing agent. From here to this what happened? Just addition of hydrogen, not oxygen. Oxygen as it is, addition of hydrogen. Addition of hydrogen means what you call reduction. Here it is what? Reduction. This is reduction means what? This is called what? Oxidizing agent. This is oxidizing agent means what you call this one? Reducing agent. So that's why NaBH4 is a reducing agent. This which reducing agent? Mild. It will reduces only selective functional group. What are those? Aldehyde, ketone and acid chloride. These three functional groups only will reduce. Reduce it to directly alcohol. Right. Now same reagent, same starting material, same substrate, but by using lithium aluminum hydride, then what happened? Lithium aluminum hydride, that is called strong reducing agent. Next H2PD is the yesterday I told H2PD or H2Ni. and H2 followed by nickel, palladium, platinum. That is called very strong reducing agent. So, this one what happened? This will reduces all functional groups except double bond. In case of H2PD is there, it will reduce all functional groups including double bond also will reduce. That is only difference now. Once again observe, H2PD, lithium aluminum hydride, both are strong reducing agents. But H2PD is reduces all double bond, triple bond, any functional group will reduce. Again, this one lithium aluminum hydride reduce all functional groups except double bond and triple bond. That is the different now. So, these two will be reduced. Reduce means what happened? Ketone reduced directly alcohol, secondary alcohol. Aldehyde is primary alcohol, ketone is secondary alcohol. This also will reduce. Reduce means what you have to do? Where you have to break. Ester is there, ester you have to break the bond between carbonyl carbon and oxygen, CO bond. Now this is converted to alcohol, this side, that is converted to alcohol. So this convert to alcohol means what? CH2, this is converted to CH2OH, this alcohol, this set, this group. This group is converted also alcohol, so CH3OH, observe clearly. In case of NaBH4, in case of lithium aluminum hydride. Lithium aluminum hydride reduces all functional groups except double bond, means ester also will reduce. Sodium borohydrate only reduces only 3 functional groups I told you, aldehyde, ketone, acid chloride, only these 3, right? That is the product. Now this one observe. CH3, CH2, CH3, CHO with lithium aluminum hydride, that means strong reducing agent. Right, answer is CH3, CH2, here CH3, aldehyde is converted to what? Alcohol. So, reduction means alcohol, oxidation means carboxylic acid, reverse, right? In case of sodium borohydrate, same product, because here what is the functional group is there? Aldehyde, so aldehyde will reduce. Or NaBH4 is again product is alcohol. This is the information about both oxidizing and reducing agents. This is the information. Compulsory they are asking one question, right? Next one boiling point question, physical property, pentane 1-ol, next one N-butane, that is called hydrocarbon. Next one pentanol means aldehyde. Next one ethoxyethane means ether. These are the four functional groups are there, 4 different functional groups are there. Write the increasing order of boiling point. One is pentanol, that means alcohol. Second one is hydrocarbon. Okay, so hydrocarbon I can write like this, that means 5 carbons again, pentane. This is called pentanol. This is called ethoxyethane, that is called ether, right? Different functional groups are there now. Different functional groups are there now. Different functional group and I think comparable molecular mass. That time boiling point depends upon 3 factors. 3 factors I told. 3 factor means what is that now? One is hydrogen bond. Second one is dipole interaction. This one already I discussed once again. Third one is induced dipole. Right? Induced dipole is called van der Waals force. In this, which one highest hydrogen bond, means which one is the highest boiling point? Which one is exhibit hydrogen bond? That is the highest boiling point. That means alcohol will exhibit hydrogen bond. So this is the first one. Which hydrogen bond? Intermolecular hydrogen bond. Observe here. Observe. So alcohol general formula ROH. Again ROH. More electronegative with oxygen with hydrogen positive charge. More electronegative with hydrogen to form a hydrogen bond. That hydrogen bond is called intermolecular hydrogen bond. So that's what alcohol is form intermolecular hydrogen bond. So that's the highest boiling point. Next one, aldehyde ketone. Sorry, this aldehyde and ether. In this, which one is the highest boiling point? First one, I'll observe now aldehyde. Observe ether. Aldehyde general formula RCOH, ROR ether. In the alcohol, in aldehyde, oxygen and carbon which is the more electronegative? Oxygen is the more electronegative. Oxygen getting which charge? Negative charge. Carbon getting which charge? Positive charge. Positive charge means charge separation. Charge separation there means that is called, charge means this is one charge, this is called one pole, this is called one pole, that is called dipole. So here dipole interaction is present here in case of ether, sorry, in case of ketone or aldehyde. Now in case of ether, observe now. Here also oxygen getting negative charge because more electronegative. Now the adjacent carbon is there, little bit get the positive charge. Here also charge separation is there. Charge separation there means that is called pole, that is called here also dipole interaction. Here also dipole interaction, here also dipole interaction. In these two, which one is the more dipole interaction? But you should know, it you want to know first. Observe here. RC double bond OH, ROR. Here, CO attach this carbon, oxygen attach this carbon. What is the hybridization? sp2 hybridization. Observe. Carbon surrounding by 4 bonds, but double bond is there. Double bond considered as a single bond as per theory. 1, 2, 3. Number of bonds are 3 means sp2 hybridization. Here number of bonds observe now 1 to 2a. But observe here 1, 2. 2 plus 2, that means 2 bond pairs to 2 lone pairs. 2 bond pairs to 2 lone pairs, otherwise there oxygen also. 2 bond pair, 2 lone pair means what the hybridization? sp3. Here observe now. 2 lone pairs, 1 bond pair, that means which hybridization? sp2. That means here oxygen hybridization is sp2, here oxygen hybridization is sp3. In case of aldehyde is sp2, in case of in case of ether is sp3. So based on hybridization you can say percentage of S character. Percentage of S character directly proportional to we know electronegativity. In this, which one is the more percentage of S character? sp2 is the more percentage of S character than sp3. sp2 is more percentage of S character than sp3. That means more percentage of S character, more electronegativity. That means in these two, which one is the more electronegative? Aldehyde is the more, aldehyde or ketone, anyone. That means carbonyl compound. Aldehyde or ketone are more electronegativity than ether. More electronegativity means what happened? More charge separation. More charge separation means what you call more polar. More polar means what you call more dipole interaction. That means this is less electronegative, less polar. Less polar means less dipole interaction. That means which one is the more dipole interaction? Aldehyde is the more dipole interaction than ether because of hybridization. So first one, this one both are dipole interaction. Aldehydes are aldehyde and ketones are more dipole interaction than ether. Next one, last one is hydrocarbon. Hydrocarbon is having induced dipole. So answer is boiling point order 1 first. Second one 1, 2, 3, 4. 1, 2, 3, 4. And the next one is 3. Next one is 4. Next one is 2. Is the order of boiling point. One of the time they ask the question. This is only now. This is related to boiling point. Next one, acidic nature. Acidic nature of alcohols and phenols. Already we discussed basic nature, amine chapter. Basic nature we discussed. Basic nature is directly proportional to plus I and plus M, inversely proportional to minus I and minus M. As it is, reverse. Acidic nature directly proportional to minus I and minus M. That means electron withdrawing group. Electron withdrawing group increases, acidic nature increases. In case of plus I and plus M, inversely proportional. That is called electron donating or electron releasing group. Electron releasing group increases, acidic nature of alcohol and phenol decreases. Electron withdrawing group increases, acidic nature of alcohol and phenol increases. Otherwise, next one, pKa. First we have to know pKa means H plus ion concentration. H plus ion concentration increases, Ka value increases. Before I told Kb. Kb is dissociation constant of base. Now Ka, dissociation constant of acid. This dissociation constant of acid purely depends on concentration of H plus ion. Concentration of H plus ion is more. H plus ion is more means more number of H plus. More number of H plus means releasing tendency more H plus. More H plus means more acidic. That means H plus ion concentration increases, Ka value increases. What about pKa? pKa value decreases. Finally, acidic nature is increases. This is the last point. This is the information. H plus ion concentration increases, Ka increases. pKa value decreases. What about acidic nature increases. Based on this, I am going to give the one question. What is the question to you? First one. What is this one? Phenol. What is this one? Ethanol. In these two, which one is the more acidic? Phenol and ethanol. Phenol is aromatic compound. Ethanol is aliphatic compound. Right? In these two, which one is the more acidic? Which one is the more acidic? Means phenol is more acidic than alcohol. This is exactly reverse to basic nature. That means aromatic compounds are more acidic than aliphatic compound. This is exactly reverse to basic nature I told you. Aliphatic compounds are more basic than aromatic compound. So same reason. Why it is more acidic? More acidic means observe clearly. Observe clearly. This oxygen atom attached to this carbon, mean this what you call aryl carbon, aryl group, otherwise benzene ring simply, or phenyl ring. Now oxygen atom this attached to this carbon is which hybridization? sp2. But here oxygen atom attached to this carbon, that carbon hybridization is sp3. Same concept, sp3. Here hydroxyl or oxygen atom attached to sp3 hybridized carbon. Here oxygen attached to sp2 hybridized carbon. sp2 hybridized carbon in these two percentage of S character, which one is more? This one. Phenyl ring is more than alkyl. Why? Because percentage, so sp2 and sp3, percentage of S character directly proportional to En. More electronegative, that means this is more electronegative atom. That means simply this what you can say, aryl ring is more electronegative means what? Minus I. Electronegative atoms are minus I, electronegative halogens are minus I. Minus I means electron withdrawing nature. That means aryl group is electron withdrawing nature. Why? Aryl group is electron withdrawing nature because of sp2 hybridization. Why sp2 hybridization? Oxygen group attached to sp2 hybridized carbon. So what happened? Electronegativity is more. Electronegativity is more means what happened? Electron withdrawing tendency is more. Withdrawing tendency. So what happened? Electron withdraw from oxygen. Withdraw means what happened here? Electron density is decreases on oxygen atom. Electron density is decreases means oxygen hydrogen bond strength will be weak. Listen carefully what I am saying. This is electron withdraw. Electron withdraw means what happened? Electron withdrawing from oxygen atom, that time electron density is decreases on oxygen atom. Electron density decreases means what happened? Oxygen hydrogen bond strength will be weak. Then hydrogen is coming as very easy. Hydrogen coming as H plus. That means bond is breaking very easy means H is coming as H plus. H plus means that is called tendency to lose of proton is called acid. That is the reason, first reason. That means sp2 hybridized carbon, because of sp2 hybridized carbon it is acting as a minus I. Because of minus I, electron density decreases on oxygen atom. That time oxygen hydrogen bond strength will be weak, then it is acting as a more acidic. That is the first point. Second point, resonance. Observe here, OH. After loss of proton it changes to what? After loss of proton changes to phenoxide ion. Phenoxide ion are in the conjugation. Conjugation means it involves in resonance. Conjugation means double bond, single bond, negative charge. Conjugation. Conjugation means it involves in resonance. Because of resonance it will be stable. That means resonance means more number of resonance structure, more stable. How to know? It will give the 4 resonance structures. More number of resonance structure, more stable. More stable intermediate is the major product. That more stable intermediate is the more acidic. More stable. Otherwise, this acid. Acid loss of proton changes to what? Conjugate base. Acid loss of proton changes to conjugate base. Conjugate base is stable. Conjugate base related alcohol is more acidic. This is more stable. That means more stable intermediate. More stable intermediate is the more acidic. That's it is the reason. So second reason is resonance. First reason is minus I. Second reason is resonance. Because of these two reasons, it is more acidic. Why it is less acidic? Acidic means what happened? Oxygen attached this group is sp3. More electronegative. That is less electronegative. That is leave it now. That point is not explained. O attached this ethyl. Ethyl means which group? Plus I. Plus I. Also called plus H. Okay, simply plus I. Plus I means what? Electron donating group. Electron donating groups are there. That means electrons will be released. Electron donated to the oxygen atom. That will not happen. What happened now? What happened? Electron density is increased in oxygen atom. That time oxygen hydrogen bond strength will be strong. It is not able to donate proton. That's it is less acidic. Finally, phenol is more acidic than what do you call? Ethanol. In case of pKa value, phenol is experimental value, pKa value is it? This is 10. No need to remember, just I am saying you. This one is 15.9, 15.9, around 16, 15.9 16 pKa value. In this which one is the lower pKa? Phenol is lower pKa. Which one higher pKa? Ethanol is higher pKa. Lower pKa means pKa value decreases. What about acidic nature? Increases. That's why it is more acidic. That is one of the option. Right, next one. Some other question. Orthonitrophenol, metanitrophenol, paranitrophenol. In this which one is more acidic? So NO2 group, that is what? Minus I and minus M. Here minus I only. In case of aromatic compounds, here meta position will not affect, mesomeric effect, resonance effect, meta position will not affect. It will affect on only ortho and para position, that will only minus I. Here also minus I and minus M. Which one is the more acidic? Which one is the more acidic? In these three, para is the more acidic, then ortho, later meta. This is the answer only now. Para, ortho, meta. Otherwise, pKa will observe now. This one ortho is 7.2, meta is 8.3, para is 7.1. pKa values. I am saying pKa values. Lower pKa which one? Para. Lower pKa means pKa value lower, acidic nature is more. That is, it is highest. Next one this one, least one this one. Because higher pKa. Now in case of cresols, observe now. Orthocresol, metacresol, paracresol. These three, which one is the more acidic? Orthocresol means here also plus I and plus M and plus H also, hyperconjugation also. Electron donating group. Electron donating groups are there. Acidic nature will be, electron donating groups increases, acidic nature will be decreases. This one here, only plus I and plus H. Mesomeric effect will not affect. Next one. Sorry, plus I, plus M and plus H only now. That means electron donating group increases, acidic nature decreases. So in this which one highest? Which one highest means first one in this meta. Next one is ortho greater than para actual, we will expect. But experimental values are showing pKa values observed clearly. This one is 10.2, this also 10.2, this is 10.1. Which one? Meta is 10.1 pKa value, ortho and para is 10.2, 10.2. So which one is the more pKa? Ortho and para. Which one lower pKa? Meta. Lower pKa, more acidic. That means meta. Okay. Next ortho para. Ortho and para. Ortho is more than para. We will expect, but experimental values are showing ortho and para. Ortho and para is same. That's answer is finally meta. Ortho equal to para. That is the information about what you call acidic nature. Next. Some other question, last question, one of the time they ask the question. Propane 1 mole, that is number 1. 2, 4, 6 trinitrophenol, TNP, trinitrophenol. Third one, 3 nitrophenol. Fourth one, 3, 5 dinitrophenol. 3, 5 dinitrophenol. Fourth one, this is fourth, this is fifth one, phenol. Sixth one, 4-methyl phenol. This is the question, one of the time they ask. Propane 1 mole, first structures you have to know. Propane 1 mole, that is aliphatic. Phenol 2, 4, 6, that is called 2, 4, trinitrophenol is also called picric acid. OH 3 nitrophenol. Next one, OH 3, 5 dinitrophenol. 1, 2, 3, 4, 5 is phenol. Sixth one is 4-methyl phenol. That means paracresol. These are the compounds. First one. So these are these 5, 1, 2, 3, 4, 5, 6. These 5 these are aromatic. This is aliphatic. So finally, what you have to know? Aromatic compounds are more acidic than aliphatic. That's why finally this is fixed. This is least. That's the last one. In this, these are the highest. In these 3, in this total 5, which are highest? Highest means first you have to know. This NO2, NO2, NO2. That means minus I and minus M. Minus I, minus M, minus I, minus M. This also minus I, minus M. So minus means M will not affect. This is minus I and minus I. Electron withdrawing. Meta. So this sp2, that is leave it now. Here CH3, that is what? Plus I, plus M and plus H. Right? What you have to know? Already written. Acidic nature is directly proportional to minus I and minus M. These 3 are the minus I, minus M. That means minus I only now. So minus I and minus M. Where is the minus I, minus M? This one. More. Because more number of electron withdrawing groups are there. More number of electron withdrawing group, more acidic. So that's why 1, 2. 2 is the highest. Next in these 3, in these 2. In these 2, which one highest? This one, because here 3 NO2, here 2 NO2. That's why the next one is 1, 2, 3, 4. Fourth one. Next one NO2. Third one. So that's why 2, 4, 3 first. 2, 4, 3. Next, in these 2, which one is the more acidic? In these 2. Both are aromatic compounds, but here electron releasing groups are there. Electron releasing group is there. What happened? Acidic nature will be decreases. So that's why these are electron withdrawing group, this is electron releasing group, this is in between that. That's this one, that means in between means neutral. So next one, 1, 2, 3, 4, 5. Next one, 6. Last one is 1. So aliphatic compounds are least one. So answer is first 2, 2 after 4, 4 after 3, 3 after 5, 5 after 6, 6 after 1. This is the order now. One of the time they ask in the NEET question. Right? This is the information about what do you call acidic nature. Now some other questions we are going to solve, some other different questions. How many monohydric phenols? How many monohydric phenols, alcohols and ethers? This is the question. How many monohydric phenols, alcohols, ethers produced by the molecular formula? Molecular formula is C7H8O. This is the molecular formula they are given, C7H8O. In this C7H8O, how many monohydric phenols is formed? Phenols, alcohols, ethers. Observe first one, phenol. Phenol means compulsory 6 carbons we need. 6 carbon. Total how many carbons are there? 7. OH, 6 carbons, that is called phenol. Still 1 carbon is there. 1 carbon means we have to keep one substituent. A total 7 carbon. Observe here. This structure, that molecular formula satisfied or not? Total 7 carbon. Yes, 6 carbon ring, 1 carbon, 7. How many hydrogens? 8 hydrogens are there. That means benzene ring is having the 4. 1, 2, 3, 4 plus 3 hydrogens, 7. 7 plus 1, 8. How many oxygen? 1. Okay, satisfied. Now position we have to change. One is ortho, meta, para. Only these three only possible. Orthocresol, metacresol, paracresol. That is called monohydric phenol. Monohydric means only one OH will be present on the benzene ring. Next, alcohols. Alcohols. Total 7 carbon. First 6 carbon ring, CH2 with OH. Total observe now, 6 carbon here, this 1 carbon, 7 carbon, total hydrogen, here 5 hydrogens, here 2 hydrogens, 7 plus 1, 8 hydrogen, 1 oxygen. So, this is the alcohol. Why you call this alcohol? That means OH group is not directly attached to the benzene ring. OH group attached to alkyl group, this is called alcohol. Alcohol means aliphatic. OH group directly attached to benzene ring, that is called aromatic. Aromatic means that is called phenol. Now, this is called alcohol. So, alcohol is 1. Now, phenols are 3. Ethers. Benzene ring compulsory because 7 carbon is there means 6 carbon compulsory benzene ring. O and CH3. Again check it now. Yes, total 6 carbon, here 1 carbon, 7 carbon, here 5 hydrogens, here 3 hydrogens, 8 hydrogens, 1 oxygen. So, satisfied. This is called ether, aromatic ether. That is called methoxybenzene, also called anisole. So, that means monohydric phenols are 3, monohydric alcohols are 1, next one is monohydric ethers are 1. So, total 3, 1, 1. So, total isomers are 3 plus 1 plus 1, total 5 isomers. Total isomers are 5 and for different isomers are 3, 1, 1. This is the one of the time they ask the question. First question, next one, statement 1. Statement 1, statement based question this one. Phenol reacting with chloroform and aqueous KOH, then followed by NaOH followed by acidification. So, one of the product you will get it you. That product is para. Para product is the major product. This is statement 1. Right? What is the question? Phenol reacting with chloroform followed by aqueous KOH followed by NaOH followed by H plus acidification. You will get the one product. That product is you will get the ortho and para. Now what they are saying here? Para is the major product. This is statement 1. Statement 2. Statement 2. Para and ortho can be products can be separated by steam distillation. Steam distillation. This is one of the neat question. Observe here. This statement 1 and statement 2. First one, we need to identify this reaction. Which reaction? Which named reaction? Phenol reacting with chloroform and KOH followed by NaOH followed by H plus. So, in what I can get the product? First one, phenol reacting with chloroform KOH, what I can get? O minus Na plus CHCl2. This is called intermediate. This reaction is called as actually named reaction. That named reaction is called as Reimer-Tiemann reaction. This is the intermediate. This is followed by NaOH, aqueous NaOH. These two chlorines are replaced by 2 OH, then followed by H plus. You can get the product is this one. What is this? OH and CHO. What is called? Orthohydroxybenzaldehyde is the major product. And including para also will form. Para hydroxybenzaldehyde. This also will form, but this is very, very lesser amount. Orthohydroxybenzaldehyde and para hydroxybenzaldehyde. In this, which one is the major product? Till now we know. What we know? Electrophilic substitution reaction, para product is the major product. Yes, correct only now. But this also electrophilic substitution. How electrophilic substitution? First intermediate is what is the intermediate? That you have to know. Chloroform reacting with NaOH. Then what I can get? Here OH and HCl eliminate, OH and H water eliminate, Na and Cl, NaCl eliminate. So eliminated product you write it first. Na and Cl, NaCl, H and OH, water. Remaining what is there now? Remaining what is there now? Here carbon is there, one chlorine already eliminated, hydrogen also eliminated, two chlorines are there. This is the intermediate. So hydrogen and chlorine at a time you are eliminating means you will get the one pair, one lone pair. This is called dichlorocarbene. Dichlorocarbene. Dichlorocarbene is the one of the electrophile. One of the electrophile, how to know, sir? This carbon surrounding by how many bonds? 2 bonds. That means 2 bonds mean 2 chlorine. That is called 4 electron. Again one lone pair is there. Total how many electrons are there? 6 electrons are there. To get octet means how many electrons we need? Still more 2 electrons we need. That means that is the meaning. 2 electrons are deficient. Electron deficient species called as what you call electrophile. That's it is electrophile. It electrophile means already we know benzene and benzene derivatives undergo which type of reaction? Electrophilic substitution reaction. That's why electrophilic substitution reaction. Finally, Riemann-Tiemann reaction is a electrophilic substitution reaction. Electrophile is dichlorocarbene. So electrophilic substitution reaction means you will get the two products. One is ortho product, second one is para product. In these two, which one is the major product? Para is the major product than the ortho. We know all of you. But in this case, named reaction, two named reactions are there. One is Riemann-Tiemann, second one is Kolbe reaction. These two reactions, ortho is the major product than the para. What the reasons are? Why? Reason is there. Clearly observe now. OH and C double bond OH, that is called orthohydroxybenzaldehyde, also called salicylaldehyde. Next one is para-hydroxybenzaldehyde. Second one. In this orthohydroxybenzaldehyde, what will happen? Here orthohydroxy, here OH is there, here hydrogen, here oxygen. Oxygen of carbonyl compound, hydrogen of alcohol to form a hydrogen bond. Which hydrogen bond? Intramolecular hydrogen bond. Which one is formed intramolecular hydrogen bond? That is called chelation. Chelation. Chelation means what? Formation of the ring. Cyclic compound is called chelation, also called ring formation. Which one is able to form ring, also called chelation? That is more stable compared to some other one. So which one is able to form ring formation? Ortho than compared to para. That's which one is more stable? Ortho is more stable. Ortho is more stable means more stable intermediate you will get major product. That is the reason. Finally, what you have to conclude? Ortho is the major, para is the minor because of intramolecular hydrogen bond. So first statement observe now. So product is from product, para is the major. But which one is the major actually? Ortho is the major. That's why statement 1 is wrong. That means false. Next one. Statement 2. Ortho and para can be separated by steam distillation. Yes, correct only now. Ortho, this is para. Ortho and para, which one is able to form intramolecular hydrogen bond? Ortho. This ortho is able to form intramolecular hydrogen bond. Para is able to form intermolecular hydrogen bond. Observe here, intermolecular hydrogen bond. para-hydroxy-benzaldehyde. Here oxygen is there, here hydrogen is there, hydrogen bond. Here oxygen is there, hydrogen is there, hydrogen bond. Which hydrogen bond? This is called inter. Why you call inter? Hydrogen bond is present between the two polar molecule, that is called inter. Why you call intra? Hydrogen bond present within the molecule, that is called intra. Which one is able to form intramolecular hydrogen bond, that is having more stable and also having the more volatile, more steam volatile. That means more steam volatile means less boiling point. That means which one is the most steam volatile? Which one is able to form intramolecular hydrogen bond? So this is form intramolecular hydrogen bond means it is more steam volatile. More steam volatile means what about boiling point? Less boiling point. Now exactly reversed to the inter. That means this is less steam volatile and more boiling point. Less steam volatile, more boiling point. So finally, which one is steam volatile? Ortho. Ortho is steam volatile means easily evaporate. So easily evaporate means this is not present, only this is present. So you can separate out very easy by using steam distillation. So that's why the statement is correct. Correct means true. Finally, what is the conclusion? Statement 1 is false, statement 2 is true. So that is the answer only now. Right? Okay, ma. Today I will stop. Thank you. Tomorrow I will continue remaining other concepts.
Good morning, dear students. Today I will explain some important concepts of from the chapter excretory products and their elimination. Excretory products and their elimination. From this chapter, I will explain firstly about counter current mechanism. Counter current mechanism. So, what is the importance of counter current mechanism means to concentrate the filtrate. What is filtrate means when our both kidneys filters blood in the glomerulus, the resultant product is formed in the lumina Bowman's capsules, no, that is called filtrate. So, that filtrate will be 300 milliosmol per liter concentration will be present. At the end of the collecting duct, it will be 1200 milliosmol per liter. That means urine or filtrate is 4 times concentrated than the initial filtration. How that concentration of our urine takes place, that is the concept counter current mechanism. So, firstly, which animals have capacity to produce concentrated urine means mammals. Mammals have ability to produce concentrated urine. Concentrated urine. So, which organisms have ability to produce concentrated urine? Mammals. Okay, all the mammals can have capacity to produce concentrated urine because to minimize the water loss, to conserve the water. So, that is the purpose of production of concentrated urine. Okay, then you all know that which structures in our body helps in the production of concentrated urine means inside the kidney, because kidneys are the excretory organs. Kidney consists the structural and functional units are called nephrons. In the nephrons, 2 important structures plays very crucial role in the production of concentrated urine. So, the 2 structures are called, number 1, Henle's loop. Henle's loop. And vasa recta. I repeat, Henle's loop and also vasa recta. These 2 structures present in the nephron which play very crucial role in the production of concentrated urine. I repeat, name the 2 structures of the nephron which helps in the concentration of the urine means the one is Henle's loop and the second one is vasa recta. Henle's loop and vasa recta are the 2 structures which helps in the production of concentrated urine. Then what mechanism inside the Henle's loop and vasa recta responsible for production of concentrated urine means counter current. So, here the word counter current represents opposite direction. So, the movement of a fluid must be occurs in the opposite direction. Let me explain. For example, you take this is the Hey, this line above will be considered as a cortex region. Which cortex? Kidney cortex. And this one will be the medulla. Medulla. Okay. So the line above will be the cortex region and below will be the medullary region. So generally if you take a human kidney, the human kidney outer portion of the human kidney, this one. So this one is called a cortex region, like this. This is called cortex region and the central portion is called a medullary region, where Henle's loop is present like this. This is called a Henle's loop. Yeah, this is called a Henle's loop. So Henle's loop contains two limbs. This is called ascending limb and it is called descending limb. So what a product will flows inside the Henle's loop means filtrate. So filtrate moves like downward direction. Hence it is called as ascending limb of high to low na, descending limb of Henle's loop. So Henle's loop contains two limbs ma. This is called a descending limb of Henle's loop and it is called as ascending limb of Henle's loop. Both in the descending limb of Henle's loop and ascending limb of Henle's loop, what will flows? Filtrate flows. Filtrate means what? As a result of glomerular filtration, the blood will be filtered and the remaining component will be formed in the lumen of Bowman's capsule is called filtrate. Here, if you observe carefully in this diagram, filtrate, the flow of filtrate in the two limbs of Henle's loop, not in the same direction, it is in the opposite direction. So this flow of filtrate in the two limbs of Henle's loop is opposite direction. This is called counter current. So I repeat, in the Henle's loop counter current will occurs or not? So occurs. What is counter current means? The flow of filtrate in the two limbs of Henle's loop will be opposite direction. So I will write here, in the Henle's loop the flow of filtrate in two limbs of Henle's loop will be opposite direction. Opposite direction. So this is called counter current. Counter current. That means counter current occurs in the Henle's loop. Secondly, the Henle's loop is closely associated with another important structure is called vasa recta. What it is called ma? Vasa recta. So this is called vasa recta. Yeah, vasa recta. In the vasa recta, what exactly flows ma? In the vasa recta, blood flows, right? So this is called descending limb of vasa recta and this is called ascending limb of vasa recta. In the two limbs of vasa recta also, the blood flows in opposite direction. Blood flows in opposite direction. So this is also forms counter current. That means counter current not only occurs in the Henle's loop it will also occurs the flow of blood in the two limbs of vasa recta will also shows counter current. So I repeat, the flow of filtrate in the two limbs of vasa recta, Henle's loop, and also the flow of blood in the two limbs of vasa recta is always in opposite direction. This is actually, we call it a counter current. What do you call it, ma? Counter current mechanism. Yeah. So ascending limb of Henle's loop. This one descending limb of vasa recta. This one ascending limb of vasa recta. Okay ma? Now, so counter current is one of the reason for production of concentrated urine, and the second one, the proximity between Henle's loop and vasa recta. Henle's loop and vasa recta will be very close proximity. Just you imagine nephron structure. So descending and ascending limb of Henle's loop ge very close proximity alli vasa recta anno U shaped blood vessel locate agirutte. So that close proximity is also one of the reason for production of concentrated urine. How? We will see now. If the distance between Henle's loop and vasa recta is very far, there is no chance to exchange of electrolytes between these two limbs. If no exchange of electrolytes, there is no chance to increasing of osmolarity in the medulla. So very close proximity is also one of the reason. Second one, counter current. ಈ ತರ opposite direction ಅಲ್ಲಿ fluid or filtrate ಮತ್ತು blood transport ಆಗೋ mechanism is also one of the reason for increasing of osmolarity. How that will be happens, we'll see now. I repeat, what are the two mechanisms responsible for increasing of osmolarity means number one, the proximity. Second one, what ma? The counter current between Henle's loop and vasa recta will increases the osmolarity. Where? In the medulla or in the medullary interstitium. So in the medullary interstitium, osmolarity increases from 300 milliosmol per liter to 1200 milliosmol per liter. So here in the cortex region, what will be the osmolarity andre just 300 milliosmol per liter will be present. So it will be increased into 1200 milliosmol per liter. So what will be the main reason of the increasing of osmolarity from 300 to 1200 when the fluid moving from cortex to medullary region? Andre two important mechanisms. Number one is the proximity. Andre ಈ ಥರ ಹೆನ್ಲೀಸ್ ಲೂಪ್ ಮತ್ತು ವ್ಯಾಸಾ ರೆಕ್ಟಾ ವೆರಿ ಕ್ಲೋಸ್ ಪ್ರಾಕ್ಸಿಮಿಟಿಯಲ್ಲಿ ಇರೋದು ಒನ್ ಆಫ್ ದ ಅಡ್ವಾಂಟೇಜ್. ಸೆಕೆಂಡ್ ಒನ್, counter current, the flow of filtrate and the flow of blood in the two limbs of Henle's loop and vasa recta is always in opposite direction. So which is also one of the responsible for increasing of osmolarity from the 300 milliosmol from the cortex region to 1200 milliosmol into the medullary region. I repeat, what is the osmolarity in the cortex region of the kidney? 300 milliosmol per liter. What is the osmolarity of the medulla region? 1200 milliosmol per liter. Then, sir, only this proximity's counter current is enough to increase the osmolarity towards the medulla. Means wrong, because the two substances plays very important role in the increasing of this osmolarity in the medulla. What are the two substances? Means number one, NaCl, and number two, urea. So NaCl and urea will be the main reason for increasing of medullary osmolarity. Medullary osmolarity. Name the substances which are responsible for increasing of medullary osmolarity. Means one is NaCl, second one is urea. Now I will try to explain how NaCl will increases osmolarity from 300 milliosmol per liter to 1200 milliosmol per liter. Okay, first Sima NaCl ಬಗ್ಗೆ ನಾನು ಹೇಳ್ತಾ ಇದ್ದೀನಿ. NaCl ಮೆಡುಲ್ಲಾ ಒಳಗಡೆ ಆಸ್ಮೊಲಾರಿಟಿನ ಹೇಗೆ ಜಾಸ್ತಿ ಮಾಡುತ್ತೆ ಅನ್ನೋದ್ರ ಕಾನ್ಸೆಪ್ಟ್. ಸೊ ಮೆಡುಲ್ಲಾ ಒಳಗಡೆ ಆಸ್ಮೊಲಾರಿಟಿ ಜಾಸ್ತಿ ಆಗಬೇಕು ಅಂದರೆ ಮೆಡುಲ್ಲಾದಲ್ಲಿ NaCl ಡಿಪಾಸಿಟ್ ಆಗಬೇಕು. NaCl ಎಲ್ಲಿಂದ ಯಾವ ಥರ ಡಿಪಾಸಿಟ್ ಆಗುತ್ತೆ ಅನ್ನೋದು ಈಗ ನೋಡೋಣ. ಫಸ್ಟ್ ಫ್ರಮ್ ದ ascending limb of Henle's loop. What is this one, ma? Ascending limb of Henle's loop it is, right, ma? From the ascending limb of Henle's loop, a small amount of NaCl. From the ascending limb of Henle's loop, a small amount of NaCl exit and enters into the or exchanged into the descending limb of vasa recta. I repeat, a small amount of NaCl from the ascending limb of Henle's loop exchanged with the descending limb of vasa recta. Here from the filtrate, because ascending limb of Henle's loop is permeable to sodium chloride electrolytes, right, ma? So called NaCl will comes outside. If NaCl comes outside, osmolarity concentration gradients in the filtrate ಏನಾಗುತ್ತೆ, ಕಡಿಮೆ ಆಗುತ್ತೆ. ಅದೇ ಥರ NaCl ಬ್ಲಡ್ ಅಲ್ಲಿ ಎಂಟ್ರಿ ಆಗೋದ್ರಿಂದ ವ್ಯಾಲ್ಯೂಮ್ ಏನಾಗುತ್ತೆ, ಬ್ಲಡ್ ವ್ಯಾಲ್ಯೂಮ್ ಐ ಮೀನ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಗ್ರೇಡಿಯಂಟ್ಸ್ ವಿಲ್ ಬಿ ಇನ್ಕ್ರೀಸಸ್. ಅಂದರೆ ಇಲ್ಲಿ 300 ಅನ್ಕೊಂಡ್ರೆ ಹಿಯರ್ ವಿಲ್ ಬಿ ದ 400 ಆಗುತ್ತೆ. ಬಿಕಾಸ್ ಆಫ್ ಎಕ್ಸಿಟ್ ಆಫ್ NaCl ಇನ್ ದ ಫಿಲ್ಟ್ರೇಟ್, ಕಾನ್ಸಂಟ್ರೇಷನ್ ಗ್ರೇಡಿಯಂಟ್ಸ್ ಡಿಕ್ರೀಸಸ್. ಇನ್ ದ vasa recta, concentration gradients will be increases. As a result, this will be repeatedly occurs. A small amount of NaCl from the ascending limb of Henle's loop exchanged with the descending limb of vasa recta. Now, the NaCl from the ascending limb of Henle's loop, where it is present, ma? In the descending limb of vasa recta. In the descending limb of vasa recta, what will flow, ma? Blood is flowing. So now NaCl is present in the blood of descending limb of vasa recta. So along with the blood of descending limb of vasa recta, NaCl also transported like this. See, it will be transported and it will comes to the ascending limb of vasa recta, where when the NaCl comes to the ascending limb of vasa recta, that NaCl finally returns to the medullary region like this. The NaCl returns to the medulla. Just imagine if all the NaCl frequently returns to the medulla, in the medullary region NaCl concentration what happens? Increases. So if NaCl concentration is increases in the medulla concentration gradients or osmolarity will increases or decreases? Increases. So in this way NaCl increases the medullary concentration gradients. Okay, this is one reason why the osmolarity increases from cortex 300 to 1200 in the medulla andre, this is one of the reason. Okay, suppose so in the cortex region 1200 alva, so ಇಲ್ಲಿ ಬರ್ತಾ ಇದ್ರೆ as NaCl is added it will be 400, 600, 800, 1000 and 1200. So ಈ ತರ increase ಆಗ್ತಾ ಬರುತ್ತೆ. Similarly ಯಾವುದರಲ್ಲಿ descending limb of vasa recta osmolarity increases from 300 to 1200. In the same case in the descending limb of vasa recta also same takes place. Yakandre exit of water takes place. Descending limb of vasa recta is permeable to water, right? As water loss takes place, what will happen? The filtrate will be concentrated into 3, 4, 600, 800, 1000, 1200. So in the descending limb of Henle's loop, in the descending limb of vasa recta, osmolarity will be increases from 300 to 1200 as it moves from cortex to medulla. But in the case of ascending limb of Henle's loop and ascending limb of vasa recta, what will happen? Concentration gradients decreases. ಯಾಕೆ ಹೇಳಿ ಇಲ್ಲಿ NaCl ಎಲ್ಲ ಲಾಸ್ ಆಗ್ತಾ ಇದೆ. ಸೊ 800, 600, 400, 300 milliosmol. Here also NaCl will lose us, right? So 1000, 800, 600, 400, 300. So in the two limbs of descending limbs of vasa recta and Henle's loop, osmolarity will be increases from cortex to medulla. When we move from medulla to cortex, in the ascending limb of vasa recta and ascending limb of Henle's loop, osmolarity decreases from 1200 milliosmol to 300 milliosmol. Okay ma? ಏನಾದರೂ ಆಗಲಿ ಇಲ್ಲಿ NaCl ಈ ಥರ ಎಕ್ಸ್ಚೇಂಜ್ ಆಗೋದ್ರಿಂದ ಈ ಟೂ ಲಿಮ್ಸ್ ಅಲ್ಲಿ ಮೆಡುಲ್ಲಾ ಒಳಗಡೆ NaCl ಕಾನ್ಸಂಟ್ರೇಷನ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಅದರಿಂದ ಮೆಡುಲ್ಲಾದಲ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಗ್ರೇಡಿಯಂಟ್ಸ್ ವಿಲ್ ಬಿ ಇನ್ಕ್ರೀಸಸ್. ಈಸ್ ಇಟ್ ರೈಟ್? ಸೆಕೆಂಡ್ ಒನ್, ಯೂರಿಯಾ. How an urea increases osmolarity in the medulla along with NaCl. See, as the filtrate moves like this and then enters into the DCT, from the DCT to the filtrate enters into the collecting duct. This is called a collecting duct. Now, see ma here, from the collecting duct, a small part of urea, a small amount of urea from the collecting duct. What present in the collecting duct? Filtrate, urine. A collecting duct alli hogtiro urine inda small amount of urine will be exit and enters into the thin segment of ascending limb of Henle's loop. So in the ascending limb of Henle's loop, the filtrate moves upwards now. So along with that filtrate, the small amount of urea is also will flows like this and reach to the DCT, and the DCT to again collecting duct, from where that will be returns into the medulla. So this is repeatedly happens. Yaudu? A small amount of urea exit from the collecting duct and enters into the thin segment of ascending limb of Henle's loop, and it will take one round and returns to the medulla. ಈ ಥರ ಎವ್ರಿ ಟೈಮ್ ಎಕ್ಸಿಟ್ ಎಂಟ್ರಿ ಸಮಯದಲ್ಲಿ some amount of urea remaining in the medulla only. As a result, urea levels will be increases in the medulla. So that will also one of the reason for increasing of concentration from 300 to 1200. Andre illi NaCl at one end, urea at another end. These two substances will deposited in the medullary region, that will increases the concentration gradients from 300 milliosmol per liter cortex to 1200 milliosmol per liter medulla. Did you understand? The two substances are responsible for this NaCl and urea. Illi NaCl urea ಈ ಥರ ಎಕ್ಸಿಟ್ ಎಂಟ್ರಿ ಈ ಎಕ್ಸ್ಚೇಂಜ್ ಆಗೋದಕ್ಕೆ ಮೇನ್ ಕಾರಣ ವಾಟ್ ಯು ನೋ, ಒನ್ ಈಸ್ ಕೌಂಟರ್ ಕರೆಂಟ್ ಮೆಕಾನಿಸಮ್, ಸೆಕೆಂಡ್ ಒನ್ ಪ್ರಾಕ್ಸಿಮಿಟಿ. ನೋಡಿ, ಈ ಡಿಸ್ಟೆನ್ಸ್ ಏನಾದರೂ ವೆರಿ ಫಾರ್ ಇದ್ದಿದ್ರೆ ಈ ಥರ ಎಕ್ಸ್ಚೇಂಜ್ ಆಗೋದಕ್ಕೆ ಚಾನ್ಸ್ ಇರ್ತಾ ಇದ್ದಿಲ್ಲ. ನಂಬರ್ ಟು, ಈ ಎರಡು ಲಿಂಬ್ಸಲ್ಲಿ ಆಪೋಸಿಟ್ ಡೈರೆಕ್ಷನಲ್ಲಿ ನಾವು ಫ್ಲೋ ನೋಡಿಲ್ಲ ಅಂದರೆ ಈ ಥರ ಎಕ್ಸಿಟ್ ಆ್ಯಂಡ್ ಎಂಟ್ರಿ ಆಗೋಕ್ಕೂ ಚಾನ್ಸ್ ಇರ್ತಾ ಇದ್ದಿಲ್ಲ. ಸೊ proximity and counter current within the Henle's loop and vasa recta will be the main reason for the increasing of osmolarity. And which substances plays very crucial role in the increasing of osmolarity? NaCl plus urea also. Is it right? As a result, in the medullary region, NaCl and urea levels are increases. As a result, in the medulla, osmolarity or concentration gradients of ions will be increases. Then the filtrate present in the collecting duct. Now collecting duct alliro concentration gradients compare ಮಾಡಿದ್ರೆ ಮೆಡುಲ್ಲಾದಲ್ಲಿರೋ concentration gradients ಜಾಸ್ತಿ ಇದೆ. As a result, water molecules are always moves from lower concentration gradients to higher concentration gradients. Is it right, ma? As a result, the water from the collecting duct all will be reabsorbed by the exit from collecting duct into the blood vessels. If as water ions, all the water comes outside from the urine becomes diluted, concentrated. So concentrated urine will be producers. Concentrated urine will be producers. At the end of the collecting duct, what will be the osmolarity andre 1200 milli osmol per liter. Nodri, initial stage ಅಲ್ಲಿ ಎಷ್ಟಿದೆ ಕಾರ್ಟೆಕ್ಸ್ ಅಲ್ಲಿ 300 milli osmol per liter. At the end of after counter current mechanism, how much concentration gradients? 1200. Andre almost 4 times the initial filtrate was concentrated. So all human beings or human kidneys can produce 4 times concentrated urine than the initial filtrate. So initial filtrate 300 ml milliosmol per liter ಇದ್ರೆ ನಾವು ಎಕ್ಸ್ಕ್ರೀಟ್ ಮಾಡೋ ಯೂರಿನ್ 1200 milliosmol per liter ಇರುತ್ತೆ. For that, the main reason is counter current mechanism. You understand, ma? You must remember that. Point number 1, which animals will have ability to produce concentrated urine? Answer is mammals. Second one, which structures of the nephron plays important role in the production of concentrated urine in the mammals? Answer, number 1 Henle's loop, number 2 vasa recta. Third, what is counter current? The flow of filtrate and the flow of blood in the two limbs of vasa recta, in the two limbs of Henle's loop respectively moves opposite direction. That is called counter current. So counter current occurs in the Henle's loop and vasa recta too. And fourth statement, what mechanism is mainly responsible for the increasing of osmolarity from the cortex 300 milliosmol per liter to 1200 milliosmol per liter medulla? One is the proximity, second one counter current within Henle's loop and vasa recta. Sixth statement, which substances plays crucial role increasing of the concentration gradients in the medulla? Number 1 NaCl, number 2 urea. So how NaCl is responsible andre, this is very clear. So from the ascending limb of Henle's loop, small amount of NaCl exchanged with the descending limb of vasa recta, and it will finally returns to the medulla from the ascending limb of vasa recta. As a result, NaCl concentration will be increases. Second, a small amount of urea from the collecting duct enters into the thin segment of ascending limb of Henle's loop, and again it will returns to the medulla. So where urea levels are increases. So NaCl and urea both will increases the osmolarity in the medulla. When osmolarity is increased in the medulla, then the filtrate present in the collecting duct. All the water reabsorption takes place from the filtrate. As a result, urine becomes concentrated. How many times? 4 times concentrated than the initial filtration. Understand ma? This is about mechanism of counter current. Okay na? So very very important topic, concentrate on this. Can I erase this one? Tell me now, what is the osmolarity in the U-shaped Henle's loop ma? 1200 milliosmol per liter. What is the osmolarity in the cortex region of the kidney? 300 milliosmol per liter. Okay. And the second topic is regulation of kidney functions. Another important topic, regulation of kidney functions. Regulation of kidney functions. Kidney functions are regulated by 3 important structures. Number 1, hypothalamus. Hypothalamus. Number 2, juxtaglomerular apparatus, JGA. Number 3, heart. So these 3 structures can regulate the kidney functions of our body. So first, how hypothalamus regulates kidney functions in our body, we will see now ma. So here, first hypothalamus. Okay. Situation number 1, suppose whenever the blood volume, okay, I will explain here. Whenever the blood volume or body fluid volume or ionic concentration or when ionic concentration is decreased or decreases in our body, homeostasis is very very essential. Homeostasis means sufficient water, all minerals and everything will be required an optimum required amount only. excess or less, both are abnormal. So here also, suppose a condition number 1, when the blood volume is decreases in our body, or body fluid volume is decreases in our body, or any ionic concentration gradients decreases in our body, or when excess loss of fluids from our body, what happens? It will activate, immediately activates osmoreceptors. Osmoreceptors. Where osmoreceptors are present in our body? Present in the hypothalamus. Hypothalamus. I repeat whenever in our body blood volume or body fluid volume or ionic concentration is decreased or decreases, immediately activates osmoreceptors present in the hypothalamus. These osmoreceptors are highly sensitive to these conditions. Andre ನಮ್ಮ ಬಾಡಿಯಲ್ಲಿ ಅಯಾನ್ಸ್ ಮತ್ತು ಬಾಡಿ ಫ್ಲೂಯಿಡ್ಸ್ ಅಲ್ಲಿ ಹೆಚ್ಚು ಮತ್ತು ಜಾಸ್ತಿ ಕಡಿಮೆ ಆದರೆ ಅದಕ್ಕೆ ಈಸಿಯಾಗಿ ರೆಸ್ಪಾಂಡ್ ಆಗೋ ನೇಚರ್ ಆಸ್ಮಾ ರೆಸೆಪ್ಟರ್ಸ್ಗೆ ಇರುತ್ತೆ. ಸೊ ಇನ್ ದಟ್ ವೇ ಆಸ್ಮಾ ರೆಸೆಪ್ಟರ್ಸ್ ಆರ್ activated by the hypothalamus. If once asthma receptors are activated, you know what happens? These asthma receptors stimulates neurohypophysis and releases ADH, also known as vasopressin hormone. ADH or vasopressin hormone from the neurohypophysis. So neurohypophysis is one of the anatomical region of pituitary gland, right ma? Pituitary gland is anatomically divided into two regions. One is anterior pituitary, second one is posterior pituitary. Here posterior pituitary is also known as neurohypophysis. Why? Because posterior pituitary gland do not secrete any hormones. Both vasopressin and oxytocin produced from the hypothalamus and reaches to the posterior pituitary or neurohypophysis through axonally. So where it's temporarily stored, that's it. Hence it is called as neurohypophysis antare. Yakandre it is direct connection with the hypothalamus with the help of neurons. So here from that neurohypophysis in the ADH, antidiuretic hormone or vasopressin hormone release ಆಗೋ ಥರ ಆಸ್ಮಾ ರೆಸೆಪ್ಟರ್ಸ್ ಮಾಡುತ್ತೆ. Then if once asthma receptors releases ADH and vasopressin, this ADH and vasopressin perform two functions. It will do two works. Work number 1. So this ADH or vasopressin acts as a vasoconstrictor. Vasoconstrictor means what ma? This hormone whenever it releases into the blood, it will cause us contractions of blood vessels. Just imagine if all the blood vessels are contracted because of ADH, inside the blood vessels the blood pressure will be what happens? Increases. If the blood pressure is increases, glomerular filtration rate what happens? Will also increases. That means ADH will helps in the increasing of blood pressure, glomerular blood flow, glomerular blood pressure, thereby glomerular filtration rate also. I repeat, ADH works as vasoconstrictor. Vaso means blood vessels, Constrictor means contraction. As a result, it will increases glomerular blood flow, and thereby it will also increases glomerular blood pressure, and also thereby increases glomerular filtration rate, GFR. This is one function of ADH. Secondly, ADH will increases the reabsorption of water from the DCT. From the distal convoluted tubules in the vasopressin ಏನು ಮಾಡುತ್ತೆ, reabsorption of water na stimulate ಮಾಡುತ್ತೆ. Just imagine, from the DCT, if all the water will be reabsorption takes place, it will prevent the loss of water through urine, alva. That process is called diuresis, we call it. Diuresis andre the prevention of loss of water through urine. ಯೂರಿನ್ ಇಂದ ಎಕ್ಸೆಸ್ ವಾಟರ್ ಲಾಸ್ ಆಗದಿರ ರೀಅಬ್ಸಾರ್ಪ್ಷನ್ ಮಾಡಿಕೊಂಡು ಪ್ರಿವೆಂಟ್ ಮಾಡುತ್ತೆ. ಅದಕ್ಕೆ ADH ಗೆ ಅನದರ್ ನೇಮ್ ಆಂಟಿ ಡಯೂರಿಟಿಕ್ ಹಾರ್ಮೋನ್ ಅಂತ ಕರೀತಾರೆ. ಆಂಟಿ ಅಂದರೆ ಅಗೇನೆಸ್ಟ್, ಡಯೂರಿಸಿಸ್ ಅಂದರೆ ಪ್ರಿವೆಂಟ್ಸ್ ದ ಲಾಸ್ ಆಫ್ ವಾಟರ್ ಥ್ರೂ ಯೂರಿನ್. ದ ಹಾರ್ಮೋನ್ ವಿಚ್ ವರ್ಕ್ಸ್ ಅಗೇನೆಸ್ಟ್ to prevent, it will helps in the prevention of water through the urine by reabsorption is called antidiuretic hormone. So as a result of diuresis only, what will happens? Increases blood volume. ಯಾಕಂದರೆ ವಾಟರ್ ಕಂಟೆಂಟ್ ಎಲ್ಲ ಎಲ್ಲೋಗುತ್ತೆ, ಬ್ಲಡ್ಗೆ ಹೋಗುತ್ತೆ. ಅವಾಗ ಬ್ಲಡ್ ವ್ಯಾಲ್ಯೂಮ್ ಏನಾಗುತ್ತೆ, ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಇಫ್ ದ ಬ್ಲಡ್ ವ್ಯಾಲ್ಯೂಮ್ is increases, glomerular blood pressure is also increases. If the glomerular blood pressure is increases, glomerular filtration rate is also increases. ಅಂದರೆ ಈ ಕಂಡೀಷನ್ಸ್ ಮತ್ತೆ ಓವರ್ಕಮ್ ಆಗಿಬಿಟ್ಟಿದೆ, ಕರೆಕ್ಟಾ? ಸೊ ಹಿಯರ್ ವೆನ್ ದ ಬ್ಲಡ್ ವ್ಯಾಲ್ಯೂಮ್ ಈಸ್ ಲೋ, this is happens, blood volume is increases. If once blood volume is increases, immediately what happens? It will send signals to the ಏನಾಗುತ್ತೆ, ಆಸ್ಮಾ ರೆಸೆಪ್ಟರ್ಸ್ಗೆ ಸಿಗ್ನಲ್ ಕಳಿಸುತ್ತೆ. ಅಬೌಟ್ ವಾಟ್? ಆಲ್ರೆಡಿ the blood volume, body fluid volume and ionic concentration gradients are increased by the ADH hormone. As a result, asthma receptors are, what will happen? Switched off. If asthma receptors are switched off, what will happen? No release of ADH from the neurohypophysis. Then the problem solved. So this is the first way. Hypothalamus will regulate the ಕಿಡ್ನಿ ಫಂಕ್ಷನ್ಸ್. ಯಾವ ಥರ ಅಂದರೆ ಈ ಥರ, ಯಾವಾಗ ನಮ್ಮ ಬಾಡಿಯಲ್ಲಿ ಬಾಡಿ ಫ್ಲೂಯಿಡ್ ವ್ಯಾಲ್ಯೂಮ್, ಬ್ಲಡ್ ವ್ಯಾಲ್ಯೂಮ್, ಅಯಾನಿಕ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕಡಿಮೆ ಆಗುತ್ತೋ ಈ ಥರ ಈ ಸಿಸ್ಟಮ್ ಆಕ್ಟಿವೇಟ್ ಆಗಿಬಿಟ್ಟು ADHನ ರಿಲೀಸ್ ಮಾಡಿ ಥ್ರೂ ADHಯಿಂದ ಈ ಕಡಿಮೆ ಆಗಿರೋದನ್ನು ಜಾಸ್ತಿ ಮಾಡುತ್ತೆ. ಸೊ ಆಸ್ಮಾ ರೆಸೆಪ್ಟಾರ್ಸ್ ವಿಲ್ ಆಕ್ಟಿವೇಟೆಡ್ ವೆನ್ ದೀಸ್ ಕಂಡೀಷನ್ಸ್ ಆರ್ ಡಿಕ್ರೀಸಸ್. ಆಸ್ಮಾ ರೆಸೆಪ್ಟಾರ್ಸ್ ವಿಲ್ ಬಿ ಸ್ವಿಚ್ಡ್ ಆಫ್ ವೆನ್ ದೀಸ್ ಕಂಡೀಷನ್ಸ್ ವಿಲ್ ಬಿ ಓವರ್ಕಮ್. ಓಕೆ, ಯಾ. And the second one, JGA apparatus. JGA. Yeah. Here JGA full form what ma? Juxtaglomerular apparatus. Juxtaglomerular apparatus. What it is exactly? How juxtaglomerular apparatus is formed means it is formed by the cellular modifications of two types of cells. One is DCT and afferent arteriole. I repeat ma, juxtaglomerular apparatus is formed by the cellular modifications of distal convoluted tubule and afferent arteriole. That means a few cells of DCT, a few cells of afferent arteriole modified with in their contact together forms into a sensitive area, a sensitive region is called juxtaglomerular apparatus. It will perform complex functions. What complex functions when it will perform, we will see now. Very simple. So here also conditions. Condition number 1, whenever glomerular blood flow is decreases or glomerular blood pressure is decreases or whenever glomerular filtration rate is decreased, at these condition, whenever GBF, glomerular blood flow, glomerular blood pressure, glomerular filtration rate is decreased, immediately juxtaglomerular apparatus contain cells called juxtaglomerular cells, JG cells will be activated and releases. JG cells present in the JGA and which will be activates and releases one hormone name called renin. Which hormone ma? Renin. So when the glomerular blood flow or glomerular blood pressure or glomerular filtration rate is low or decreases in our body, immediately juxtaglomerular apparatus containing juxtaglomerular cells will activate and releases one hormone called renin. So this renin hormone will convert one enzyme angiotensinogen into angiotensin 1. Renin will convert angiotensinogen. It is an inactive protein which is produced from the liver So an inactive protein or enzyme which is produced from the liver will be converted into angiotensin 1 with the help of renin hormone. Then soon this angiotensin 1 is converted into angiotensin 2 by the enzyme name called ACE. ACE full form angiotensin converting enzyme we call it. Angiotensin converting enzyme will convert angiotensin 1 into angiotensin 2. Here angiotensin 2 will be the active form. Then this angiotensin 2 perform two functions in our body. First one, angiotensin 2 will act as a vasoconstrictor like ADH. Vasoconstrictor means what? It will cause us contraction of all the blood vessels. Whenever all the blood vessels are contracted, what will happen, ma? It will increases glomerular blood flow because of narrow lumen, right? if the glomerular blood flow is increases, what will increases? Glomerular blood pressure is also increases. If the glomerular blood pressure is increases, it will be also increases glomerular filtration rate. ಅಂದರೆ ಇಲ್ಲಿ ಈ ಹಾರ್ಮೋನ್ ರಿಲೀಸ್ ಆಗೋದಕ್ಕೆ ಮೇನ್ ಕಾರಣ ಈ ಕಂಡೀಷನ್ಸ್ ಇರೋದ್ರಿಂದ, ಹೌದಾ? ಇವಾಗ ಏನಾಗಿದೆ? ದ ಕಂಡೀಷನ್ಸ್ ಆರ್ ಸಾಲ್ವ್ಡ್. ಒಂದು ವೇಳೆ ಈ ವ್ಯಾಸೋ ಕನ್ಸ್ಟ್ರಿಕ್ಟರ್ ಇಂದ ಮತ್ತೆ GBF, GBP, GFR ನಾರ್ಮಲ್ ಸ್ಟೇಜ್ಗೆ ಬಂದಿದೆ ಅನ್ಕೊಳ್ಳಿ, ಈ ಕಾನ್ಸೆಪ್ಟ್ ಇಲ್ಲಿಗೆ ಎಂಡ್ ಆಗುತ್ತೆ. ಈವನ್ ಆಫ್ಟರ್ ವ್ಯಾಸೋ ಕನ್ಸ್ಟ್ರಿಕ್ಟರ್ ಆಲ್ಸೋ, if the GFR is not up to the mark, then the angiotensin 2 by doing another activity also will try to increases the glomerular filtration rate. What is that? This time it will acts on angiotensin 2 acts on adrenal cortex. Adrenal cortex for what? To release one hormone. To release one hormone called aldosterone. Aldosterone. Aldosterone is an hormone which is released from the adrenal cortex. This aldosterone function ಏನು ಅಂದರೆ, it will increases the reabsorption of water plus sodium ions from the DCT of nephrons. As a result, see here, whenever water and sodium ions reabsorption is increased, all the reabsorption content where it will goes? It will go and add to the blood of blood vessels. ಅವಾಗ ಬ್ಲಡ್ ವ್ಯಾಲ್ಯೂಮ್ ಏನಾಗುತ್ತೆ? ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. As a result of this, increases blood volume. If the blood volume is increases, thereby glomerular blood pressure is also increases. If the glomerular blood pressure is increases, thereby increases the glomerular filtration rate also. So then the problem will be solved. Very very important ma. Idinne we can call it RAS system. RAS system means renin angiotensin system anta karitare, because renin, this is the enzyme, angiotensin together perform this activity. Up to now the ADH and even angiotensin 2, these two hormones helps in the increasing the glomerular blood flow, glomerular blood pressure, glomerular filtration rate. Is it right? Then which hormone is responsible for the decreasing these activities? Sir, ಕಡಿಮೆ ಆದರೆ ಇನ್ಕ್ರೀಸ್ ಆಗೋದಕ್ಕೆ ಈ ಎರಡು ಮೆಕ್ಯಾನಿಸಮ್ಸ್ ಇದೆ. ಒಂದು ವೇಳೆ ಜಾಸ್ತಿ ಆದರೆ ಕಡಿಮೆ ಮಾಡೋದಕ್ಕೆ ಯಾರಿದ್ದಾರೆ ಅಂದರೆ ಆ ಥರ್ಡ್ ಒನ್, ಹಾರ್ಟ್. ಹಾರ್ಟ್ ವಿಲ್ ವರ್ಕ್ಸ್ ಅಗೇನೆಸ್ಟ್ ಟು ದ ರಾಸ್. ರಾಸ್ ಸಿಸ್ಟಮ್ಗೆ ಅಗೇನೆಸ್ಟ್ ಆಗಿ ವರ್ಕ್ ಮಾಡೋದೇ ಹಾರ್ಟ್. ಹೌ? ವಿಲ್ ಸಿ ನೌ. And in this topic, you must remember that which hormones will increases glomerular filtration rate by acts as vasoconstrictor. The answer is both ADH and angiotensin 2. Second, which of the following hormones increases the glomerular filtration rate? Means ADH and angiotensin 2 and even aldosterone also. Okay, and the third one is heart. Here whenever glomerular blood pressure is increased or any ನಾರ್ಮಲ್ ಬ್ಲಡ್ ಪ್ರೆಷರನ್ನು ಇನ್ಕ್ರೀಸ್ ಆಗಿದ್ರೆ ಏನಾಗುತ್ತೆ ಅಂದರೆ, ದ ಬ್ಲಡ್ ವಿತ್ ಹೈ ಪ್ರೆಷರ್ ವಿಲ್ ಗೋಸ್ ಟು ದ ಹಾರ್ಟ್, ವೇರ್ ಹಾರ್ಟ್ ಕಂಟೈನ್ ಏಟ್ರಿಯಾ ಆ್ಯಂಡ್ ವೆಂಟ್ರಿಕಲ್, ರೈಟ್? The walls of the atria will be very sensitive to the high blood pressure. They can be sense it. So whenever glomerular blood pressure is increased, you know what happens? The walls of the heart releases one hormone called ANF, atrial natriuretic factor. Atrial andre walls of the atria produces this hormone. Natri andre sodium and factor, okay, uretic, natriuretic factor, uretic andre urine, okay. So atrial natriuretic factor hormone is released from the walls of the atria of the heart. If once ANF is released, this ANF increases, it acts as vasodilator. Array, vasoconstrictor andre enama? Constriction or contraction of blood vessels, right? Vasodilator means what? It will cause us dilation of, relaxation of blood vessels. If the blood vessels are relaxed, what will happen, sir? Decreases the glomerular blood pressure. If the glomerular blood pressure is decreases, automatically decreases the glomerular filtration rate is also. So it is absolutely against to the ROS system, okay. This is what regulation of kidney functions, okay. So prepare well, and today I will stop here, tomorrow will continue, okay ma. Thank you.
Hello, Vinbistan. So good morning students. So the discussion that going on here is biomolecules. Yesterday we have said that biomolecules are the organic compounds which are found in the living organism. These biomolecules, based on their solubility in the acid, which was used was trichloroacetic acid, we can divide them into biomicro and biomacromolecules. These micromolecules are having molecular weight less than 800 Daltons, whereas macromolecules 10,000 Daltons and above. So based on this differentiation, we said that some are monomers, some are polymers. The monomers, the discussion yesterday was completed. We have done with the amino acids and nucleotides already done. So monosaccharides now we are going to discuss. Polysaccharides also means polymers also we have done the discussion related to proteins. So some important points about the proteins. Proteins are always heteropolymers, not the homopolymers. If that is going to be the assertion, reason will be there are 20 different types of amino acids are there which are there involved in the formation of the proteins. Later we told different functions of the protein. Name a protein that involves in the transfer of glucose into the cells. In that case we can consider GLUT4. So which is acting as a hormone, that is insulin, enzyme is going to be the trypsin. That particular table saying the functions of the protein is important. Already they had given in the last examination of the NEET. Later on, now we have to move ahead related to the discussion of this another monomer related polymer. The another monomer to be discussed is going to be these sugars or carbohydrates. Carbohydrates, we can call them as sugars. So proteins related amino acids, nucleotides is the monomers present in the nucleic acid. Nucleic acid and nucleotide discussion already done. Again I am saying here now we are going to enter into the sugars, we can call them as carbohydrates. See, as per textbook heading what they have given, that is a polysaccharides. Polysaccharide is a polymer of the many monosaccharides which are connected by glycosidic bonds. Do you remember the bond present in between two nucleotides? Phosphodiester bond. Whereas the bond present between two amino acids in a protein, that is a peptide bond. And the bond present between lipid molecules like fatty acid and glycerol, that is going to be the ester bond. The bond present in these carbohydrates is going to be glycosidic bond. So these sugars are of different types. First, monosaccharides are there. Monosaccharides are there. Second, disaccharides are there. Even polysaccharides are also there. Polysaccharides. So in this discussion, they have given monosaccharides in different places. I am combining them. So these monosaccharides are going to be the simple sugars. Simple sugars, both mono and this disaccharides, both are simple sugars. For example, the simple sugars here, two examples we can take. One is a pentose sugar, another one is a hexose sugar, which are there in our syllabus. So pentose sugar, do you remember it is related to nucleotide? What is a pentose sugar we know? That is going to be the ribose and deoxyribose. Deoxyribose. Even ribulose is also possible here. Pentose sugar, ribulose is there, which is we can see in the biosynthetic pathway or Kelvin pathway and also Hatch-Slack pathway. Next, hexose sugars. Example, does anyone remember 6 carbon compounds? Glucose, its isomer fructose. Glucose and its isomer fructose. These are going to be the simple sugars which are monosaccharides, and simple sugars which are disaccharides, those are going to be the sucrose. Sucrose and lactose. Already we have seen these two. Sucrose, where we have seen in the glycolysis. Glycolysis before, the source of the glucose coming from the sucrose. Sucrose will be broken down with the help of invertase into glucose and fructose. So sucrose is a combination of glucose and fructose. Both are combined. This is a monosaccharide, this is a monosaccharide, both are combinedly forming it as a disaccharide. Do you remember the enzyme that breaks the sucrose? That is invertase. Invertase is the enzyme that can break the sucrose into glucose and fructose. So sucrose is a disaccharide, combination of two monosaccharides. One is the aldo sugar, that is a glucose, another one is a ketose sugar, that is going to be fructose. Both are isomers, we have seen in the glycolysis. And lactose, where we have seen this lac operon concept. The enzyme going to break the lactose is going to be beta galactosidase, which is coded by the gene LAC-ZET gene. See, this lactose will be broken down into two compounds. One is glucose, another one is galactose. So glucose and galactose are the two compounds present in this. So sucrose and lactose both are going to be the disaccharides. Remember, here is the enzyme that can break this, here is invertase can break this, another one is beta galactosidase. Then our point of discussion mainly as per the textbook is going to be polysaccharides. See, these polysaccharides are the sugars which are having many monomers are attached. The bond present in these polysaccharides between two sugar molecules is glycosidic bond. Glycosidic bond is there. Now this glycosidic bond is going to be present between carbon, oxygen to carbon. This is the glycosidic bond. By the removal of the water molecule, it will be formed. Next, there are many types of polysaccharides are there. In them, first we are going to discuss the starch. So starch is going to be homopolymer of glucose. It is going to be the homopolymer of the glucose. Many glucose molecules are going to combine to form the unit called as starch, and it is a storehouse of energy in case of the plants. In the plants, energy will be stored in the form of starch. And next, this starch is going to have secondary helical structure. Secondary helical structure. This same helical structure we have seen in the proteins. Protein, primary structure of the protein is a linear chain. Secondary structure we can call it as a alpha helix or beta pleated sheets. So here also it is a secondary structure which is a helical structure. It means it is going to be formed like this, helical spring like structure. Because it is a helical structure, if you add the iodine to this, so this iodine will be held together at the helices. Forming a complex called as starch iodine complex. When we add the iodine to the starch, because of the secondary helical structure, this iodine is held by this helical structure of the starch, forming a complex called as a starch iodine complex. This starch iodine complex will give you the color called as blue color. It is a blue color starch. So the presence of starch can be understood or done the experimentation with the help of iodine, because the starch having the secondary helical structure. That is the thing. Next, after saying that, next one is glycogen. So similar points. It is also homopolymer of the glucose. Same homopolymer of glucose. And in contradiction with this is a storehouse of energy in case of animals. And it doesn't have a secondary helical structure. It is having the branched structure. Is there. See, this branched structure, if you observe, it is going to be the structure like this, and these are having the branches. Textbook they had given in the form of a cartoon. So this is going to be the left end and this is going to be the right end. So this left end is going to be called as non-reducing end. It is not going to involve in reduction reactions. So left end is going to be called as non-reducing end. Here the right end, which is going to be present here, called as a reducing end. One is a non-reducing end, another one is going to be the reducing end. So totally glycogen is a homopolymer of glucose, storehouse of energy in case of the animals. Sometimes this glycogen is considered as an animal starch. Starch like storage substance present in case of the animals. And it does not have a helical structure, it have a branched structure. In this branches, the left end is called non-reducing end, right end is going to be called as reducing end. This is related to glycogen. Next, third one is the cellulose. See, this cellulose is a same homopolymer of glucose. Same compound, same like this. but these are storage polysaccharides, but this is going to be the structural polysaccharide. Forms the cell wall of plants. It forms the cell wall of plants. That's why I am considering it as a structural polysaccharide. These are, what do you say, these storage polysaccharides. And it does not have secondary structure was not there, so that it cannot hold iodine. It cannot hold iodine. Assertion, reason statements same. Here starch can hold this iodine because the reason is going to be secondary helical structure. Cellulose cannot hold the iodine because secondary structure was absent, helical structure was absent. Next, these cellulose having so many commercial applications. What are those? The paper made of plant pulp is because of cellulose, and the cotton fibers which we are using for our clothing purposes, those are all going to be because of cellulose. So, a textbook statement, paper made of pulp and the cotton fibers are made up of cellulose. That is the logic here. Next, after that, next one is inulin. So, inulin is not a family of glucose, it is a family of fructose. So, it is a homopolymer of fructose. Many people confuse us while they are reading the question paper. Inulin is a polysaccharide. Insulin is a kind of a protein. So, suppose if the statement will be like this, question, statement 1 and 2. Statement 1, insulin is a homo or heteropolymer. How can we choose? It is a heteropolymer, insulin, because it is a protein. I told proteins are always heteropolymer, there is no homopolymer. Whereas inulin is a kind of homopolymer which is made up of fructose. Insulin is a heteropolymer of amino acids. This is a homopolymer of the fructose. And related to this one, not much information is there, but simply one extra point you have to understand. It acts as a storage polysaccharide in case of the Asteraceae members. Asteraceae family, how can I say to you, sunflower family. In this sunflower family, storehouse of energy is in the form of the inulin, which is a homopolymer of fructose. And after saying this, complex, even more complex polysaccharides are there, even more complex sugars. These are all complex sugars, disaccharide and homosaccharides, these are simple sugars. Starch, glycogen, cellulose, inulin, these are complex. Even more complex polysaccharides are there, we can call them as amino sugars. Amino sugars means the sugar molecule will be connected with the amino group. So, this is even more complex sugars, we can call them as modified sugars or the amino sugars. One is glucose amine. Another one is N-acetyl galactose amine. One is glucose amine, another one is N-acetyl galactose amine. How can we explain this? Suppose let me take the structure of glucose. Formula of the glucose C6H12O6. First carbon, second carbon, third carbon, fourth carbon, fifth carbon. Here CH2OH will be there. Here H and OH. Here is going to be H and OH, here OH and the H, here OH and H, here H will be there. So, this is the structure of the glucose, C6H12O6. To this, who is attached? Amino group. At the second carbon, the amino group will be attached. So, this is the structure NH2. This is the structure, we call it as a glucose amine. Same this structure if you apply here. At the second carbon, to the same structure at the second carbon, NH, C double bond O and CH2. So, this is going to be N-acetyl galactose amine. No need to remember the structures and all, just have the name. Even more complex sugars are glucose amine and N-acetyl galactose amine. Amino group is attached to the sugar compounds. Then, some of the sugars are called as, what can you say, glycolipids. Do you remember? Lipid molecule, when it is connected with the sugar compounds, you can call it as a glycolipids. That is a different kind. So, here this N-acetyl galactose amine, NAG. It is the monomer that forms a homopolymer called as a chitin. So, chitin is a homopolymer of NAG. So, it is a homopolymer of NAG, homopolymer of NAG, that is the logic. So these are all the starch, glycogen and cellulose are the family of the glucose. These are homopolymers of the glucose. Inulin is a homopolymer of fructose. These are complex sugars that are not much complicated. Even more complex sugars are there related to this glucosamine and N-acetyl galactosamine. Here the N-acetyl galactosamine shortcut form is NAG. NAG is the monomer that is combined together to form a complex polysaccharide that is going to be called as a chitin. Chitin functionality we know already. Chitin is present in exoskeleton of the arthropods, in the arthropoda. In the arthropoda, exoskeleton is there, insects family. So their exoskeleton is made up of chitin. Even in the fungi, the cell wall of fungi is made up of chitin and also cellulose, both are there. So chitin is a homopolysaccharide of N-acetyl galactosamine. So this is the discussion related to this polysaccharides. And common formula of these sugars is going to be CnH2nON. So you can replace it like this, C6, 2n means H12O6, like that. So C5H10O5, ribose sugar. So common general formula is CN2H2nON. So this is about the polysaccharides. So polysaccharides as per textbook I am discussing here, starch, glycogen, cellulose are there, inulin and the chitin. All these we have represented. So there completes the 5 kinds of biomolecules what we have discussed. Amino acids related proteins, nucleotides related nucleic acids, and polysaccharides which are related with the monosaccharides, and the lipid molecules. Sorry, 4 types. Lipid molecules we have discussed everything. Then after saying this, a small concept was pending, that is a secondary metabolites. So to be simple, let me discuss it. Metabolites are the compounds which are involved in the functions of the body. Same like biomolecules. Some people consider biomolecules is the another name for the metabolites. See, these metabolites in the body of an organism are of 2 types. One is going to be the primary metabolites, another one is going to be the secondary metabolites. Primary and secondary metabolites. See, these primary metabolites are produced by all living organisms. All living organisms are there for the production of these primary metabolites. Whereas secondary metabolites produced in fungi, plants and microbes like bacteria. So simply to remember, except in animals. In animals, even like human beings, we don't have secondary metabolites. We have only primary metabolites. Next, these primary metabolites are having known role in the body of an organism. Their function we know. They are involved in physiological activities of the organism. All these are primary metabolites. Carbohydrates, proteins, fats, lipids, amino acids, nucleotides, nucleic acids, all these functions we know. They came under the umbrella of primary metabolites, because we know their role, we know their functionality, and they have which pathway they are involved also, we know everything. But these secondary metabolites, function unknown function in host. In the host organism, here carefully how to understand, host organism means the organism which is producing that. That is a fungi or the plant or the microbes. Their function is suppose in a plant body, we can observe the secondary metabolites. But these secondary metabolites, what they are doing in the plant body, we don't know. So there is a very sensitive line here. We are not saying secondary metabolites are not having any function. They might have having a function, but we don't know their role. So primary metabolites having known role, their role is unknown still in case of the secondary metabolites. Then after saying this, these secondary metabolites are useful for the human welfare. Human welfare, we are using them. So what is that? A table they had given different secondary metabolites they had given in the table. Once if you observe shortcutly, first one is pigments. There are 2 pigments that are given, anthocyanin and carotenoids. Another one is going to be the alkaloids. These alkaloids are having number of functions. One is going to be morphine and the codeine. Not these are drugs. Next, after that, terpenes, monoterpenes and the diterpenes. Later on, we can see this drugs, toxins like heparin and the resin, essential oils like lemon grass oil, lemongrass oil, and polymeric substances like rubber, gum, etc. Different functions are there. Na? Here, drugs example these concavalin, vinblastine and curcumin. Even one important thing many people are going to confuse is lectin. What is this lectin? Lectin is a concavalin A. Concavalin A. Why I am saying this is important means, yesterday we are under the discussion related to these lipids. I told you phospholipid. One of the phospholipid is lecithin. So lecithin is a phospholipid. Lecithin is a phospholipid. Phospholipid, and it is found in the plasma membrane of the organisms, and lectin is a secondary metabolite. There is a difference. Students generally confuses between lectin and lecithin. So lectin is a concavalin A secondary metabolite. Lectin is a phospholipid found in case of the plasma membrane. So there completes the primary and secondary metabolites. Symbol known function, function unknown. Found in all living organisms except animals, found in remaining organisms. Examples of carbohydrates, proteins, fats, lipids, nucleic acids. Other than this, what are there? Those are called as secondary metabolites. They are useful for the human welfare, and this table once you prepare according to it. Then, after saying this all biomolecules total discussion was done on particular area which is added in this chapter, that is related to enzymes. So, what do we know about enzymes? Basically, enzymes are the catalytic compounds. So, what is a catalyst? Catalyst is a compound that is involved in the chemical reactions going to speed up the reaction process. Let we discuss about the enzymes. So, enzymes, functionally enzymes are biocatalyst. Carefully I am using this word, biocatalyst. These are the catalysts found in the living organisms. Next, structurally, enzymes are structurally going to be proteins. So major cases, protein with catalytic activity going to act as a enzyme. So to act as an enzyme, minimum structure it requires is a protein structure. Other than protein, there is one enzyme, one particular enzyme. Do you remember ribozyme? Ribozyme is an enzyme not made up of protein, it is made up of nucleic acid, that is RNA. Where we have seen this ribozyme? Ribozyme is involved in process of translation. 23S rRNA in case of prokaryotes and 28S rRNA in case of the eukaryotes, having this particular thing. So structurally enzymes are proteins, functionally enzymes are biocatalysts. Other than protein, there is one enzyme, that enzyme is called as ribozyme. Ribozyme is made up of rRNA, that is the thing. Next, but these enzymes, this protein to act as an enzyme, it contains tertiary structure. It should contain tertiary structure. If you remember properly, yesterday I told tertiary structure of the enzyme is absolutely necessary for biological activities. What are the biological activities? Acting as a catalyst. To act as a catalyst, this enzyme should have the tertiary structure of the protein. But this tertiary structure of the protein, why it is important means, I am drawing the cartoon form of this enzyme. So this is the enzyme having some pocket. The pocket is formed during which structure? Tertiary structure. The pocket of the tertiary structure, we can call it as an active site. We call it as an active site. What is active site? It is a site where substrate going to bind. Here another doubt comes. So what is this substrate? What is this compound called substrate? Substrate is a chemical which is going to be converted into product. So in a chemical reaction, generally we use this terminology in chemistry, reactant going to form product. Here in the enzyme terminology we are using, the reactant is another way called as a substrate. The chemical which is going to convert into product, that is going to be called as substrate. So here the reaction is substrate will be converted into product with the help of a catalyst called as enzyme. How come enzyme going to act as a catalyst here? Because enzyme is a protein having tertiary structure. What is the importance of this tertiary structure? In this structure, the enzyme are a protein having some pockets or crevices. Pockets or crevices. Crevices. So these pockets or crevices is a site where substrate going to bind. The place where substrate going to bind, those are called as what ma? Active site. So active site is very important for the functioning of the enzyme. If active site is not there, it cannot attach with the substrate, so that it cannot be converted into product. For the protein to act as an enzyme, it should be there in tertiary structure, because the tertiary structure is the structure that contains the active sites. Then after this, the catalyst is of two types. As per textbook sequence, I am moving ahead. So catalyst is of two types. One is going to be the inorganic catalyst, another one is going to be the organic catalyst. One is inorganic catalyst, another one is organic catalyst. See here, this inorganic catalyst means the catalysts which are lifeless, present outside the living organism. Organic catalyst means, in this case we can consider it as an enzyme. So this organic catalyst will be damaged at high temperature, above 40 degrees Celsius. Above 40 degrees Celsius, this organic catalyst, that is enzyme, will be damaged, because more than 40 degrees Celsius enzyme will be denatured. See, understand, denature means tertiary structure of the protein will be broken down into secondary and primary, so that in the secondary and primary structures there is no active site, so that it cannot act as an enzyme. So organic catalyst above 40 degrees Celsius, it will be denatured and damaged, and it loses the capacity of catalyst. Whereas inorganic catalyst, they will be active or stable. The correct word is stable, even at high temperature and high pressure. Even at high temperature and high pressure. Even at high temperature and high pressure, they will be stable. Then for this, we are generally saying above 40 degrees Celsius it is going to be damaged, but there is an exception for this. So what is the exception? Thermophilic organisms. Thermophilic organisms. So understand this word, philic means loving, thermo means temperature. The organisms which are living in high temperatures, like sulfur springs, hot vents, like this. Near to the volcanoes, hot vents are there, boiling water bodies. In those areas also, even at high temperatures also, some organisms able to live. Those are called as thermophilic organisms. Already we know it, Do you remember Taq DNA polymerase? So example for this is Thermus aquaticus. Thermus aquaticus is a bacteria that contains the capacity to be stable even at the high temperatures. So this thermophilic organism, like Thermus aquaticus, from that whatever enzymes we are extracted, these are stable even 80 to 90 degrees Celsius. Even 80 to 90 degrees Celsius also, they will be stable, because they are actually living in the high temperatures. So those are thermophilic, and Thermus aquaticus is the example for this. Then after saying this, next concept to discuss as per the textbook is, they have given heading chemical reactions. So what is this chemical reactions? Simply, to be simple, if you go, change is of two types. One is the physical change, another one is the chemical change. One is the physical change, another one is going to be the chemical change. So this physical change is no bond breaking or no bond making is involved. Bond making is not involved and bond breaking is also not involved. Just change in, because of this there is a change in shape. Continue cheycha. Cheyna continue. So sorry for the interruption. Observe the chemical reactions. To understand, change is of two types. One is a physical change, another one is going to be the chemical change. if there is no bond making and bond breaking is involved, that is called as physical change. Bond formation or whatever bonds are there, those will be broken down. This is going to be called as chemical change. Here are the two examples I have taken from the textbook. One is an inorganic reaction, another one is an organic reaction. In both cases, we can observe there is a breakdown of the bonds and formation of the new bonds. This is called as a chemical change. Next, the chemical change or chemical reaction having a property called rate. What is mean by rate? Rate means amount of product formed per unit time. I am repeating, amount of product formed per unit time, it is going to be called as rate. Sometimes this rate is considered as velocity if there is any particular direction of reaction. So there is this rate will be affected by so many factors. For example, we are considering two factors in this case. One is the temperature that can affect the rate, another one is presence of catalyst that can affect the rate of the reaction. So how the temperature is going to affect, to show that there is a general thumb rule. What is this thumb rule means? Suppose for our understanding I am taking one example. At 25 degrees Celsius of temperature, 10 products are there formed per 1 hour, suppose in this case. So if I increase the reaction temperature by 10 degrees, rate will be doubled. 10 products per 1 hour will become 20 products per 1 hour. Same case, from the 25 degrees Celsius, if I reduce the temperature by minus 10, so that it will become 15 degrees Celsius and the rate will become half. So what is the general thumb rule? Textbook line, what it says? Rate will be doubled or rate will be decreased to half for every 10 degree change. Either 10 degree increase or 10 degree decrease, rate will be doubled or decreased to half in either direction they had given. So the general thumb rule, that is effect of temperature towards the rate of reaction. Then effect of catalyst towards the rate of the reaction, how it is going to be. So what the catalyst going to do? All of us know that catalyst, presence of catalyst increases the speed of the reaction. So that if you consider, I am taking one example which is also again textbook example. Carbon dioxide going to combine with the water to form carbonic acid. This is the reaction generally occurs in the cytoplasm of the organism, cytoplasm of the cell. So carbon dioxide plus water forming the carbonic acid, this reaction can happen without the catalyst or it can happen with the catalyst. So without the catalyst, what is the rate? 200 molecules of H2CO3 are formed per 1 hour. This is the rate without the catalyst. With the catalyst, that is enzyme that is acting as catalyst, 6 lakh molecules of product will be formed per 1 second. So that what is the assumption here? The rate of the reaction will be increased by 10 million times. So this is the very greatest observation we can have here. So 10 million times rate of reaction will be increased with the help of the catalyst. What is the enzyme? The enzyme name we have to mention, that is carbonic anhydrase. Carbonic anhydrase is the enzyme. Anhydrase is the enzyme which is going to act as a catalyst in this reaction. So related to carbonic anhydrase, this is the enzyme can form the reversible reaction, first point. And this enzyme is going to form 6 lakh molecules of H2CO3 for 1 second, second point. Third, this enzyme is available within the cytoplasm of the cell. So that is the thing. So chemical reaction, rate and the factors affecting the rate we have discussed. Now the next concept to be discussed, as per the textbook they have given metabolic pathway and issues, that will be already covered in the respiration concept. Now I am going to enter, there is a heading in the textbook, how do enzymes can bring about such high rates of chemical conversion. High rates of chemical conversion means, so understand here, how presence of an enzyme increase the rate of reaction 10 million times. The mechanism we are going to discuss. So under this heading, what we have to consider here, first, mechanism of action of enzyme, let me see. Let me take, this is the structure of a enzyme. So enzyme, I am reminding again, chemically a protein present in the tertiary structure. The tertiary structures contain some pockets. These pockets are called as active sites. So active site is a site where, suppose this is the structure of a substrate. Substrate going to bind. The site where substrate going to bind, that is going to be called as active site. Now in the first step of conversion of substrate into product, this substrate will come and bind to the enzyme and move towards the active site. After entering into the active site, it is forming a complex called as enzyme substrate complex. A intermediate complex formation is there, that is going to be called as ES complex. Very, very important formation. This is EX complex. So what is happening here? For example, if I have about to show to you, suppose this is the enzyme which is having an active site. This is active site where substrate going to bind. Then the substrate will come directly, it is not possible for it to fit into the active site. First it will come and diffuse towards this active site, enter into the active site. The moment the substrate has entered into the active site, this active site of the enzyme will fit around this substrate properly. Now the active site of the enzyme binded to the substrate firmly, hardly it is binded. This complex formed after binding of substrate into the enzyme is called as ES complex. Later on, after fitting towards this substrate, this enzyme substrate complex, there are some bond breaking and bond making. So formation of the bonds and breakdown of the old bonds will happen. That leads to formation of a new structure of a substrate. Those structure will be considered in this case as a product, and enzyme is still binded. This complex is called EP complex. This complex is called EP complex. What is EP complex? Enzyme product complex. That is enzyme product complex. Next, this slowly releases the enzyme out and the product will be released. Slowly releases the product and the enzyme will be released. This enzyme in this entire reaction is unchanged. Again it will come to the cycle from the starting. So observe, enzyme to the active site, who is binded substrate. After binding to the substrate of active site of the enzyme, this active site will hold the substrate tightly. The tight formation of substrate and the enzyme is going to be called as enzyme substrate complex. In this enzyme substrate complex, there are bond breaking and bond making is happening. So that structure of the substrate will be converted into structure of the product. This complex is called enzyme product complex. This enzyme product complex slowly releases the enzyme and the product will be released. See, this entire reaction, who is changed? Substrate is converted into product. Who is unchanged? Enzyme. Enzyme is entire reaction will be unchanged. Again come to the starting of the cycle. Initially in the middle it is holding the substrate. Later on it is coming back to the original state. No change in the enzyme. Because catalyst is a substance going to speed up the rate of reaction without getting involved into the reaction. Just it is helps in speeding up the reaction. It is not going to get converted here. Then this ES complex related, there are some terminology. Many people confuse us here. First point, this is a obligatory formation. If you properly go through the textbook statements, there are many points related to this ES complex. Obligatory formation. What is meant by obligatory formation? It is a compulsory formation. Why it is compulsion? Because without binding to the enzyme, substrate directly cannot convert it into product. That is why formation of the ES complex is obligatory, compulsory formation, and it is a transient phenomena. Transient phenomena means it is a temporary process. Very short-lived. Simply we can understand, transient phenomena means it is a phenomena that is very short-lived, very highly unstable. So, and this is, you can consider it as a unstable. Obligatory, compulsory, transient, temporary, it is a short-lived and it is an unstable complex, that is ES complex. Next, after saying here, from here onwards, many people are having many doubts related to the graph what they had given in the textbook. Properly, if you follow the diagram and coordinated with the textbook statements, concept is very simple here. Observe, same reaction I am bringing it into the graphical form. Graphical form we are bringing it here. Suppose this is the progression of reaction on the x-axis. Progression of reaction. and here it is going to be the potential energy taken in the y-axis. So all of us know this is the origin point. The moment you are going up, amount of energy will be increases. Here the amount of energy, suppose here is the substrate, this is the amount of energy for the substrate. Lesser than substrate, here is the product. As per textbook I am saying. Now if you observe, energy of the substrate is greater than product in this particular reaction. This reaction will be exothermic reaction. That reaction will be exothermic reaction. Whereas if you consider it as a reverse situation, substrate energy is lesser than product, reaction will be endothermic reaction. In our textbook they have used another word, exothermic is called as a spontaneous reaction. This is non-spontaneous reaction. So we are discussing this particular thing. Energy of the potential energy of the substrate is higher than potential energy of the product. So that by releasing the energy, substrate will be converted into product. For example, if enzyme was not there, catalyst was not there, how the reaction is going to be? So substrate directly cannot become product. Substrate will enter into a high energy state. That high energy state is called as a transition state structure. Transition state structure. After entering into the transition state, again by releasing the energy, it will come to form the product. So there is an energy difference between substrate and the transition state. This energy difference we can call it as an activation energy. Activation energy. What is activation energy? The energy difference between substrate and the transition state, that is called as an activation energy. I am repeating, observe carefully. This is a graph we are showing the conversion of substrate into product. That is a progression of reaction in the x-axis. On the y-axis we are taking potential energy. Our designed example here, substrate is having high energy than the product, so that the reaction is exothermic reaction. Now if you observe, substrate directly cannot form the product. First, by absorbing the energy, by accumulating the energy, substrate will enter into high energy state, that is called as a transition state. From this transition state, by releasing the energy, it is going to form the product. So the energy difference between substrate and the transition state is called as activation energy. Now without the enzyme, suppose let me consider, as we are not involving our enzyme here, without enzyme, I mean by catalyst, this is the activation energy. In the same reaction, if I involve the enzyme, the reaction graph, the graph of this, the curve will be like this. So here is the transition state. Here is the transition state. Substrate entering into transition state and coming with the enzyme or without the enzyme, same reaction. Enzyme first entering into transition state, then only it is becoming product. But in the presence of enzyme, the activation energy is very less. Substrate can easily, very fastly entering into transition state, so that easily it will be dissociated into the product. But without the enzyme entering into transition state require more activation energy. With the enzyme entering into transition state requires less energy. So here, where is the transition state in this reaction? After binding to the enzyme, substrate will enter into transition state, then it is becoming the product. What is the work of the enzyme? I am repeating finals, I am saying the final statement here. Substrate become the product, not directly. Second point, substrate converted into product by entering into a high energy state, that is going to be called as a transition state. With the enzyme or without the enzyme, substrate should enter into transition state, then only it is becoming the product. And the moment it is entered into transition state, the energy difference here between the transition state and the substrate is going to be called activation energy. Without the enzyme, the substrate need more activation energy to reach the transition state. Presence of enzyme makes it easy, substrate easily enter into transition state and become the product. Ultimately, bottom line of the story here, substrate should pass through the transition state to become the product. Substrate should pass through the transition state, then only it will become the product. Finally, the entire discussion I am concluding my here, enzyme going to speed up the rate of reaction by decreasing the activation energy. By decreasing the activation energy. So that is the overall discussion ma here. And there is another point ma, if you observe the textbook statement, between the substrate and the product, there are many altered state structures are there. Altered state structures are there. These altered state structures we can call them as intermediate structures. Altered state structures are intermediate structures. All these structures are present near to the transition state. Here and there many intermediate states are there between substrate and product. All these are unstable compounds. All these are unstable. Immediately they will be broken down to form the product. Where these intermediate states are there, I am repeating, from the substrate in the journey towards the product, middle there are intermediate states are there. Those intermediate states we can call them as altered state structures. They are unstable. The reason behind this, they are having the high energy. As they are having the high energy, they are unstable. Textbook statement what it says, stability is something related to energy status and they are inversely proportional. High energy, less stability. Less energy, more stability. That is the logic. So this is the functioning of the enzyme. What is the question? How enzymes making this enzyme this much faster? How? First enzyme binds to the substrate forming ES complex. This is temporary and it is compulsive. ES complex breaking and making the bonds converted into EP complex. EP releases the product. Unchanged enzyme will go on doing the same cycle. And in this graph what we are discussing, substrate energy is higher than product energy, so that the reaction is exothermic reaction. Now substrate directly cannot become product, it should enter into a high energy state called transition state. After that it is forming the product. So energy difference is called activation energy. So without the enzyme more activation energy is required, with the enzyme less activation energy is required. Between substrate to product many intermediate and altered state structures are there. Those are unstable because they are having high energy. So this is mechanism of enzyme action and how do enzyme bring about the high rates of chemical conversion completed. Tomorrow we will discuss the factors affecting the enzyme action and we will close the total concept. Thank you. We will meet in tomorrow's concept.
Good afternoon all of you. Yesterday class mechanical properties of solids completed. Today concept mechanical properties of fluids. In mechanical properties of the fluids total this topic divide the two parts today and tomorrow. On tomorrow only surface tension. Today we discuss about the fluid dynamics. In that fluid dynamics the main important concept is nothing but viscosity. Main topic is nothing but viscosity. Okay, first we can discuss about the viscosity, some important formulas. Viscosity. So viscosity is nothing but is the viscous force. Viscosity is also known as the viscous force. Now it is the opposing force which is always opposing the relative motion between the two layers of fluid. For example, this is the ground. Water is flowing, upper level velocity. Upper level the velocity flow is more. Lower level, next level like this. Upper one having the more velocity. Next level as compared to above one velocity is less. and below one having the very less. And ground, the liquid layer is in contact with the ground, almost velocity becomes 0. So here velocity more, here velocity less, some opposing force is there. That is known as a viscous force. So viscosity, like a viscous force, acts tangentially and opposing the relative motion between the two layers of the fluid. That force F is equal to eta A into dV by dx, where F is nothing but viscous force. Here a negative sign shows that the viscous force is always opposing the relative motion between the two layers of the fluid. Okay, area of the layer. A is nothing but area of the layer. Area of the layer. dV, change in velocity. Like this value is V, this value V plus dV. This value V minus dV. What is the difference of these two layers velocity? dV. What is this difference? dV. dV is nothing but change in velocity of the two layers. And delta x is the distance between the two layers. Distance between the two layers. Like dV by dx. dV by dx is velocity gradient. dV by dx, velocity gradient. And eta is known as coefficient of the viscosity of liquid. Coefficient of viscosity. Coefficient of the viscosity of liquid. Coefficient of the viscosity of liquid. Therefore, F is equal to minus eta A into dV by dx. That is the important point. Here, eta is nothing but a coefficient of the viscosity. Now, what is the SI unit of eta? SI unit is nothing but a Pascal second. Pascal second. CGS unit, poise. CGS unit, like poise. Important point, SI unit of eta is nothing but a Pascal into second. What is the CGS unit of poise? So, these 2 points are the important. Next one. Reynolds number. Reynolds number, another important point. So, Reynolds number, what is the meaning of that one Reynolds number? It is used, like Reynolds number means it is used, the flow is streamline flow or turbulent flow that can be identified. For example, in a tube, water is flowing. That fluid like streamline flow na turbulent flow na. How to say that one? By using the Reynolds number, we can identify the fluid is streamline or turbulent. So, what is the main formula? The Reynolds number is equal to rho dV by eta. Rho dV by eta. Where rho is nothing but density of liquid. Density of liquid. D, diameter of tube. Diameter of tube. V is nothing but a critical velocity of the fluid, like simply velocity of the fluid. Already we know that eta is nothing but coefficient of the viscosity. Therefore, the Reynolds number R is equal to rho dV by eta. For example, these all values are substituting, we get the answer value like less than 1000. Less than 1000. So 1000 or below 1 is there, the flow is nothing but streamline flow. So the flow is streamline flow. For example, R value greater than 2000. R value greater than 2000. The flow is turbulent. Turbulent flow. For example, the R value lies between 1000 to 2000. The fluid unstable. The fluid is unstable. Fluid is unstable means like streamline flow to changes to turbulent flow changes to streamline. So that is nothing but unstable. So another important concept Reynolds number. What is the expression of the Reynolds number? Rho dV by eta. Rho density of the liquid, d diameter of the tube, v velocity of the fluid, simply also known as the critical velocity of the fluid, eta coefficient of the viscosity of the fluid. Like this value may be less than 1000 streamline, greater than 2000 turbulent. Like 1000 to 2000 the flow is unstable. Flow is unstable means like at streamline to turbulent to streamline this continuously changes. That is nothing but unstable. So this point is the important one. Right, now another important point. By the rise of temperature, the viscosity in liquids and gases. What happens, like by the rise of temperature, increase of the temperature, the viscosity in liquids increase or decrease? Answer, increase or decrease. Like in gases also increase or decrease. So that 2 points are also the important one. Now listen, by the rise of temperature the viscosity in liquids is decreases. The viscosity in liquids is decreases. For example, on a surface, take them water on the surface, easily flowing. On the same surface, honey is dropped. Honey. In case of the honey is dropped, it is not moving easily because of high density and high viscous liquid. Already we know that honey can be taken in hot water. What happens? In hot water, honey can be easily melted and layer in between the layers is nothing but the viscous value gradually decreasing. That's why by the rise of temperature, the viscosity in liquids is decreases. Now in gases, by the rise of temperature, gas molecules are having the speed is more. Already we know that V directly proportional to root T. Velocity is directly proportional to root T. By the rise of temperature, speed of the gas molecules also increases. By the increase of the speed, apposition is also more. Apposition is more means viscosity value is greater. So that's why by the rise of temperature, the viscosity in liquids decreases, the viscosity in gases increases. These 2 points are the important. Next, Stokes theorem. Stokes law or terminal velocity. Stokes law or terminal velocity. Now listen, Stokes law. Already we know that the raindrops, already we know that when your body is dropped freely, the velocity is nothing but from certain height, V is equal to root 2gh. Like similarly, when raindrops is falling from a certain height, but that raindrops is moving, that are reaches to the surface, they having some constant velocity. Because of in between them air is there, air is nothing but opposes the motion, that's where a velocity value is constant. That velocity is known as terminal velocity. So when the body is dropped in a viscous liquid, after some time the body attains a constant velocity. That constant velocity is known as terminal velocity. So what happened amma here? When the body is moving inside a liquid amma, the layers between the liquid having the so many layers ga, each layer is opposing the motion kada, that is known as viscous force ga. Like according to Stokes, Stokes is nothing but a scientist name ra, Stokes. According to Stokes, the viscous force F is equal to 6 pi eta RV. F is equal to 6 pi eta RV, or in case of vector notation 6 pi eta RV. So in case of the vector like this one. So F bar is equal to, in vector notation compulsory take them minus, because of that force is opposing the motion gara, compulsory take them in minus. Magnitude value F is equal to 6 pi eta RV. F is equal to 6 pi eta RV, where R is nothing but radius of the spherical body. R is nothing but radius of the spherical body. V is nothing but terminal velocity or constant velocity of the body. Eta, coefficient of the viscosity of the liquid. Okay, that's where F is equal to 6 pi eta RV. Now this formula like 2 times on the previous NEET question. 2 times are the given on the previous NEET question or directly asking the formula based questions amma. So that's why this formula is the important. In vector notation amma, F is equal to minus 6 pi eta RV. Okay, this point is the important one. Now listen, when this raindrop amma is falling downward gamma, raindrops is falling downward gara, whose weight value is mg is acting downward, buoyancy force is acting upward, and also the one force is also acting. When raindrops are moving downward amma, viscous force is acting upward, like this one is the viscous force. After some time the body attain the constant velocity, that constant velocity is known as terminal velocity, right? At a constant velocity, or at a constant velocity, already we know that body moving with a constant velocity means acceleration becomes zero nega. Acceleration becomes zero means upward force, downward force both are equal gamma, like mg is equal to buoyancy force plus viscous force. This formula is the important one. This all the values are substituting gamma, we get the terminal velocity is nothing but what is the terminal velocity? V is equal to 2r square. This is the lengthy derivation, that's why I am writing the direct formula. What is the terminal velocity? 2r square g. 2r square g dB, density of the body, minus dl, density of the liquid, by 9 eta. Eta is nothing but coefficient of the viscosity of the liquid. So this formula is the very very important amma. This one is also given previous NEET. One question is the given amma on the previous NEET. And now listen, that terminal velocity is directly proportional to r square. The terminal velocity amma is directly proportional to r square. Very very important point. Now another point. Now listen carefully. Now this is the raindrops. Each one having the radius r. Each one having the terminal velocity is vs. How many drops are there amma? N drops. These are n drops. These n drops each having the terminal velocity vs. Now they are combined to form the big drop of radius r. To form the big drop of radius is capital R, whose terminal velocity is Vb. Whose terminal velocity is Vb. Therefore, what is the terminal velocity of the bigger drop? The terminal velocity of the bigger drop is n power 2 by 3 of terminal velocity of the smaller drop. Now again the important model. The terminal velocity of the bigger drop is n power 2 by 3 into terminal velocity of the smaller drop. N is nothing but number of the drops, number of the liquid drops. Now this is the another important formula. V directly proportional to R square. That is another important formula. The terminal velocity is 2R square G dB minus dl by 9 eta. Another important formula. When the body moving with a constant velocity, that is known as a terminal velocity. At that terminal velocity, body weight mg is acting downward. Buoyancy force and viscous force both are acting upward. At equilibrium, what happens, amma? Mg downward force, these two are upward force, both are equating, amma. Mg is equal to buoyancy force plus viscous force. This is the another important formula. In the last 4-5 years, amma, only this formula based questions are number of the models, amma. So that's why these all are the important points. Okay. Right, amma. Now we can discuss some important formula, important problems on the previous questions, amma. Now, 2023 question. Now listen carefully. The viscous drag acting on a metal sphere of diameter is 1 millimeter. Diameter, amma. Diameter is 1 millimeter is falling through a fluid of the viscosity. Eta value, coefficient of the viscosity 0.8 Pascal second and whose terminal velocity 2 meter per second. That's why what is the viscous force? What is the viscous force acting on the body? What is the formula of the viscous force, amma? 6 pi eta RV. 6 pi eta RV. 6 pi like 3.14, 3.14 eta 0.8, radius, diameter value 1 amma, radius value 1/2 millimeter 10 power minus 3, velocity like 2 meter per second. So these two values are cancelled. So simply 6 3s are 18. Approximately 18. Here 0.8 gamma 8 into 10 power minus 4 18 8s are 144 into 10 power minus 4. So this is nothing but newtons. 144 into 10 power minus 4 newtons. So in given option 1.0, this value take them here. Here how much, amma? 15.4 into 10 power minus 3 nega, that 14.4 into 10 power minus 3 Newton. This is the given option, amma. So that's why now this formula is the important one. That is the 2023 question. Now another question. This is the 2022 question. Now listen carefully. This is the 2023 22 question. The terminal velocity of the copper ball of radius of 5 millimeter is falling in a tank of oil at a room temperature is, whose terminal velocity is 10 centimeter per second. And the viscosity of the oil is nothing but 0.9 Pascal second. What is the viscous force? Now what is the viscous force? Again given the same question. Like 2022 that question is given, we can practice in this question on 2023 again the same model. So like what is the formula? 6 pi eta RV. 6 pi eta 0.9, radius 5 millimeters into velocity 10 centimeter per second, converting into meter per second. Right, amma? 0.9 into 10, 9. 6 3s are approximately 18. What are the remaining value, amma? 6 3s are 18, here emo 9, already 5 is there amma, 5 is there, 10 power minus 5. Next amma, 18 5s are 90, 18 5s are 90, 90 into 9, 810. So 81 into 10 power minus 4 newtons. 81 into 10 power minus 4 newtons. Again the same model is the given amma on 2022 question. Okay, Nama. Now next one. Third question. Which of the following statement is not true? Ma, not true. Which of the following statement amma is not true? First one. Pressure. Pressure is a vector quantity. Pressure is a vector quantity. Next, relative density is a scalar quantity. A relative density is a scalar quantity. Coefficient of the viscosity is a scalar quantity. Fourth one, surface tension is a scalar quantity. Surface tension is a scalar quantity. Which of the following is dropped into the same liquid of a coefficient of the viscosity eta, but the density of the liquid amma is nothing but 0.1 rho 2. And this body is dropped in this liquid, this body is also dropped in the same liquid. Here same liquid ga, that density of the liquid is also same kada. What is the ratio of the terminal velocities? What is the formula of terminal velocity? The terminal velocity is equal to 2r square g into dB minus dl by 9 eta ga. Eta value same, leave it. And 2 value constant, g value constant, 9 value constant. Therefore, terminal velocity is proportional to r square into dB minus dl ga. First one velocity name v1, second one velocity name v2. First one having the r square value 1 square, second one name 2 square like 4. Now next one dB minus dl. What is the first one density of the body? Rho 1. What is the density of the liquid amma? 0.1 rho 2. dB minus dl. Second one body density rho 2. Density of the liquid amma 0.1 rho 2. Right, next 1 by 4 into, here rho 2 value common denominator value 1 minus 0.1, 0.9. But here rho 1 and rho 2 different terms kada, but rho 1 value is equal to how much 8 rho 2. This value 8 rho 2. 8 minus 0.1, 8 minus 0.1, 7.9 rho 2. Again this rho 2 value are again cancel. 7.9 by 4 into 0.9, 3.6 like 79 by 36. The answer is 79 by 36 is the given on the previous one. 79 by 36. Now again body densities are given They are dropped in a same liquid and that's why coefficient of the viscosity value same and liquid density is also same. But radius value is different What is the ratio of the terminal velocity formula? Okay here 9 value, 2 value constant, g value constant, eta value constant, r square into dB minus dl value is different values. Take them ratio, we get the answer. So this is the one of the important model and maximum given on the previous year 90% possibility on the viscosity 90%. Inga remaining 10% is the given on the pressure Now we can explain some important points. Now listen on the previous one the points are nothing but, now listen carefully. Generally the pressure is nothing but force per unit normal area. Force per unit normal area, that is the general formula, leave it. Now the main concept is nothing but, this is the vessel, up to here liquid is there. Now here what is the pressure The pressure exerted by the air column is known as atmospheric pressure, like P0. P0 is nothing but pressure exerted by the air column is known as atmospheric pressure. This one is how much depth H. Rho is the density of the liquid and density of the liquid, G is the gravity. That's why what is the pressure at the bottom? The pressure at the bottom is equal to P0 plus H rho G. P0 plus H rho G. The pressure at the bottom is P0 plus H rho G. That is the very important point That point is the given on the previous year Same this questions are is the given 2026 question. Okay right. Now listen. Another point. Previous year like two times are is given on YouTube concept. YouTube. Now here amma we can observe them ra, H is the depth gamma. Era in this point or in this point or in this point, whatever may be the point ra, P naught plus H by H rho zinega. Because of on a same liquid on a same level pressures are equal ga, that is P is equal to P naught plus H rho z. Now listen amma, U tube both are on the initially on the same level. Initially a liquid can be taken amma initially on the same level amma. Initially on the same level. Right. So any liquid can be taken amma initially they are nothing but on the common level. Now here amma on one side some liquid can be taken on this one. Like a water can be taken on one of the limb. Limb means one vertical face amma. On that one, what happens amma? By the liquid can be taken in this one amma, by that weight level is a disturbance kada, like this one. Like this one this height value H1 amma. Okay like up to here amma height H2. This one amma density D1. This liquid amma density D2. That's why by the H1 height of the liquid can be taken in this side amma, like compared to this level. What is the compared to this level? What is the value of height H2? What is the value of height H2? Now what is the concept here amma? Already complete like this. So on a same liquid, on a same level the pressures are equal. On a same liquid, on a same level the pressures are equal. Like here amma. This one is the one liquid amma. This is the total ga one liquid gara. This is also same one ega. Here and here both are same liquid ega. On a same level ga. On a same level ga. On a same liquid. On a same level the pressures are equal. And one no, this one 2. Like P1 is equal to P2. What is the value of P1 amma? In this point pressure is how much amma? Open. On that open gara P naught. H1 D1 G. This side amma P naught, height H2, density D2 into G. This P naught value cancel. H1 D1 is equal to H2 D2. Again G value is also cancel gamma. Therefore H1 D1 is equal to H2 D2. So one of the important concept amma H1 D1 is equal to H2 D2. So here H1 value D1 value given ga. This density value is given ga, is asking the height H2 ga, that's where we can find this formula. This is nothing but U tube concept. Okay, very very important one. On a same liquid, on a same level, the pressures are equal. That is the point. Okay, right. Now one question that is the 2019 question amma. 2019 question. Here amma 15 centimeter. This one amma 20 centimeter. This one is the water. This one is the oil. This one is the oil. Is asking the density of the oil is. Density of the oil is. Now here amma in this one YouTube in this one YouTube amma. So there are here amma take them one side amma water amma. One side amma like oil amma. As a finally system is in equilibrium like this one. What is the density of the oil? Like this is the ground. This is the ground. But on a same liquid, on a same level pressures are equally. But here the two liquids are meet in this position. Like this position and like on a ground level. This position is nothing but on a ground level. So on a ground level we can equate in them pressures on both sides. What is this height amma? P naught, I am taking the P naught. Both sides the P naught value common agara, leave it. What is that one? H Rosie, H 15 centimeter. 15 centimeter converting into meter. Rho, density of the water 1000 G. The side amma, H, what is that? 20 centimeter density of the oil into G. 10 power minus 2, 10 power minus 2. G value cancel. Therefore, density of the oil is equal to 15 into, here amma 1000 amma, by this value 20. How much amma? Here amma 20, here 25s are 100, 50. So 15 5s are 75. 750 kg per meter cube. So the density of the oil is 750 kg per meter cube. That is another important point amma. Now next point amma. Now listen. Now next point. Some important points amma is possibility simple questions. W1 is the weight of the body in air. W1 is the weight of the body in air. W2 is the weight of body in water. W2 is the weight of the body in water. W3 is the weight of body in liquid. Liquid means except water. Except water, that is nothing but liquid. That's why one of the important question, what is the relative density of the solid? What is the relative density of the liquid? Now again the important models. Direct W1, W2, W3, 3 values are given amma. That's why what is the relative density of the solid and the relative density of the liquid? So relative density of the solid is W1 by W1 minus W2. W1 by W1 minus W2. Relative density of the liquid, W1 minus W3 by W1 minus W2. W1 minus W3 by W1 minus W2. So these two are the very, very important formulas. So is the given amma and the previous one is the possibility is there amma? Right. Note this formulas amma, important one. Now another question is the possibility. What is the reading amma here? What is the reading of the what is the tension in the body like mg nega? Already we know that tension T is equal to mg. Now it is dipped in water. Like dl, density of the liquid or water. Body density name dB. That's why what is the tension in the string? What is the tension in the string? That is also the important model amma. What is the tension in the string? Now listen, this is the body amma, mass m. Body weight mg is acting downward. Rope is nothing but acting in upward. Rope is like rope. In a rope, tension is there. That tension is acting always pulling force, tension T. Body inside the liquid, that means the force is exerted in upwards, is known as buoyancy force. Now at equilibrium what happens? T plus buoyancy force is equal to mg. Therefore T is equal to mg minus buoyancy force. Already we know that. And the previous problem FB buoyancy force V in dlg, V dlg. Volume is nothing but mass by density of the body dlg. So mg value is common, 1 minus dl by dv. So that's why what is the tension in the string? Mg into 1 minus dl by dv. And simply is nothing but reading of the what is that? Reading of the tension or here sometimes spring balance is there. What is the reading of the spring balance? Like this one reading of the spring balance, so tension in the string same one and mg into 1 minus dl by db this is also known as weight of the body in water. This expression is also known as weight of body in water. In air, they having some weight is given. What is the weight of the body in water? What is the weight of the body in water? Mg into 1 minus dl by db. Weight of the body mg value is given. Density of the body, density of the liquid values are given. Substituting them, we get the weight of the body in water. So that is another important model. Now next point. 2020 question. A barometer is constructed using a liquid. Actually, in a barometer, we can use the, what is that? Mercury. In a barometer, we can use the mercury. That's why, what is the atmospheric pressure? What is the atmospheric pressure? 76 centimeters of mercury. In case of the barometer, we use the mercury. 76 centimeters of mercury is raised by the atmosphere. But here, in barometer, we use the liquid. In the liquid, density value is how much? 760 kg per meter cube. That's why what would be the height of the liquid column when the mercury, what is the height of the liquid column? In case of the mercury is used, how much height will be raised? 76 centimeter. In mercury place, we use the liquid. How much of the height of the liquid is raised in the barometer? That is the given question. Right, next one. Mercury or liquid, any other one, anyone used atmospheric pressure value is not changing. So atmospheric pressure value by the mercury and by the liquid value is nothing but same. Maybe heights are different, but overall atmospheric pressure value same. What is the atmospheric pressure? H rho g. How much height? 76 centimeter. Rho, mercury 13.6 into 10 cube. Fixed value. The density of the mercury is 13.6 into 1000. G. H rho g. For a liquid, what is the height? We don't know. Rho, density 760 H rho g. For example, if we take the another liquid like alcohol, is saying some alcohol, that density value is given. This value is equal to H, alcohol density into gravity. Now acid value is given, that height and density of the acid into G. Any one value is equal, that one is equating to 76 centimeters of mercury. That's where how much value? G value cancel. Okay. So 10 power minus 2, 10 power 3, like 10. That 10 value multiple here, 716 into 13.6 H into 760. This is 760 cancel, H is equal to 13.6 meters. In case of the liquid, that liquid height is not, how much height is there by the atmospheric pressure? 13.6 meter. For mercury, 76 centimeter. For example, in case of the mercury place, we can use the water. We can use the water. How much height will be raised? How much height will be raised? Same question. This one atmospheric pressure by the mercury. Here liquid density value is given, but here I am taking the water. How much height will be rise ra? H rho g. H rho density of water 1000 into g. Era actual ga atmosphere pressure value ra H 76 centimeters, rho 13.6 into 10 cube into g. Okay, g value cancel. Like what is this value ra? 1000. This value cancel. What is the height value amma? 76 centimeters of simple ga already calculation lengthy gara. Simply I am taking the another method. H rho g for water amma. What is the atmosphere pressure for mercury ra? 1.01 into 10 power 5. Direct ga we know that 1.01 into 10 power 5. Simply amma this total value simplifying amma 1.01 into 10 power 5 pascals. Like this one. How much value amma here? 10 cube into 10 power 4. That 10 power 4 value cancel ra only 10 ega. How much value amma? 10.1 meters. 10.1 meter. So in case of the mercury ra 76 centimeter. Era liquid emo here emo 13.6. In case of the water emo 10 meters. 10 meter or 1010 centimeter. Era 1010 centimeter amma height of the liquid is rise amma. So important theory points amma right. Next amma another point. Pascal's law. Pascal's law, one small important point amma. In Pascal's law amma, this is the vessel. The total one up to water is filled amma. So water is filled gara. Here amma there are the so many number of the holes are there amma here. Number of the holes. Here amma some pressure is applied. This piston can moving downward. So each and hole liquid is ejecting outward. So how much pressure is acting on the each hole amma? So whatever may be this pressure is acting each and every point like same. So whatever may be the pressure, that pressure is acting each and every hole like same. That is known as a Pascal's law. The pressure exerted by the liquid at one point, that value may be equal at any point on the each and every point is same anamata. Each and every point amma that whole each and every point na pressure value same. That is known as Pascal's law. One of the important point is nothing but hydraulic lift. Hydraulic lift. In hydraulic lift amma like this one. Like this is the hydraulic lift. Now here different area of the cross section of the tubes are there. This one large, this one smaller area. That smaller area can be taken as A1. This one larger area is A2. So in that tube we can take them oil, engine oil. Take them any some oil some high density of the liquid. Here there are the two platforms. Like in a Pascal's law, like this is the car. When that car can be taken on the platform, so how to find that weight of the body? Already we know that. So in hydraulic lift, like one car is there on the platform. So how to find this weight of this car? By using the Pascal's law. For example, Now, when car is taken on the platform, what happened? On the another end, on the another end, we can apply the some load. What happens, amma? So this value is a load. Load means mg. Mg means like a force. That force is acting downward, amma. That force is acting downward. So this force is acting on the cross sectional area A1 ga. How much pressure is acting downward? Pressure is nothing but force by area. Pressure is nothing but force by area. Already we know that according to Pascal's law, whatever may be the pressure is acting downward, that same pressure is acting in all the directions same ega. Here the pressure is nothing but P2. Pressure is nothing but P2. What is the pressure formula? Force by area ga, and this load is nothing but F2 ra. Area is nothing but A2 amma. Here amma, what is the pressure amma? Force by area nega. So here amma, how much pressure is there? Same pressure is transmitted in another side ga. So that's why by the Pascal's law, this pressure and this pressure both are equal. Therefore, F1 by A1 is equal to F2 by A2 ga. F2 by A2. Once the load, when car is taken on a platform, this whose weight is nothing but F2 ga. Already we know that this is the device ga. Area values already known values ga. Area values are known values. Once a car is on a platform whose weight is W2 first measured, that's why we can find the load F1. So how much load can be taken? This can be easily lifting have the idea. That's why so that F1 value can be easily finding this equation number. That load can be taken in another platform. Slowly this car is lifting upward. So one of the important formula is F1 by A1 is equal to F2 by A2. This is the Pascal's law, one of the important concept, hydraulic lift. Okay, Namma. Only Amma, today concept fluid in that fluid mechanics law, viscosity, pressure concepts are complete amma. On tomorrow Bernoulli's theorem and whose applications, similarly surface tension. Bernoulli's theorem and their applications and surface tension, that two concepts are explained on tomorrow amma. Right. So thank you amma. Next class we can continue.
Hello all. Today it's the second day in chemical kinetics. Let's solve questions. The first question is, there is a reactant A which decomposes into B and C in a closed vessel of 1 liter volume. And this A is allowed to decompose at T Kelvin after 100 minutes. After 100 minutes, initial pressure is also given 1 bar. At time t equals 0, it's 1 bar. At time t equals 100, the total pressure is given, which is 1.5 bar. What is the rate constant? This is question. So question alli ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ? Initial pressure 1 bar ಕೊಟ್ಟಿದ್ದಾರೆ. 100 minutes ಆದ ನಂತರ pressure 1.5 bar ಇದೆ total pressure. Rate constant ಏನು? ಈ ತರಹ A gives rise to B plus C ಅನ್ನುವ question ಇದ್ದಾಗ, ಈ ತರಹದ ಒಂದು equation ಇದ್ದಾಗ ನಾವು rate constant ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ 2.303 by T log PI by PF. PI ಅಂದರೆ ಇನಿಷಿಯಲ್ ಪ್ರೆಷರ್, PF ಅಂದರೆ ಫೈನಲ್ ಪ್ರೆಷರ್. ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. PF ಅಂದರೆ A gives rise to B plus C ಟೈಪ್ಗೆ 2PI minus PT ಬರುತ್ತೆ. ಇಫ್ ಯು ಕ್ಯಾಲ್ಕ್ಯುಲೇಟ್ ದ್ಯಾಟ್ 2PI minus PT ಯಾವ ಥರ ಕ್ಯಾಲ್ಕ್ಯುಲೇಟ್ ಮಾಡಬೇಕನ್ನೋದು ಗೊತ್ತಿದೆ ನಿಮಗೆ ಆಲ್ರೆಡಿ, ಬಟ್ ಜಸ್ಟ್ ಐ ಆಮ್ ಟ್ರೈಂಗ್ ಟು ರಿಮೈಂಡ್ ಯು. Let us consider initially PI ಅಷ್ಟು ಪ್ರೆಷರ್ ಇದೆ. ಆಫ್ಟರ್ ಸಮ್ ಟೈಮ್ T X ಅಷ್ಟು ರಿಯಾಕ್ಟ್ ಆಗಿದೆ. ಉಳಿದಿದ್ದು PI ಮೈನಸ್ X. ಇದು 1ಗೆ 1 ಬರ್ತಾ ಇದೆ, Xಗೆ X ಬರುತ್ತೆ. 1ಗೆ 1 ಬರ್ತಾ ಇದೆ, Xಗೆ X ಬರುತ್ತೆ. ಈಗ PT ಕ್ಯಾಲ್ಕ್ಯುಲೇಟ್ ಮಾಡಿದರೆ PI ಮೈನಸ್ X ಪ್ಲಸ್ X, PI ಪ್ಲಸ್ X. ನಮಗೆ ಡೇಟಾದಲ್ಲಿ ಎಲ್ಲಿ X ವ್ಯಾಲ್ಯೂ ಕೊಡಲ್ಲ, ಸೊ Xನ್ನು ನಾವು PT ಮತ್ತು PI ಟರ್ಮ್ಸ್ನಲ್ಲಿ ಬರೆಯಬೇಕು. ಅದರಿಗೋಸ್ಕರ PT ಮೈನಸ್ PI ಈಸ್ X. ನನಗೆ ಬೇಕಾಗಿದ್ದು ಇದು PI, ಇದು PF, ಇದೇ PF ಫೈನಲ್ ಪ್ರೆಷರ್. ಈ ಫೈನಲ್ ಪ್ರೆಷರ್ ವ್ಯಾಲ್ಯೂ PI ಮೈನಸ್ X ಇರೋದರಿಂದ PI ಮೈನಸ್ X ವ್ಯಾಲ್ಯೂ PT ಮೈನಸ್ PI ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದರೆ PT ಪ್ಲಸ್ PI 2PI ಮೈನಸ್ PT ಬರುತ್ತೆ. ಆ ತರಹ ನಾನು ಇಲ್ಲಿ 2PI ಮೈನಸ್ PT ಬರೆದಿದ್ದೀನಿ. Therefore, K equals 2.303 divided by 100 minutes anantara. Initial pressure 1 and total pressure is 2PI minus PT anta bariyabeku final pressure. So, adaralli 2 into initial pressure is 1 and then total pressure is 1.5. Therefore, K equals 2.303 by 100 log 1 by 2 minus 1.5 is 0.5. ಅಂದರೆ log 2 ಇದು. log 2 is 0.3010. That equals 2.303 by 100. ಇದು 1 by 2. 1 by 1 by 2 is 2. log 2 is 0.3010, which is 0.693 divided by 100, which equals 6.93 into 10 to the power minus 3 minute inverse. ಇದು ಆನ್ಸರ್. ಇನ್ನೊಂದು ಸಲ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. A gas gives rise to B gas plus C gas ಅನ್ನುವ ಈಕ್ವೇಷನ್ ಇದ್ದಾಗ ಟೈಮ್ ಈಕ್ವಲ್ 0 ಇದೆ, 1 ಬಾರ್ ಟೈಮ್ ಇನಿಷಿಯಲ್ ಟೈಮ್ ಹತ್ತಿರ 1 ಬಾರ್ ಅಷ್ಟು ಪ್ರೆಷರ್ ಇದೆ. ಟೋಟಲ್ ಪ್ರೆಷರ್ ಆಫ್ಟರ್ 100 ಮಿನಿಟ್ಸ್ 1.5 ಬಾರ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಈಗ ಕೆ ಕ್ಯಾಲ್ಕ್ಯುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಹೇಳ್ತಿದ್ದಾರೆ. ಅದರಿಗೋಸ್ಕರ ಫಾರ್ಮುಲಾ PI ಬೈ PF. ಈ A ಗಿವ್ಸ್ ರೈಸ್ ಟು B ಪ್ಲಸ್ C ಅನ್ನುವ ಟೈಪ್ನಲ್ಲಿರುವ ರಿಯಾಕ್ಷನ್ಗೆ PF ವ್ಯಾಲ್ಯೂ 2PI ಮೈನಸ್ PT, 2PI ಮೈನಸ್ PT ಅಂತ ಬರುತ್ತೆ. ಇನಿಷಿಯಲ್ ಇಸ್ PI, X ರಿಯಾಕ್ಟ್ ಆಗಿದೆ, ಉಳಿದಿದ್ದು PI ಮೈನಸ್ X. ಅನಂತರ ಇದು X ಮತ್ತು ಅದು ಕೂಡ X ಬರ್ತಾ ಇದೆ. Therefore, PT equals PI minus X plus X plus X ಹಾಕಿದರೆ ಇದು ಸಮಪ್ಪಾಗಿ PI plus X ಬರುತ್ತೆ, which is PT minus PI, X value. ಸೊ X ವ್ಯಾಲ್ಯೂ ನಾನು ಏನು ಮಾಡಿದ್ದೀನಿ, PI minus X ದಲ್ಲಿ ಹಾಕಿದ್ದೀನಿ. It became 2PI minus PT. Then we have PI by PF, 1 by 2 minus 1.5, 1 by 0.5 ಬರುತ್ತೆ. ಅಂದರೆ 2 ones are 2 minus 1.5. Then I get 6.93 into 10 power minus 3 minute inverse. Idu answer. Let's go to another. Next. Log K versus 1 by T. Graphs ಇವು. ಇದು ಫಸ್ಟ್ ರಿಯಾಕ್ಷನ್ದು, ಇದು ಸೆಕೆಂಡ್ ರಿಯಾಕ್ಷನ್ದು, ಇದು ಥರ್ಡ್ ರಿಯಾಕ್ಷನ್ದು. Excuse me. The question is, the order of activation energies is, order of activation energies for reactions 1, 2 and 3 ಗಳಿಗೆ ಆರ್ಡರ್ ಆಫ್ ಆಕ್ಟಿವೇಶನ್ ಎನರ್ಜೀಸ್ ಯಾವ ತರಹ ಇರುತ್ತೆ ಅನ್ನೋದು ಹೇಳಬೇಕು. ಇದನ್ನು ಹೇಳಲಿಕ್ಕೆ ನಾವು ಏನು ಮಾಡ್ತಾ ಇದ್ವಿ ಅಂದರೆ, ಜನರಲಿ ಆಕ್ಟಿವೇಶನ್ ಎನರ್ಜಿ ಅನ್ನೋದು ಎಲ್ಲಿಂದ ಬರುತ್ತೆ, ಇದೇ ಈಕ್ವೇಷನ್ ನಾನು ಬರೆದ್ರೆ log k equals log a minus EA divided by 2.303 R 1 by T. ಇದು ನೋಡಲಿಕ್ಕೆ y equals mx plus c ಗ್ರಾಫ್ ವೇರ್ m is ನೆಗೆಟಿವ್ ಈ ಫಾರ್ಮ್ನಲ್ಲಿದೆ. ಆವಾಗ ನಾನು ಸ್ಲೋಪನ್ನು m ಈಕ್ವಲ್ಸ್ EA ಡಿವೈಡೆಡ್ ಬೈ 2.303 R ಅಂತ ಬರೀಬೇಕಾಗತ್ತೆ. ಫಸ್ಟ್, ಸೆಕೆಂಡ್ ಮತ್ತು ಥರ್ಡ್ ರಿಯಾಕ್ಷನ್ಗಳಿಗೆ ಖಂಡಿತ 2.303 ಬೈ R ಅನ್ನೋದು ಕಾನ್ಸ್ಟೆಂಟ್ ಇರುತ್ತೆ. ಸೊ ಡಿಫ್ರೆನ್ಸ್ ಏನಾದರೂ ಬಂದರೆ ಅದು EA ಮಾತ್ರ. EA ಅನ್ನೋದು ಸ್ಲೋಪ್ಗೆ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಇದೆ. ಯಾವುದಕ್ಕೆ ಸ್ಲೋಪ್ ಜಾಸ್ತಿ ಇದೆ ಅದರ EA ಜಾಸ್ತಿ ಇದೆ. ಅದರ ಪ್ರಕಾರ ನಾವು ಕಂಪೇರ್ ಮಾಡಿದರೆ ಹೈಯೆಸ್ಟ್ ಸ್ಲೋಪ್ ಇರೋದು ಸೆಕೆಂಡ್ ಒನ್ನಲ್ಲಿ. ಇದು ನೋಡಿ ಸ್ಲ್ಯಾಂಟ್ ಆಲ್ಮೋಸ್ಟ್ ಸ್ಟ್ರೈಟ್ ಲೈನ್ ಥರ ಇದೆ, ಅದಕ್ಕೆ ಹೈಯೆಸ್ಟ್ ಸ್ಲೋಪ್ ಇದೆ. ಸ್ಲೋಪ್ ಹೈಯೆಸ್ಟ್ ಇದ್ದರೆ ಆಕ್ಟಿವೇಶನ್ ಎನರ್ಜಿ ಕೂಡ ಹೈಯೆಸ್ಟ್, ಅಂದರೆ ಸೆಕೆಂಡ್ ಆಕ್ಟಿವೇಶನ್ ಎನರ್ಜಿ ಇಸ್ ಹೈಯರ್. ನೆಕ್ಸ್ಟ್ ಒನ್, ಈಗ ಮೂರನೇದು ಒಂದನೇದು ಕಂಪೇರ್ ಮಾಡಿದಾಗ ಫಸ್ಟ್ ಒನ್ಗೆ ಸ್ವಲ್ಪ ಇಷ್ಟು ಸ್ಲೋಪ್ ಇಲ್ಲ, ಇಷ್ಟು ಕಮ್ಮಿ ಸ್ಲೋಪ್ ಇಲ್ಲ, ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಐತಿ, ಅಂದರೆ ಸೆಕೆಂಡ್. ಫಸ್ಟ್ ಒನ್. ನೆಕ್ಸ್ಟ್ ಬಹಳ ಕಮ್ಮಿ ಸ್ಲೋಪ್, ಆಲ್ಮೋಸ್ಟ್ ಫ್ಲಾಟ್ ಲೈನ್ ಥರ ಇದೆ ಇದು. ದೇರ್ ಫಾರ್ ವಿ ನೀಡ್ ಟು ಸೇ EA3 ಫಾಲ್ಸ್ ಲಾಸ್ಟ್. ಈ ತರಹ ನಾವು ಈ ಕ್ವೆಶ್ಚನನ್ನು ಸಾಲ್ವ್ ಮಾಡಬೇಕು. ಕ್ವೆಶ್ಚನಲ್ಲಿ ಏನು ಮಾಡಿದ್ದಾರೆ, ಲಾಗ್ ಕೆಗೂ 1/Tಗೂ ಗ್ರಾಫ್ ಡ್ರಾ ಮಾಡಿ 3 ಡಿಫ್ರೆಂಟ್ ರಿಯಾಕ್ಷನ್ಸಿನ ಗ್ರಾಫ್ಸನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ. ಅದರಲ್ಲಿ ಆರ್ಡರ್ ಆಫ್ ಆಕ್ಟಿವೇಶನ್ ಎನರ್ಜೀಸ್ ಫಾರ್ ಫಸ್ಟ್, ಸೆಕೆಂಡ್ ಆ್ಯಂಡ್ ಥರ್ಡ್ ಕೇಳ್ತಿದ್ದಾರೆ. ಅದರಿಗೋಸ್ಕರ ನಾನೇನು ಮಾಡಿದ್ದೀನಿ, ಯಾವಾಗಲೂ ಕೂಡ ಇಟ್ ಓನ್ಲಿ ಚೇಂಜಸ್ ರೇಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಆ್ಯಂಡ್ ಆಕ್ಟಿವೇಶನ್ ಎನರ್ಜಿ, ಅಫ್ಕೋರ್ಸ್ ದ ರಿಯಾಕ್ಷನ್ ಪಾತ್ ಆಲ್ಸೋ, ಬಟ್ ಇಟ್ ಡಸ್ ನಾಟ್ ಚೇಂಜ್ ಡೆಲ್ಟಾ G, ಡೆಲ್ಟಾ H, ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಕಾನ್ಸ್ಟೆಂಟ್ ಕೈಂಡ್ ಆಫ್ ಫ್ಯಾಕ್ಟರ್ಸ್ ಫಾರ್ ಅ ಪರ್ಟಿಕ್ಯುಲರ್ ರಿಯಾಕ್ಷನ್. ದೇರ್ ಫಾರ್ ಎ ಅನ್ನೋದು ಈ ಥರ ಆಗುತ್ತೆ. ಬಿ ನೋಡೋಣ. ಡೆಲ್ಟಾ H ರಿಯಾಕ್ಷನ್ ಇಸ್ 20 ಕಿಲೋಜೂಲ್ ಪರ್ ಮೋಲ್ ಅಂತಿದ್ದಾರೆ. ಆ್ಯಕ್ಚುಲಿ ಆಕ್ಟಿವೇಶನ್ ಎನರ್ಜಿ ಆಫ್ ಫಾರ್ವರ್ಡ್ ರಿಯಾಕ್ಷನ್ ಸ್ವಲ್ಪ ಕಮ್ಮಿ ಇದೆ, ಬ್ಯಾಕ್ವರ್ಡ್ಗೆ ಜಾಸ್ತಿ ಇದೆ ಅಂತಂದರೆ ಇಟ್ ಶುಡ್ ಬಿ ಅನ್ ಎಕ್ಸೋಥರ್ಮಿಕ್ ರಿಯಾಕ್ಷನ್. ಎಕ್ಸೋಥರ್ಮಿಕ್ ರಿಯಾಕ್ಷನ್ನಲ್ಲಿ ಈ ಹೈಟನ್ನು 180 ತಗೊಂಡು ಈ ಹೈಟನ್ನು 200 ತಗೋಬೇಕು. ಆ ಥರ ತಗೊಂಡಿದ್ದಾಗ ನಮಗೆ ಡೆಲ್ಟಾ H ಅನ್ನೋದು ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಡಿಫ್ರೆನ್ಸ್ರಿಂದ ಬರ್ತಾ ಇರುತ್ತೆ. ದೇರ್ ಫಾರ್ ವೆನ್ ವಿ ಕನ್ಸಿಡರ್ ದಿಸ್, ಇದರಲ್ಲಿ ಅವರು ಕೊಟ್ಟಿದ್ದ ಸ್ಟೇಟ್ಮೆಂಟ್ ಏನಂತಂದರೆ ಡೆಲ್ಟಾ H ರಿಯಾಕ್ಷನ್ ಇಸ್ ಪ್ಲಸ್ 20 ಕಿಲೋಜೂಲ್ ಪರ್ ಮೋಲ್ ಅಂದರು. ಇದು ತಪ್ಪಾಗತ್ತೆ ಸ್ಟೇಟ್ಮೆಂಟ್. ಆ್ಯಕ್ಚುಲಿ ವ್ಯಾಲ್ಯೂ ಬಂದುಬಿಟ್ಟು ಅದೇ ಕರೆಕ್ಟೇ 20ನೇ, ಬಟ್ ಇದು ಎಕ್ಸೋಥರ್ಮಿಕ್ ರಿಯಾಕ್ಷನ್ ಅಂದರೆ ಮೈನಸ್ ಬರಬೇಕು. ಸೊ ಇದು ಫಾಲ್ಸ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಆಗುತ್ತೆ, ಇದು ಟ್ರೂ ಸ್ಟೇಟ್ಮೆಂಟ್ ಆಗುತ್ತೆ. ಕ್ಯಾಟಲಿಸ್ಟ್ ಕ್ಯಾನ್ ಕಾಸ್ ನಾನ್ ಸ್ಪಾಂಟೇನಿಯಸ್ ರಿಯಾಕ್ಷನ್ ಟು ಅಕ್ಕ. ಡೆಲ್ಟಾ G ಚೇಂಜ್ ಆಗಲ್ಲಲ್ವಾ? ಕ್ಯಾಟಲಿಸ್ಟ್ ಅನ್ನೋದು ಒಂದು ವೇಳೆ ಡೆಲ್ಟಾ G ಚೇಂಜ್ ಆದರೆ ಆವಾಗ ಮೇ ಬಿ ನೆಗೆಟಿವನ್ನು ಪಾಸಿಟಿವನ್ನು ನೆಗೆಟಿವ್ ಮಾಡಿ ಸ್ಪಾಂಟೇನಿಟಿಯನ್ನು ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ಬೋದು. ಆ ಥರ ಬರಲಿಕ್ಕೆ ಅವಕಾಶ ಇಲ್ಲ. ಸೊ ಡೆಲ್ಟಾ G ಚೇಂಜ್ ಆಗಲ್ಲ ಅಂದರೆ ನಾನ್ ಸ್ಪಾಂಟೇನಿಯಸ್ ರಿಯಾಕ್ಷನ್ಸನ್ನು ಕೆಟಲೈಸ್ ಮಾಡಲಿಕ್ಕೆ ಆಗಲ್ಲ. ದೇರ್ ಫಾರ್ ಇದು ಕೂಡ ಫಾಲ್ಸೇ. ಡೆಲ್ಟಾ H ಫಾರ್ ಕೆಟಲೈಸ್ಡ್ ರಿಯಾಕ್ಷನ್ ಇಸ್ ಡಿಫ್ರೆಂಟ್ ಫ್ರಮ್ ಅನ್ಕೆಟಲೈಸ್ಡ್ ರಿಯಾಕ್ಷನ್ ಅಂತಿದ್ದಾರೆ. ಇಲ್ಲ, ಬಿಕಾಸ್ ಸ್ಟಾರ್ಟ್ ಆಗೋದಿಲ್ಲೇ ಎಂಡ್ ಆಗೋದಿಲ್ಲೇ ಆಗಿರೋದ್ರಿಂದ ಎರಡಕ್ಕೂ ಕೂಡ ಡಿಫ್ರೆನ್ಸ್ ಇಟ್ ರಿಮೈನ್ಸ್ ಸೇಮ್ ಅನ್ನೋದು ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಸೊ ದಿಸ್ ಇಸ್ ವಾಟ್ ವಿ ನೀಡ್ ಟು ನೋ. Rate law for a reaction between A and B is given by R equals K into A to the power N, B to the power M. ಇದು rate law. If concentration of A is doubled and concentration of B is halved from their initial value, the ratio of new rate of reaction to the initial rate of the reaction is how much? ಇದು ನ್ಯೂ ಓಲ್ಡ್ ರೇಟ್ R1 ಅನ್ಕೋ, ಹೊಸ ರೇಟ್ R2 ಅನ್ಕೊಳ್ಳೋಣ. ಎ ಅನ್ನು ಡಬಲ್ ಮಾಡಿದ್ದಾರೆ, ಬಿ ಅನ್ನು ಹಾಫ್ ಮಾಡಿದ್ದಾರೆ. ಆವಾಗ ಎ ಡಬಲ್ ಆಗಿದ್ದಕ್ಕೆ 2a ಪವರ್ n, ಬಿ ಹಾಫ್ ಮಾಡಿದ್ದಕ್ಕೆ b ಬೈ 2 ಪವರ್ m. R2 ಈಕ್ವಲ್ಸ್ k ಇಂಟು 2 ಪವರ್ n a ಪವರ್ n by 2 power m b power m. R2 equals k into 2 power n minus m, k into a power n b power m. R2 equals 2 power n minus m. ಇದು R1 ಆಗುತ್ತೆ ಈ ಟೋಟಲ್ ವ್ಯಾಲ್ಯೂ. ಇವಾಗ ಕೇಳ್ತಾ ಇರುವ ರೇಷಿಯೋ ಯಾವುದು? ಕೇಳ್ತಾ ಇರುವ ರೇಷಿಯೋ R2 by R1. So if you send R1 that side, it is 2 power n minus m. ಇದು ಆನ್ಸರ್. ಇನ್ನೊಂದ್ಸಲ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ರೇಟ್ ಲಾ ಕೊಟ್ಟಿದ್ದಾರೆ, ಇದರಲ್ಲಿ ಎನ್ನು ಡಬಲ್ ಮಾಡಿ ಬಿ ಅನ್ನು ಹಾಫ್ ಮಾಡಿದರೆ ಏನು ಹೊಸ ರೇಟ್ ಲಾ ಬರುತ್ತೆ, ಎಷ್ಟು ಸಲ ಚೇಂಜ್ ಆಗುತ್ತೆ, R2ಗೂ R1ಗೂ ಏನು ರೇಷಿಯೋ ಬರುತ್ತೆ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. ಅದಕ್ಕೋಸ್ಕರ R2 ಅನ್ನು ನಾನು ಬರೀತಾ ಇದು 2 ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ ಬಿ ಅನ್ನು ಡಿವೈಡ್ ಮಾಡಿದ್ದೀನಿ 2 ಇಂದ. ಇದು 2 ಪವರ್ n ಆಗುತ್ತೆ, ಇದು 2 ಪವರ್ m ಆಗುತ್ತೆ. ನಾನು ಹೊರಗಡೆ ತಂದಿದ ಮೇಲೆ m ಅನ್ನು ಮ್ಯಾಲೆಗೆ ತೊಗೊಂಡು ಹೋಗಿದ್ದೀನಿ. ಈ k ಇಂಟು a ಪವರ್ n ಇಂಟು b ಪವರ್ m ಬದಲು R1 ಅಂತ ಬರೀತಾ ಇದ್ದೀನಿ. R2 ಈಕ್ವಲ್ಸ್ 2 ಪವರ್ n ಮೈನಸ್ m ಇಂಟು R1 ಅನ್ನೋದು ಬರುತ್ತೆ. Therefore what we need to understand here is, it is R2 by R1, the ratio is going to be 2 power n minus m. Let's go to the next question. The next question is all, it's full of statements given. So let's try to analyze those. We need to find the correct statements from this. The first statement is, the Arrhenius equation holds good for, holds true only for elementary homogeneous reactions. The second statement, the unit of A is same as that of K in Arrhenius equation. Statement C, at a given temperature, a low activation energy means a fast reaction. D, A and EA as used in Arrhenius equation depend on temperature. E, when EA is greater than RT, A and EA become intermediate dependent. Ivu statements. We need to find out the correct statements here. In order to find that out, Arrhenius equation holds true only for elementary homogeneous reactions. Another tappu, it holds good for all kinds of reactions. There is nothing like, it's only applicable for elementary, it is not applicable for complex reactions. It's only applicable for homogeneous, not for heterogeneous anta helike baralla. Therefore, it is a false statement. The unit of A is same as that of K in Arrhenius equation, definitely, because K equals A into e to the power minus Ca by RT. Idu fraction of molecules irodrinda idakke unit iralla, K ge unit A ge unit. So that's a true statement. At a given temperature, a low activation energy means a fast reaction. Andre, iga naan idanna expand madidaga log K equals log A minus EA divided by 2, reaction is going to be faster. So this is also a true statement. A and EA as used in Arrhenius equation depend on temperature. No, they are not actually. A and EA are not dependent on temperature. Then when EA is greater than RT, if EA is 2 greater than RT, then A and EA become interdependent antidare. Andre A EA mele EA A mele depend agatte anta heltidare. No, atara agalla. Even then EA and EA actually depends on nature of reactants but not on A. A is actually deciding number of collisions taking place. It's a frequency factor. How many collisions do take place ಅನ್ನುವ ವಿಷಯವನ್ನ A ಹೇಳ್ತಾ ಇದೆ with proper orientation. With proper orientation, number of collisions ಬರೇ ತಗೊಂಡ್ರೆ ಆವಾಗ ಟೆಂಪರೇಚರ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗ್ಬೋದು ಅದು. ಬಟ್ ವಿತ್ ಪ್ರಾಪರ್ ಓರಿಯೆಂಟೇಷನ್ ನಂಬರ್ ಆಫ್ ಕೊಲಿಷನ್ಸ್ ಜಾಸ್ತಿ ಆಗ್ತವೆ ವಿತ್ ಟೆಂಪರೇಚರ್ ಅನ್ನಕ್ಕೆ ಬರಲ್ಲ. ದೇರ್ ಫಾರ್ ಟೆಂಪರೇಚರ್ ಮೇಲೆ ಎ ಡಿಪೆಂಡ್ ಆಗಲ್ಲ. EA is also almost ಸೇಮ್ at a particular temperature. ಟೆಂಪರೇಚರ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದರೂ ಕೂಡ ಆಕ್ಟಿವೇಶನ್ ಎನರ್ಜಿಯಲ್ಲಿ ಜಾಸ್ತಿ ಡಿಫರೆನ್ಸ್ ಏನು ಬರಲ್ಲ ಅನ್ಲೆಸ್ ಯು ಯುಟಿಲೈಸ್ ಅ ಕ್ಯಾಟಲಿಸ್ಟ್ ಇನ್ ದ ರಿಯಾಕ್ಷನ್. ಸೊ ಥರ್ಡ್ ಸ್ಟೇಟ್ಮೆಂಟ್, ಫೋರ್ತ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅನ್ನೋದು ತಪ್ಪಾಗುತ್ತೆ. ಫಿಫ್ತ್ ಸ್ಟೇಟ್ಮೆಂಟ್ನಲ್ಲಿ EA ಇಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ RT. EA ಎಷ್ಟೇ ಗ್ರೇಟರ್ ಆಗಲಿ ಕೂಡ ಅದು ನಂಬರ್ ಆಫ್ ಕೊಲ್ಯೂಷನ್ಸನ್ನು ಎಫೆಕ್ಟ್ ಮಾಡಲ್ಲ. EA ಅನ್ನೋದು ಎದರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿದೆ ಅಂದರೆ ನೇಚರ್ ಆಫ್ ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿದೆ. ಆಕ್ಟಿವೇಶನ್ ಎನರ್ಜಿ ಎಷ್ಟು ಬರುತ್ತೆ ಅಂತ ಅನ್ನೋದು. ದೇರ್ ಫೋರ್ ವಿ ಕೆನಾಟ್ ಸೇ ದ್ಯಾಟ್ ಇಟ್ ಇಸ್ ಡಿಪೆಂಡೆಂಟ್ ಆನ್ A. ದೇರ್ ಫೋರ್ ವಿ ನೀಡ್ ಟು ಸೇ ದಿಸ್ ಇಸ್ ಅ ಫಾಲ್ಸ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಟು. And hence we only have two statements, B and then C, which are correct. ಈ ಕ್ವೆಶ್ಚನಲ್ಲಿ X becomes ineffective after 50% decomposition. Drug X, drug ಅಂದರೆ medicine, it becomes ineffective. ಇದು ineffective ಆಗತ್ತೆ after T50%. The original concentration of drug in a bottle was 16 milligram per milliliter. Original concentration of drug is 16 milligram per milliliter, which becomes 4 milligram per milliliter. 4 milligram per milliliter in 12 months. ಅಂದರೆ 16 4 ಆಗಬೇಕಂದ್ರೆ 12 months ಬೇಕು. What is the expiry time of the drug? Expiry time of the drug ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಇದು ಫಸ್ಟ್ ಆರ್ಡರ್ ರಿಯಾಕ್ಷನ್ ಅಂದರು. ಸೊ ಈ ಡೇಟಾ ತಗೊಂಡು ಎಕ್ಸ್ಪೈರಿ ಟೈಮ್ ಅಂದರೆ ಏನು? ಹಾಫ್ ಲೈಫೇ. ಹಾಫ್ ಲೈಫ್ ಆದರೆ ಅದು ಇನ್ಎಫೆಕ್ಟಿವ್ ಅಂದರೆ ಎಕ್ಸ್ಪೈರ್ ಆಯಿತು. ಹಾಫ್ ಲೈಫ್ ಎಷ್ಟು ಅಂತಿದ್ದಾರೆ. ನಾವು 16 grams 4 ಆಗೋದ್ರಲ್ಲಿ ಎಷ್ಟು ಹಾಫ್ ಲೈಫ್ಸ್ ಇನ್ವಾಲ್ವ್ ಆಗಿದ್ದಾವೆ ಅನ್ನೋದು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಸೊ 16 4 ಆಗೋದು ಅಂತಂದರೆ 16 8 ಆಗೋದು, 8 4 ಆಗೋದು, ಅಂದರೆ 2 ಹಾಫ್ ಲೈಫ್ಸ್ ಇನ್ವಾಲ್ವ್ ಆಗಿದ್ದಾವೆ. 2 ಹಾಫ್ ಲೈಫ್ಸ್ಗೆ ಟೈಮ್ ಪೀರಿಯಡ್ ಬಂದುಬಿಟ್ಟು 12 months. 2 ಹಾಫ್ ಲೈಫ್ಸ್ಗೆ ಟೈಮ್ ಪೀರಿಯಡ್ ಬಂದುಬಿಟ್ಟು 12 months. ಆವಾಗ 1 ಹಾಫ್ ಲೈಫ್ಗೆ ಎಷ್ಟು ಟೈಮ್ ಪೀರಿಯಡ್ ಬರುತ್ತೆ? 12/2 ಅಂದರೆ 6 months. ಸೊ ದಿ ಆನ್ಸರ್ ಈಸ್ 6 months. ಅನಂತರ ಆ ಡ್ರಗ್ ಎಕ್ಸ್ಪೈರ್ ಆಗುತ್ತೆ ಅಂತ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಇನ್ನೊಂದು ಸಲ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ಡ್ರಗ್ ಎಕ್ಸ್ ಅನ್ನೋದು 50% ಹಾಫ್ ಲೈಫ್, ಅಂದರೆ 50% ಅಂದರೆ ಹಾಫ್ ಲೈಫ್ ಆದ ನಂತರ ಅದು ಇನ್ಎಫೆಕ್ಟಿವ್ ಆಗಿಬಿಡುತ್ತೆ. ಅಂತಹ ಒಂದು ಸಿಚುವೇಷನಲ್ಲಿರುವ ಡ್ರಗ್ ಒನ್ ವಿ ಕನ್ಸಿಡರ್. ಈ ಡ್ರಗ್ ಅನ್ನೋದು 16 mg/ml ಅನ್ನು ತಗೊಂಡಿದ್ದಾಗ ಅದು 4 mg/ml ಅಷ್ಟು ಆಗಲಿಕ್ಕೆ 12 months ಅಷ್ಟು ಟೈಮ್ ಬೇಕಾಗತ್ತೆ. ಸೊ ಎಕ್ಸ್ಪೈರಿ ಟೈಮ್ ಅನ್ನೋದು ಎಷ್ಟು ಅನ್ನೋದು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಹೇಳ್ತಿದ್ದಾರೆ. ಎಕ್ಸ್ಪೈರಿ ಟೈಮ್ ಅಂದರೆ 50%, ಯಾಕಂದರೆ 50% ಆದಮೇಲೆ ಇನ್ಎಫೆಕ್ಟಿವ್ ಆಗಿಬಿಡುತ್ತೆ. ಅವ್ರು ಹೇಳಿದ ಪ್ರಕಾರ 16 4 ಆಗಬೇಕಂದ್ರೆ 12 months ಅಲ್ವಾ, ಅಂದರೆ 16 8 ಆಗಿ 8 4 ಆಗಲಿಕ್ಕೆ ಅದು 12 months ಆಗ್ತಿದ್ರೆ 1 ಹಾಫ್ ಲೈಫ್ಗೆ 6 months ಬೇಕು, ಅಂದರೆ ಅದೇ ಎಕ್ಸ್ಪೈರಿ ಡೇಟ್ ಆಗುತ್ತೆ, ಎಕ್ಸ್ಪೈರಿ ಟೈಮ್ ಆಗುತ್ತೆ. ಸೊ ದ್ಯಾಟ್ಸ್ ದ ಆನ್ಸರ್ ಟು ದ ಕ್ವೆಶ್ಚನ್. ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್ಗೆ ಹೋಗೋಣ. ಈ ರಿಯಾಕ್ಷನಲ್ಲಿ A2 + B2 ಗಿವ್ಸ್ ರೈಸ್ ಟು 2AB ಅನ್ನೋದು ರಿಯಾಕ್ಷನ್. ಅದಕ್ಕೆ ಮೆಕ್ಯಾನಿಸಮ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಈ ಮೆಕ್ಯಾನಿಸಮ್ದಲ್ಲಿ A2 ರಿವರ್ಸಿಬಲ್ ಆರೋ K1 K-1 ಅಂದರೆ ರಿವರ್ಸಿಬಲ್ಗೆ ಆ ಥರ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಾರೆ. A plus A is a fast reaction. A plus B2 K2 is a slow reaction. A plus B gives rise to AB is a fast reaction. Overall order of the reaction. ಯಾವಾಗಾದರೂ ಓವರಾಲ್ ಆರ್ಡರನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕಂದ್ರೆ ಇಟ್ ಓನ್ಲಿ ಡಿಪೆಂಡ್ಸ್ ಅಪಾನ್ ದ ಸ್ಲೋವೆಸ್ಟ್ ಸ್ಟೆಪ್ ಆಫ್ ದ ರಿಯಾಕ್ಷನ್. ಸೊ ದ ಸ್ಲೋವೆಸ್ಟ್ ಸ್ಟೆಪ್ ಇಸ್ ದಿಸ್ ಒನ್. ದೇರ್ಫೋರ್ ಆರ್ ಈಕ್ವಲ್ಸ್ ಕೆ ಇಂಟು K2 ಇಂಟು ರೇಟ್ ಲಾ ಇದರಿಂದನೇ ಬರೆಯಬೇಕು. ಸ್ಟಾಯ್ಕ್ಯೋಮೆಟ್ರಿಕ್ ಕೋಎಫಿಷಿಯಂಟ್ ಫಾರ್ ದಿಸ್ ಬರೆಯಬೇಕು. ಆದರೆ ಎ ಅಂತ ಬರೆಯಬೇಕು. ಎ ವೆನ್ ವಿ ಕನ್ಸಿಡರ್ A is not really a reactant. It is actually obtained from A2. A2 ರಿಂದ obtain ಆಗಿದ ಒಂದು ಇದು. Therefore ನಾನು ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, A into B2 ಅಂತ ಬರೀತಾ ಇದ್ದೀನಿ. ಇದು ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಆಗುತ್ತೆ. ಇಂಟರ್ಮೀಡಿಯೇಟ್ಸ್ ಯಾವತ್ತೂ ಕೂಡ ನಮಗೆ ರಿಯಾಕ್ಷನ್ ರೇಟ್ ಲಾದಲ್ಲಿ ಇರಬಾರ್ದು. ರಿಯಾಕ್ಷನ್ ರೇಟ್ ಲಾದಲ್ಲಿ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಇರಬಾರ್ದಲ್ವಾ, ಅದರಿಗೋಸ್ಕರ ನಾವೇನು ಮಾಡಬೇಕು, ಅದು ಎಲ್ಲಿಂದ ಫಾರ್ಮ್ ಆಗಿದೆ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಅನ್ನೋದು ಆ ಸ್ಟೆಪ್ಗೆ ಹೋಗಬೇಕು. ಸೊ ಎಲ್ಲಿಂದ ಫಾರ್ಮ್ ಆಗಿದೆ ಇಂಟರ್ಮೀಡಿಯೇಟು? ಫಸ್ಟ್ ಸ್ಟೆಪ್ರಿಂದ ಫಾರ್ಮ್ ಆಗಿದೆ. ಈ ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಏನಾಗಿದೆ, ಇಟ್ ಈಸ್ ರಿವರ್ಸಿಬಲ್. ಯಾವಾಗ ರಿವರ್ಸಿಬಲ್ ರಿಯಾಕ್ಷನ್ಸ್ ಇರ್ತವೆ ಅವುಗಳಕ್ಕೆ ನಾವು ಖಂಡಿತ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಕಾನ್ಸ್ಟೆಂಟನ್ನು ಬರೆಯಬಹುದು. ಸೊ ಐ ರೈಟ್ ಕೆ equilibrium constant as A concentration into A concentration divided by A2 concentration. ನಾನು A ಬದಲು ಏನಾದರೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು, ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಇರಬಾರ್ದು ಅಂತ ಅಂದ್ಕೊಳ್ತಾ ಇದ್ದೀನಿ. ಅದಕ್ಕೆ A2 ಇಲ್ಲಿ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡ್ತೇನೆ. A ಇಂಟು A ಕಾನ್ಸಂಟ್ರೇಷನ್ A² ಆಗುತ್ತೆ. ಸ್ಕ್ವೇರ್ ರೂಟ್ ಅಪ್ಲೈ ಮಾಡ್ತೀನಿ. ರೂಟ್ ಓವರ್ ಕೆ ಇಂಟು ರೂಟ್ ಓವರ್ A2 A ಆಗುತ್ತೆ. ಅಂದರೆ ರೂಟ್ ಓವರ್ ಕೆ ಇಂಟು A2 ಪವರ್ ಹಾಫ್ ಆಗುತ್ತೆ. ಇದರ ಈ ವ್ಯಾಲ್ಯೂ ಆಫ್ A ಏನಿದೆ ಅದು ತೊಗೊಂಡು ಹೋಗಿ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀನಿ. ಅವಾಗ ಆರ್ ಈಕ್ವಲ್ಸ್ ಕೆ ಟು ಇಂಟು ಎ ಬದಲು ರೂಟ್ ಕೆ ಇಂಟು ಎ ಪವರ್ ಹಾಫ್ ಎ ಟು ಪವರ್ ಹಾಫ್ ಇಂಟು ಬಿ ಟು ಅಂತ ಬರುತ್ತೆ. ಈಗ ನಾನು ಆರ್ಡರ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಂದ್ರೆ ಆರ್ ಈಕ್ವಲ್ಸ್ ಇದು ಕಾನ್ಸ್ಟೆಂಟೇ ಅದು ಕಾನ್ಸ್ಟೆಂಟೇ, ಎರಡು ಕಾನ್ಸ್ಟೆಂಟ್ಸಿನ ಪ್ರಾಡಕ್ಟ್ ಆಬ್ವಿಯಸ್ಲಿ ಒಂದು ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗುತ್ತೆ. ಎ ಟು ಪವರ್ ಹಾಫ್ ಇಂಟು ಬಿ ಟು ಪವರ್ 1 ಆವಾಗ ಹಾಫ್ ಪ್ಲಸ್ 1 ಇಸ್ 3/2 ಇಸ್ 1.5. ಇದು ಟೋಟಲ್ ಸಾಲ್ಯೂಷನ್ ಆಫ್ ದ ಪ್ರಾಬ್ಲಮ್. ಇನ್ನೊಂದು ಸಲ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, A2 plus B2 gives rise to 2AB ಅನ್ನೋದು ಕ್ವೆಶ್ಚನ್. ಅದರ ಮೆಕ್ಯಾನಿಸಮ್ ಕೊಟ್ಟಿದ್ದಾರೆ 3 ಸ್ಟೆಪ್ಸ್ನಲ್ಲಿ. ಅದಕ್ಕೆ ಆರ್ಡರ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು ನಾವು. ಆರ್ಡರ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕಂದ್ರೆ ರೇಟ್ ಲಾ ಎಲ್ಲಿಂದ ತಗೋಬೇಕು? ಸ್ಲೋವೆಸ್ಟ್ ಸ್ಟೆಪ್ರಿಂದ ತಗೋಬೇಕು. ಬಿಕಾಸ್ ದ ಸ್ಲೋವೆಸ್ಟ್ ಸ್ಟೆಪ್ ಇಸ್ ದ ರೇಟ್ ಡಿಟರ್ಮಿನಿಂಗ್ ಸ್ಟೆಪ್. ಈ ರೇಟ್ ಡಿಟರ್ಮಿನಿಂಗ್ ಸ್ಟೆಪ್ ಇದಿದೆ ಅಲ್ವಾ, ಅದು ಎಲಿಮೆಂಟ್ರಿ ರಿಯಾಕ್ಷನ್ ಅಂತ ಅಂದ್ಕೊಂಡ್ರೆ ಆವಾಗ ಆ ಎಲಿಮೆಂಟರಿ ರಿಯಾಕ್ಷನ್ನಲ್ಲಿ ಈ ಸ್ಟಾಯ್ಕ್ಯೋಮೆಟ್ರಿಕ್ ಕೋಎಫಿಷಿಯೆಂಟ್ಸೇ ಪವರ್ಸ್ ಆಗ್ತವೆ. ಆವಾಗ ಎ ಪವರ್ 1 B2 ಪವರ್ 1. B2 ಅನ್ನೋದು ಒಂದು ರಿಯಾಕ್ಟೆಂಟ್, ಓಕೆ, ಬಟ್ ಎ ಈಸ್ ನಾಟ್ ಅ ರಿಯಾಕ್ಟೆಂಟ್, A2 ಇಸ್ ದ ರಿಯಾಕ್ಟೆಂಟ್. ದೇರ್ ಫಾರ್ ವಾಟ್ ಡಿಡ್ ಐ ಡೂ ಇಸ್ ಎ ರಿಯಾಕ್ಟೆಂಟ್ ಅನ್ನೋದು ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಅಂತ ಐಡೆಂಟಿಫೈ ಮಾಡಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ಎ ಬದಲು ಏನಾದರೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಲಿಕ್ಕೆ ಆಗತ್ತಾ ಅಂತ ನೋಡ್ತಾ ಇದ್ದೀನಿ. ಆವಾಗ ನನಗೆ ಇದು ಕಂಡು ಬಂತು, ವೇರ್ ಎ ಈಸ್ ಫಾರ್ಮ್ಡ್ ಫ್ರಮ್. ಎ ಇಲ್ಲಿಂದ ಬಂದಿರೋದ್ರಿಂದ ಅದು ರಿವರ್ಸಿಬಲ್ ಆಗಿರೋದ್ರಿಂದ ಅದಕ್ಕೆ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಕಾನ್ಸ್ಟೆಂಟನ್ನು ಬರೆದಿದ್ದೀನಿ. ಆವಾಗ ಎ ಇಂಟು ಎ ಸ್ಕ್ವೇರ್ ಆಯಿತು, ಡಿವೈಡೆಡ್ ಬೈ A2 ಬಂತು. ನನಗೆ A2 ಬದಲು ಏನಾದರೂ ಬರೆಯಬೇಕು, ಅದರಿಗೋಸ್ಕರ ಎ ಬದಲು ಏನಾದರೂ ಬರೀಬೇಕು, ಅದರಿಗೋಸ್ಕರ ಎ ಬದಲು ನಾನು ಈ ರೂಟ್ ಕೆ ಇಂಟು A2 ಪವರ್ ಹಾಫ್ ಅಂತ ಬರೆದಿದ್ದೀನಿ. ಅದು ತೊಗೊಂಡು ಹೋಗಿ ಇದರಲ್ಲಿ ಹಾಕಿದ್ದೀನಿ. ಆವಾಗ ಹಾಫ್ ಪ್ಲಸ್ 1 3/2 ಆಯಿತು, ಅದು 1.5 ಬಂದಿದೆ. ಇದು ಟೋಟಲ್ ಸೊಲ್ಯೂಷನ್ ಫಾರ್ ದಿಸ್ ಕ್ವೆಶ್ಚನ್. ಲೆಟ್ಸ್ ಗೋ ಟು ದ ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್. Consider an elementary reaction. Next question. A gives rise to A plus B gives rise to C plus D. If the volume of the reaction mixture is suddenly reduced to 1/3 of its initial volume. ಇದು ಎಲಿಮೆಂಟರಿ ರಿಯಾಕ್ಷನ್. ಫಸ್ಟ್ ಥಿಂಗ್ ಅದು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕು. ಇದರಲ್ಲಿ ವಾಲ್ಯೂಮ್ ಆಫ್ ದ ವೆಸಲನ್ನು 1/3 ಆಫ್ ಇಟ್ಸ್ ವಾಲ್ಯೂಮ್ಗೆ ಕಮ್ಮಿ ಮಾಡಿದ್ದಾರೆ. ವಿ ಇನಿಷಿಯಲ್ ಅಂದ್ಕೊಂಡ್ರೆ V/3 ಫೈನಲ್ ಮಾಡಿದ್ದಾರೆ. ದ ರಿಯಾಕ್ಷನ್ ರೇಟ್ ವಿಲ್ ಬಿಕಮ್ ಹೌ ಮಚ್ ಅನ್ನೋದು ಕ್ವೆಶ್ಚನ್. ಫಸ್ಟ್ ಇನಿಷಿಯಲ್ ರೇಟ್ ಲಾ ಬರೆಯೋಣ. Rate law equals K into concentration of A power 1 into B power 1. Elementary reaction ನಲ್ಲಿ stoichiometric coefficients powers. Therefore R equals K into A power 1 into B power 1. ಇದನ್ನೇ R equals K into concentration ಅಂದರೆ N by V. Number of moles of A by volume V. Number of moles of B by volume V. ಈಗ ನಾನೇನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಇದು ಆರ್ ಅಂದ್ಕೊಂಡ್ರೆ ಈಗ ವಾಲ್ಯೂಮ್ ಆಫ್ ದ ವೆಸಲನ್ನು ಚೇಂಜ್ ಮಾಡ್ತಾ ಇದ್ವಿ. ವಾಲ್ಯೂಮ್ ಆಫ್ ದ ವೆಸಲ್ ಯಾವಾಗ ಚೇಂಜ್ ಮಾಡ್ತೀನಿ ಅವಾಗ ಆಟೋಮ್ಯಾಟಿಕಲಿ ರೇಟ್ ಕೂಡ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಅದಕ್ಕೆ ಹೊಸ ರೇಟನ್ನು R1 ಅಂದ್ಕೊಳ್ತಾ ಇದ್ದಾನೆ. ಅಂದ್ಕೊಂಡ್ರೆ ಕೆ ಇಂಟು NA ಡಿವೈಡೆಡ್ ಬೈ ವಾಲ್ಯೂಮ್ ಆಫ್ ದ ವೆಸಲ್ 1/3 ಆಗಿದೆ, ಹಳೇದಕ್ಕಿಂತ ಥರ್ಡ್ ಆಗಿದೆ. ಸೊ NB ಡಿವೈಡೆಡ್ ಬೈ V/3 ಅದು ಕೂಡ. ಆವಾಗ R1 ಈಕ್ವಲ್ಸ್ K ಇಂಟು ಈಗ 3 ಮ್ಯಾಲಗೆ ಹೋಗಿಬಿಟ್ರೆ 3 ಪವರ್ 1, ಇದು ಕೂಡ 3 ಪವರ್ 1 ಇಂಟು K NA ಬೈ V NB ಬೈ V ಅಂತ ಬರುತ್ತೆ. R1 ಈಕ್ವಲ್ಸ್ 3 3s are 9. K ಇಂಟು NA ಬೈ V NB ಬೈ V ಅಂದರೆ ಏನು? which is none other than R. So old rate ಕಿಂತ ಕೂಡ 9 times ಜಾಸ್ತಿ ಆಗತ್ತೆ ನ್ಯೂ ರೇಟ್. ಇಷ್ಟು ವಿಷಯ ನಾವು ತಿಳ್ಕೋಬೇಕು. Therefore, A plus B gives rise to C plus D. V is becoming V by 3. R equals K into A power 1 into B power 1 ಅನ್ನುವ ರೇಟ್ ಲಾ ಬರೆದಿದ್ದೀನಿ. ಕಾರಣ ಇದು ಎಲಿಮೆಂಟ್ರಿ ರಿಯಾಕ್ಷನಲ್ಲಿ ಸ್ಟಾಯ್ಕ್ಯೋಮೆಟ್ರಿಕ್ ಕೋಎಫಿಷಿಯಂಟ್ಸನ್ನು ಪವರ್ಸ್ ಆಗಿ ಬರ್ಕೊಂಡು ಆರ್ಡರ್ನ ಡಿಟರ್ಮೈನ್ ಮಾಡ್ಬೋದು. ದೇರ್ಫೋರ್ ಆರ್ಡರ್ 2 ಆಗುತ್ತೆ ಈ ರಿಯಾಕ್ಷನ್ಗೆ. ನನಗೆ ವಾಲ್ಯೂಮ್ ಚೇಂಜ್ ಮಾಡಿರೋದ್ರಿಂದ ಇಲ್ಲೆಲ್ಲಿ ವಾಲ್ಯೂಮ್ ಕಾಣ್ತಾ ಇಲ್ಲ, ಅದಕ್ಕೆ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಬದಲು ಎನ್ ಬೈ ವಿ ಅಂತ ಬರೆದಿದ್ದೀನಿ. ಎನ್ ಎ ಬೈ ವಿ ಎನ್ ಬಿ ಬೈ ವಿ ಅಂತ ಬರೆದು ವಿ ಇಂಟು ವಿ ನಾನು ನೋಡಿದಾಗ ಇದು ರೇಟ್ ಲಾ ಆಗುತ್ತೆ. ಈಗ ವಾಲ್ಯೂಮ್ ಏನು ಮಾಡಿದ್ದಾರೆ, 1/3 ಮಾಡಿದ್ದಾರೆ, ಅಂದರೆ ವಿ ಬೈ 3 ಆಯಿತು. ಅದಕ್ಕೆ ವಾಲ್ಯೂಮ್ ಈಸ್ ರೀಪ್ಲೇಸ್ಡ್ ಬೈ ವಿ ಬೈ 3. ಇದು ಮೇಲಕ್ಕೆ ಹೋದಾಗ 3 3s are 9 ಆಗುತ್ತೆ. ಸೊ ಇದೆಲ್ಲ ಕೂಡ ಆರ್ ಆಗುತ್ತೆ. R1 ಈಕ್ವಲ್ಸ್ 9R ಅನ್ನೋದು ವಿಷಯ. ದಿಸ್ ಇಸ್ ವಾಟ್ ವಿ ನೀಡ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. Let's go to the next important part. So for a reaction, N2O5 gas gives rise to 2NO2 plus half O2 in a constant volume container. No products were present initially. The final pressure of the system when 50% of reaction gets completed is only 50% complete ಆಗಿದೆ. ಆವಾಗ ಇನಿಷಿಯಲ್ ಪ್ರೆಷರ್ಗೂ ಫೈನಲ್ ಪ್ರೆಷರ್ಗೂ ರಿಲೇಷನ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು ನಾವು. ಅದು ಕ್ವೆಶ್ಚನ್. ಸೊ ಇನಿಷಿಯಲ್ ಪ್ರೆಷರನ್ನು P0 ಅಂದ್ಕೊಳ್ಳೋಣ. ಇದರಲ್ಲಿ 50% ರಿಯಾಕ್ಟ್ ಆಗಿದೆ. 50% ರಿಯಾಕ್ಟ್ ಆಗಿದೆ ಅಂದರೆ P0/2 ರಿಯಾಕ್ಟ್ ಆಗಿದೆ. ಉಳಿದಿದ್ದು P0/2. ಇದು ಟೇಕನ್, ಇದು ರಿಯಾಕ್ಟೆಡ್, ಇದು ರಿಮೈನಿಂಗ್. ಒಂದು ಟೇಕನ್, ಒಂದು ರಿಯಾಕ್ಟೆಡ್, ಒಂದು ರಿಮೈನಿಂಗ್. ಇವಾಗ 1ಗೆ 2 moles ಬರ್ತಾ ಇದೆ ಅಂದರೆ P0/2 molesಗೆ ಎಷ್ಟು ಬರುತ್ತೆ? 1ಗೆ 2 ಅಂದರೆ 1 ರಿಯಾಕ್ಟ್ ಆದರೆ ಡಬಲ್ ಆಗ್ತಾ ಇದೆ. P0/2ಗೆ ಡಬಲ್ ಅಂದರೆ P0. ಇದು 1ಗೆ ಹಾಫ್ ಬರ್ತಾ ಇದೆ ಅಂದರೆ P0/2ಗೆ P0/2ನಲ್ಲಿ ಹಾಫ್ ಬರುತ್ತೆ. ಈಗ ಟೋಟಲ್ ಪ್ರೆಷರ್ ಮೆಷರ್ ಮಾಡಬೇಕು. LCM ತಗೋಬೇಕು. P0/4 ಟೈಮ್ಸ್ ಅಂದರೆ ಇನಿಷಿಯಲ್ ಪ್ರೆಷರ್ ಎಷ್ಟು ಸಲ ಚೇಂಜ್ ಆಗಿದೆ ಅಂತಂದರೆ 7/4 ಟೈಮ್ಸ್ ಆಫ್ ಇನಿಷಿಯಲ್ ಪ್ರೆಷರ್ ಆಗಿದೆ ಫೈನಲ್ ಪ್ರೆಷರ್. ಇನ್ನೊಂದು ಸಲ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ಈ ಈಕ್ವೇಷನ್ ಕೊಟ್ಟು ಇದರಲ್ಲಿ ಏನು ಮಾಡಿದ್ದಾರೆ, T 50% ಆಗೋ ತಲಕ್ಕೆ ಇನಿಷಿಯಲ್ ಪ್ರೆಷರ್ ಅನ್ನೋದು ಎಷ್ಟಾಗತ್ತೆ ಅನ್ನೋದು ಕೇಳ್ತಿದ್ದಾರೆ. ಅದರಿಗೋಸ್ಕರ ಟೇಕನ್ ಇನಿಷಿಯಲ್ ಪ್ರೆಷರ್ P0 ಅಂದ್ಕೊಂಡಿದ್ದೀನಿ. ರಿಯಾಕ್ಟ್ ಆಗಿದ್ದು 50% ಆಗಿರೋದ್ರಿಂದ P0/2 ಅಂತ ತೊಗೊಂಡಿದ್ದೀನಿ. ತೊಗೊಂಡಿದ್ದು ರಿಯಾಕ್ಟ್ ಆಗಿದ್ದು ಉಳಿದಿದ್ದು P0/2. ಆವಾಗ ನಾವು 1 ತೊಗೊಂಡ್ರೆ 2 ಬರ್ತಾ ಇದೆ ಅಲ್ವಾ, P0/2 ತೊಗೊಂಡ್ರೆ ಅದಕ್ಕೆ ಡಬಲ್ ಅಂದರೆ P0 ಬರುತ್ತೆ. 1 ತೊಗೊಂಡ್ರೆ ಹಾಫ್ ಬರ್ತಾ ಇದೆ ಅಲ್ವಾ, ಅಂದರೆ P0/2 ಅಂದರೆ ಅದರಲ್ಲಿ ಹಾಫ್ ಬರುತ್ತೆ, ವಿಚ್ ಇಸ್ P0/4. ಇವಾಗ ಟೋಟಲ್ ಪ್ರೆಷರ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ದೇರ್ಫೋರ್ ಅದಕ್ಕೆ P0/2 P0/4 ತೊಗೊಂಡು ನಾನು LCM ಹಾಕಿದರೆ 7/4 P0 ಬರ್ತಾ ಇದೆ. ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್ಗೆ ಹೋಗೋಣ. ಇದು ಎನರ್ಜಿ, ಇದು ರಿಯಾಕ್ಷನ್ ಕೋಆರ್ಡಿನೇಟ್. ಗ್ರಾಫ್ E2 E1 activated complex. ಇದು ರಿಯಾಕ್ಟೆಂಟ್, ಇದು ಪ್ರಾಡಕ್ಟ್. ಇದಕ್ಕೆ ಸಂಬಂಧಪಟ್ಟಂಥ ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಯಾವುದು ಕರೆಕ್ಟ್ ಅನ್ನೋದು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಫಸ್ಟ್, activation energy of both forward and backward reactions is E1 plus E2 and reactant is more stable than product. Next, activation energy of forward reaction is E1 plus E2 and product is more stable than reactant. Statement 3. Activation energy of backward is even and product is more stable than reactant. Last statement, activation energy of forward reaction is E1 plus E2 and product is less stable than reactant. This statement. Let's see how to understand this. What we are trying to know here is, ಇದರಲ್ಲಿ ಗ್ರಾಫ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಗ್ರಾಫ್ನಲ್ಲಿ ಇಟ್ ಈಸ್ ಕ್ಲಿಯರ್ಲಿ ಅಂಡರ್ಸ್ಟುಡ್ ದಟ್ ಬ್ಯಾಕ್ವರ್ಡ್ ರಿಯಾಕ್ಷನ್ಗೆ ಆಕ್ಟಿವೇಶನ್ ಎನರ್ಜಿ E1, ಫಾರ್ವರ್ಡ್ ರಿಯಾಕ್ಷನ್ಗೆ ಆಕ್ಟಿವೇಶನ್ ಎನರ್ಜಿ E1 ಪ್ಲಸ್ E2. ಈಗ ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ, ಆಕ್ಟಿವೇಶನ್ ಎನರ್ಜಿ ಆಫ್ ಬೋತ್ ಫಾರ್ವರ್ಡ್ ಆ್ಯಂಡ್ ಬ್ಯಾಕ್ವರ್ಡ್ ರಿಯಾಕ್ಷನ್ಸ್ ಈಸ್ E1 ಪ್ಲಸ್ E2. ಯಾವತ್ತೂ ಕೂಡ ರಿಯಾಕ್ಷನ್ಸ್ನಲ್ಲಿ ಸೇಮ್ ಆಕ್ಟಿವೇಶನ್ ಎನರ್ಜಿ ಫಾರ್ ಬೋತ್ ಫಾರ್ವರ್ಡ್ ಆ್ಯಂಡ್ ಬ್ಯಾಕ್ವರ್ಡ್ ಅನ್ನೋದು ಇರಲ್ಲ. ದೇರ್ ಫೋರ್ ಇದರಲ್ಲಿ ಇಷ್ಟಿದೆ E1 ಪ್ಲಸ್ E2, ಅದು E1, ಸೊ ತಪ್ಪದು. ಆ್ಯಂಡ್ ರಿಯಾಕ್ಟೆಂಟ್ ಈಸ್ ಮೋರ್ ಸ್ಟೇಬಲ್. ಹೌದು, ರಿಯಾಕ್ಟೆಂಟ್ is more stable because it has lower energy than product. So first statement is false statement. Activation energy form for forward reaction is E1 plus E2. ಹೌದು, ಅದು ಕರೆಕ್ಟೇ. ಆ್ಯಂಡ್ ಪ್ರಾಡಕ್ಟ್ ಈಸ್ ಮೋರ್ ಸ್ಟೇಬಲ್. ಇಲ್ಲ, ಪ್ರಾಡಕ್ಟ್ಗೆ ಜಾಸ್ತಿ ಎನರ್ಜಿ ಐತಿ, ದೇರ್ ಫೋರ್ ಅದು ಲೆಸ್ ಸ್ಟೇಬಲ್ ಆಗುತ್ತೆ. ಇದು ಫಾಲ್ಸ್ ಸ್ಟೇಟ್ಮೆಂಟ್. ಆಕ್ಟಿವೇಶನ್ ಎನರ್ಜಿ ಆಫ್ ಬ್ಯಾಕ್ವರ್ಡ್ ರಿಯಾಕ್ಷನ್ ಈಸ್ E1 ಆ್ಯಂಡ್ ಪ್ರಾಡಕ್ಟ್ ಈಸ್ ಮೋರ್ ಸ್ಟೇಬಲ್ ದ್ಯಾನ್ ರಿಯಾಕ್ಟೆಂಟ್. ಆಕ್ಟಿವೇಶನ್ ಎನರ್ಜಿ ಆಫ್ ಬ್ಯಾಕ್ವರ್ಡ್ ರಿಯಾಕ್ಷನ್ ಅಂತಂದರೆ ರಿವರ್ಸ್ ರಿಯಾಕ್ಷನ್ E1. ಹೌದು, ಕರೆಕ್ಟೇ. ಪ್ರಾಡಕ್ಟ್ ಈಸ್ ಮೋರ್ ಸ್ಟೇಬಲ್, ತಪ್ಪು. ದೇರ್ ಫೋರ್ ಇದು ಕೂಡ ಫಾಲ್ಸ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಆಗುತ್ತೆ. ಆಕ್ಟಿವೇಶನ್ ಎನರ್ಜಿ ಆಫ್ ಫಾರ್ವರ್ಡ್ ರಿಯಾಕ್ಷನ್ ಇಸ್ E1 ಪ್ಲಸ್ E2 ಆ್ಯಂಡ್ ಪ್ರಾಡಕ್ಟ್ ಈಸ್ ಲೆಸ್ ಸ್ಟೇಬಲ್ ದ್ಯಾನ್ ರಿಯಾಕ್ಟೆಂಟ್. ಇದು ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಆಕ್ಟಿವೇಶನ್ ಎನರ್ಜಿ ಆಫ್ ಫಾರ್ವರ್ಡ್ ರಿಯಾಕ್ಷನ್ ಅದು E1 ಪ್ಲಸ್ E2ನೇ, ಪ್ರಾಡಕ್ಟ್ ಈಸ್ ಲೆಸ್ ಸ್ಟೇಬಲ್ ದ್ಯಾನ್ ರಿಯಾಕ್ಟೆಂಟೇ, ಬಿಕಾಸ್ ಪ್ರಾಡಕ್ಟ್ಸ್ ಎನರ್ಜಿ is higher than reactants energy. Higher is the energy, lower is the stability. So option number 4 is a correct statement. So that's the correct answer. Next question. For a chemical reaction, A plus B gives rise to products ordered with respect to A and B is 1. ಪ್ರತಿ ಒಂದು ಅಂದರೆ ಎ ಮತ್ತು ಬಿ ಎರಡಕ್ಕೂ ಕೂಡ 1 ಈಚ್. ಇಲ್ಲಿ ರೇಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ 0.1, 0.4, 0.8. ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ಎ ಕೊಟ್ಟಿದ್ದಾರೆ 20x40. ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ಬಿ ಕೊಟ್ಟಿದ್ದಾರೆ 0.5, 0.5 and y. We need to find out x and y. So rate law ಬರೆದಿದ್ದಾರೆ ಇದಕ್ಕೆ. Rate law is k into a to the power x, a power 1 into b power y. b power ಕೂಡ 1. ಆವಾಗ ಏನು ಮಾಡಿದ್ದಾರೆ ಇಲ್ಲಿ 0.5 to 0.5 ಅಂದರೆ ಬಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಇದೆ, ಸದ್ಯಕ್ಕೆ ಇದು ತಗೊಳ್ಳುವ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಇವಾಗೇನು ಇದು ಎಕ್ಸ್ ಟೈಮ್ಸ್ ಇನ್ಕ್ರೀಸ್ ಆದರೆ ಇದು ಕೂಡ ಎಕ್ಸ್ ಟೈಮ್ಸ್ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಇಫ್ ಐ ಇನ್ಕ್ರೀಸ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ದ ರಿಯಾಕ್ಟೆಂಟ್ ಬೈ ಎಕ್ಸ್, ಆವಾಗ ನೋಡಿ ರೇಟ್ ಕೂಡ ಎಕ್ಸ್ ಟೈಮ್ಸ್ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ. ಸೊ ಇದರಲ್ಲಿ ಎಷ್ಟು ಚೇಂಜ್ ಬರುತ್ತೆ, ಇದರಲ್ಲಿ ಕೂಡ ಅಷ್ಟೇ ಚೇಂಜ್ ಬರುತ್ತೆ, ಬಿಕಾಸ್ ಪವರ್ ಇಸ್ 1. ಹಾಗಾಗಿ ಇದರಲ್ಲಿ ನಾವೇನು ಮಾಡಬೇಕು, 4 ಟೈಮ್ಸ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಇದೆ. ಇದು 4 ಸಲ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಇದ್ದರೆ ಇದು ಎಷ್ಟು ಸಲ ಇನ್ಕ್ರೀಸ್ ಆಗಿರಬೇಕು, ಅದು ಕೂಡ 4 ಸಲನೇ ಇನ್ಕ್ರೀಸ್ ಆಗಿರಬೇಕು. ಆವಾಗ 4 into 20 is 80. ಎರಡನೇದು ನೋಡಿ 80 to 40 ಏನಾಗಿದೆ, ಇದು 80 to 40 ಇದು ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಇದೆ. ಇಫ್ ದಟ್ ಈಸ್ 80, ದಿಸ್ ಇಸ್ ಸೆಟ್ ಟು ಬಿ 40. ದೇರ್ಫೋರ್ 80 to 40 ಇದೇನಾಗ್ತಾ ಇದೆ, ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಇದೆ, ಹಾಫ್ ಆಗಿದೆ. ಇದೇನಾಗಿದೆ, ವಾಟ್ ಹ್ಯಾಪನ್ ಟು ದಿಸ್ ಒನ್ 0.52 ಇದು ಅನ್ನೋದು ನಾವು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಅದರಿಗೋಸ್ಕರ r equals k into a power 1 and b power y. ಇದು ಎಷ್ಟು ಸಲ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ, 2 ಟೈಮ್ಸ್. 2r equals ಅಂತ ಬರೆದು ಕೆ ಅನ್ನೋದು ಹಾಕಿ ಇದು ಹಾಫ್ 80-40 ಆಗಿದೆ, ಅಂದರೆ ಹಾಫ್ ಟೈಮ್ಸ್ ಆಗಿದೆ. ಬಿ ಎಷ್ಟು ಸಲ ಚೇಂಜ್ ಆಗಿದೆ ಅನ್ನೋದು ಗೊತ್ತಾಗ್ತಾ ಇಲ್ಲ. ಸೊ ನಾನು n ಟೈಮ್ಸ್ ಚೇಂಜ್ ಆಗಿದೆ ಅಂತ ಅಂದ್ಕೊಳ್ತಾ ಇದ್ದೇನೆ. ಅವಾಗಿದು ಪವರ್ 1 ಪವರ್ 1. 2r equals half into n power 1 into k into a power 1 into b power 1 ಬರೆದ್ರೆ ಇದು ಕೂಡ ಆರೇ ತಾನೆ. ಸೊ 2r equals half into n power 1 into r. r and r gets cancelled 4 times. 4 equals n. ಅಂದರೆ 0.5 ಎಷ್ಟು ಸಲ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ ಅಂತಂದರೆ 4 ಸಲ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ. 0.5 4 ಸಲ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ ಅಂತಂದರೆ ಅದು 0.5 into 4 ವಿಚ್ ಬಿಕಮ್ಸ್ 2 ಅಂತ ಅರ್ಥ. ಇದು ಈ ತರಹ ನಾವು ಸಾಲ್ವ್ ಮಾಡಬೇಕು ಈ ಕ್ವೆಶ್ಚನನ್ನು. ಇನ್ನೊಂದು ಸಲ ಹೇಳ್ತಾ ಇದ್ದೀನಿ ನಾನು. ಈ ಕ್ವೆಶ್ಚನಲ್ಲಿ ಏನು ಮಾಡಿದ್ದಾರೆ, a plus b gives rise to products ಅಂತ ಕೊಟ್ಟು ಆರ್ಡರ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು a and b is 1 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಆ ಥರ ಕೊಟ್ಟು ಇದರಲ್ಲಿ ರೇಟ್ ಲಾ ಬರೆದಿದ್ದೀನಿ ನಾನು. ಬರೆದಿದ್ದ ಮೇಲೆ ಏನಾಯಿತು, ಇದು 4 ಟೈಮ್ಸ್ ಇನ್ಕ್ರೀಸ್ ಆಯಿತು. ಆವಾಗ ಇದು ಎಷ್ಟು ಸಲ ಇನ್ಕ್ರೀಸ್ ಆಯಿತು ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. ಪವರ್ 1 ಆಗಿದ್ದಕ್ಕೆ ಇದು ಎಷ್ಟು ಸಲ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ, ಇದು ಕೂಡ ಅಷ್ಟೇ ಸಲ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಸೊ ಇದು 4 ಟೈಮ್ಸ್ ಆಗಿದೆ ಅಲ್ವಾ, ಅದು ಕೂಡ 4 ಟೈಮ್ಸ್ ಆಗಬೇಕಲ್ವಾ. ಸೊ 4 20s are 80 ಈಗ. ಸೊ 4 20s are 80 ಆದರೆ ನಾನೇನು ಮಾಡಬೇಕು, 4 20s are 80 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್, 4 ಟೈಮ್ಸ್ ಆಗಿದೆ ಅಲ್ವಾ, 80 ಅಂತ ಎಕ್ಸ್ ವ್ಯಾಲ್ಯೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. ಈಗ ವೈ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಇಲ್ಲಿ 80-40 ಆಗಿದೆ ಅಂದರೆ ಕಮ್ಮಿ ಆಗಿದೆ, ಇದು ಹಾಫ್ ಆಗಿದೆ. ಇದು ಎಷ್ಟು ಸಲ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ ಅನ್ನೋದು ಗೊತ್ತಾಗ್ತಾ ಇಲ್ಲ. ಇದು ಡಬಲ್ ಆಗಿದೆ, ಇದು ಡಬಲ್, ಅದಕ್ಕೆ ಆರನ್ನು 2r ಬರೆದಿದ್ದೀನಿ. ಇದು ಹಾಫ್ ಆಗಿದ್ದು ಬರೆದಿದ್ದೀನಿ. ಅದೆಷ್ಟು ಸಲ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ ಗೊತ್ತಿಲ್ಲ, ಅದಕ್ಕೆ n ಟೈಮ್ಸ್ ಅಂತ ಬರೆದಿದ್ದೀನಿ. ಈಗ ಹಾಫ್ ಪವರ್ 1 ಇಸ್ ಹಾಫ್, n ಪವರ್ 1 ಇಸ್ n, k ಇಂಟು a ಇಂಟು b ಆಯಿತು. ಈ ಹಾಫನ್ನು ಆ ಕಡೆ ಕಳಿಸಿ r ಕ್ಯಾನ್ಸಲ್ ಮಾಡಿದ್ದೀನಿ. ಸೊ ನನಗೇನು ಬಂದಿದೆ, 4 = n ಬಂದಿದೆ. This is what I get as an answer to this question. Therefore 4 times n ವ್ಯಾಲ್ಯೂ 4 ಆಗತ್ತೆ ಅನ್ನೋ ವಿಷಯ ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಅಂದರೆ n 4 ಟೈಮ್ಸ್ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ, 0.5 4 ಟೈಮ್ಸ್ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ ಅಂದರೆ y ವ್ಯಾಲ್ಯೂ 0.5 ಇಂಟು 4 ವಿಚ್ ಮೀನ್ಸ್ 2. ಇನ್ನೊಂದು ಕ್ವೆಶ್ಚನ್ ನೋಡೋಣ. ಈ ಕ್ವೆಶ್ಚನ್ನಲ್ಲಿ ವಿತ್ ಆ್ಯಂಡ್ ವಿತೌಟ್ ಕ್ಯಾಟಲಿಸ್ಟ್ ಗ್ರಾಫ್ಸ್ನಲ್ಲಿ ಯಾವುದು ಕರೆಕ್ಟ್ ಗ್ರಾಫ್ ಅನ್ನೋದು ಪಾಯಿಂಟ್. ಇಲ್ಲಿ ಎನರ್ಜಿ, ಇಲ್ಲಿ ರಿಯಾಕ್ಷನ್ ಕೋಆರ್ಡಿನೇಟ್, ಇದು ರಿಯಾಕ್ಟೆಂಟ್, ಇದು ಪ್ರಾಡಕ್ಟ್, ಇದು ಪ್ರಾಡಕ್ಟ್. ಇದು ವಿತೌಟ್ ಕ್ಯಾಟಲಿಸ್ಟ್, ಇದು ವಿತ್ ಕ್ಯಾಟಲಿಸ್ಟ್. ಇದು ಗ್ರಾಫ್ ಆಗತ್ತಾ ಅನ್ನೋದು ಕ್ವೆಶ್ಚನ್. ಎರಡನೇದು ಇದು ವಿತ್ ಕ್ಯಾಟಲಿಸ್ಟ್, ಇದು ವಿತೌಟ್. ಇದಾಗತ್ತಾ? ಇದು ವಿತೌಟ್, ಡಾಟೆಡ್ ವಿತ್. ಈ ಗ್ರಾಫ್ಸ್ನಲ್ಲಿ ಯಾವುದು ಕರೆಕ್ಟಾಗಿ ಮ್ಯಾಚ್ ಆಗತ್ತೆ ಅಂತ ನಾವು ವಿಚಾರ ಮಾಡಿದರೆ, ಇದರಲ್ಲಿ ನಾವು ನೋಡ್ಕೋಬೇಕಾಗಿದ್ದು ಕ್ಯಾಟಲಿಸ್ಟ್ ಯೂಸ್ ಮಾಡಿದಾಗ ಆಕ್ಟಿವೇಶನ್ ಎನರ್ಜಿ ಅನ್ನೋದು ಕಮ್ಮಿ ಆಗಬೇಕು, ಜಾಸ್ತಿ ಆಗಬಾರ್ದು. ಇದರಲ್ಲಿ ಜಾಸ್ತಿ ಆಗಿದೆ, ಇದರಲ್ಲಿ ಆಲ್ಮೋಸ್ಟ್ ಸೇಮ್ ಇದೆ, ಇದರಲ್ಲಿ ಕೂಡ ಜಾಸ್ತಿ ಆಗಿದೆ, ಇದರಲ್ಲಿ ಕಮ್ಮಿ ಆಗಿದೆ. ಸೊ ಆಪ್ಷನ್ ನಂಬರ್ 4 ಈಸ್ ದ ಕರೆಕ್ಟ್ ಗ್ರಾಫ್ ವಿಚ್ ರೆಪ್ರೆಸೆಂಟ್ಸ್ ದಿ ರಿಯಾಕ್ಷನ್ ಕೋಆರ್ಡಿನೇಟ್ ವರ್ಸಸ್ energy versus reaction coordinate graph is correctly represented by the 4th option. We shall stop here for today and discuss the rest of the things tomorrow with another chapter called D and F block elements. Probably I'll provide the assignment because the chapter is mostly theoretical. I'll try to send the assignment by tomorrow and we'll discuss the questions in that from that particular assignment only. Thank you.